having a discussion, trying to figure out where you might want to move forward next, or for things like research, obviously not for basically like using something like Wikipedia, basically, oh, where can I find sources for X? And then you verify the sources to make sure that everything checks out. I think something with a lot of these tools were appreciated for having feedback available 24/7. A lot of our participants are independent developers, and some of them are part-time, so they might have weird hours, and they can't message someone at 2 a.m. And expect a response, or they might lose some of their friends. So it's helpful to have something that'll respond immediately. And sometimes something that was really interesting for participants, just the act of talking to something that responded back, whether they used the idea or not, that sort of helped get ideas going. Similarly, representational work, which we define here as basically assets made to communicate with other developers, but that won't be used in the final product. That was also a relatively popular use case. One of the two key examples was that participant 11, who was a programmer, wanted to make better placeholder assets for the artist to base their final work off of, and sort of felt bad about their earlier prototype. So things like Photoshop's generative fill was helpful in that regard for communicating an idea more easily. All right, what wasn't very useful in terms of use cases? So we talked about how asset creation could be helpful for representational work, especially tools that work with the context around the image that gets generated. A wholesale asset creation, quote unquote, from nothing, was not very helpful, even for representational work. So for example, participant 2 would try to create an asset, a placeholder asset, just for a 2D platformer, but might get a 3D model. And then participant 15 talked about, and it was talked about in other ways, games tend to try to express a very specific environment or setting visually. So sometimes even if an asset is high fidelity, if it doesn't fit into the context of everything else, it won't work because then the illusion is broken and it's not quite as helpful. And some participants talked about generating something and then taking as much time to edit that image into being something helpful, and it may have taken, it sort of added work for them. Code insertion, I guess similarly, debugging was expressed. So some programmers talked about how certain aspects of documentation or debugging generative AI tools were helpful for that, but wholesale code creation wasn't super helpful. A lot of games are really large. They can have pretty complicated architectures, so the code might not work in the engine. Something might interact badly with another system that the person who had made the system might be able to see, but it might be harder for something like Copilot to help out with. So so I guess it's a similar idea to the added labor there. So something that was interesting, so outside of the literal usage of these tools and what was useful and what wasn't, a lot of the presence of these tools changed how participants communicated, even those that didn't actively use generative AI. So you guys probably heard of data scraping. Basically, it's the idea of taking data off of public places on the internet to train AI models. And obviously, art is not the only thing that could be scraped, but the context of art being scraped was a common topic. So the participants generally had mixed perceptions on how they felt about data scraping by itself, but most of them had problems with how it was used, if that makes sense. So basically, some artists felt that because if their work was taken and trained on a model and someone made money off that model, it sort of felt like, oh, my work is, my work feels like people are valuing it less and for less pay and stuff like that. And some participants even talked about how, there aren't too many options if an artist has their body of work taken specifically for a model meant to imitate their work. For example, participant 6 actually was okay with the idea of their work being used to train a model because, if a human practiced off of their work, they felt it was similar. But there were specific incidents, like an artist who died, someone afterwards made a model of their work, And in other ways, other participants have talked about, someone saying that they don't want their art being used for a model and then someone maliciously doing so. The way that data scraping is sort of used as an implicit threat also changes how people don't want to talk about generative AI online. So it becomes, it's added a lot of anxiety to online discussions. And the online space is very important for especially independent developers, because that's typically where they reach their audience. Similarly, a lot of participants expressed more distrust in others' work. They had a hard time, some expressed that they had a hard time, they perceived that most images online are AI images, or they would talk about being worried about some of their work, or even an email used in correspondence being mistaken for generative AI. And so basically, and one participant even worked on a larger project, and they had a feature which used, which was designed, basically they used an icon that looked relatively generic, and they got a lot of backlash for using generative AI even when they didn't. So just because not only is there a lot of suspicion over generative AI, people aren't necessarily going to be the best at guessing whether something is or not, and because of hostility created through incidents like the data scraping online, it sort of creates even more of an anxious and distrustful environment. And I guess I went into this a bit with data scraping, but a lot of, especially artists, were worried about generative AI tools making their work have less value in terms of monetary value and also social value. I think some participants talked about how already they felt that they were often underpaid for their work as artists, and they thought that this might exacerbate it, which also increased the community feelings of hostility and feeling like either they didn't want to talk about it, or they, because a lot of the participants that used these tools didn't want other people to know that they did, because they didn't want to be lumped in with the people who maliciously put a dead person's art into a model when they didn't want it, or they didn't want to be seen in the same light as someone who might lie about whether they used a tool or not, because that's controversial in its own way, even if, so I think that also created, it sort of changed, people get secretive or concerned, and they think a lot more about what they say. In terms of both positive and negative thoughts for the future, a lot of participants were thinking about novel use cases that they thought would be helpful that generative AI tools would be helpful for. For example, participant 6 brought up an interesting idea. So let's say, for example, you wanted to make a live service game, but those are very expensive and require a lot of people at the helm. And they also often require players to communicate with each other. But if you have players communicating with each other online with no moderation, that can go very badly. The issue is that a flat word filter often doesn't work super well. And if you're a smaller team, you might not be able to afford 24/7 moderation. So the participant expressed interest in certain LLM model-based filters that might be able to catch context better, because I think with online games, you might already know people can get very creative about saying horrible things without necessarily using swear words. Also, a lot of participants who were in positions to hire junior developers or mentor junior developers were very worried about how this might impact the future state of the career, because a lot of these tools can be helpful for quote-unquote little things or busy work, but a lot of them said that when they were juniors, that was very helpful for them to train and get to the point where they are now as seniors. So they were unsure of how the state of what the skill set of developers might be 10 years from now with these tools, or if the access of these tools change. And also, in a similar vein, some participants talked about how sometimes when you work with generative AI, you sort of similar to someone telling you exactly what to do, it can sort of, some parts of the creative process are being intercepted. So let's say, for example, if you start a sketch from the beginning, you might see something and then add it to the design. But if you generate a concept, you might just draw what the concept is just by yourself. So I think there was some backlash to representational work in that way in terms of career development and thinking of new things by doing every part of that process. Also, mid-level to senior developer participants did talk about how they were concerned since a lot of the place they're working at, or they were seeing less juniors are getting hired, so they were wondering, oh, who's going to be the seniors 10 years from now? All right, so even amongst participants who use these tools pretty readily, they sort of felt pressure. This is mostly a theme that was relevant to AA and AAA developers. A lot of these developers felt pressure to use these tools even more than they already had, even if they had already integrated them into their workflows in ways that they felt was most performant, and that adding any more would sort of add unnecessary overhead and slow things down for them. So there was sort of this idea of, oh, even if I've already added this and this is already helpful to me, since my boss really likes the idea of how this sounds, I'm gonna have to also do this, but I know that this slows me down, or I know that this takes just as much time. So there was some concerns about that. Okay. So what can we do with this information? So, you know, there was more information than just this for the entire study, but I suppose, you know, if I really wanted to generalize, the idea is to sort of, it's good to focus on, you know, if you are in a position to integrate these tools into your workforce, it's good to focus on what's actually useful. You know, what doesn't add more labor, what helps communication between developers where there might not be existing communication. You know, if there are any snags that may be added with integrating certain tools, and like how can that be mitigated, or yeah, so I think just an emphasis on what's truly helpful and what will help the whole team overall. All right, well, I want to say thank you. Well, I want to say, you know, I'm so grateful to every single participant in the study, and I want to say thanks again to the team at the Tandem Lab, Dr. Vishal Sharma, Dr. Pagement, Mirza Babe, and Dr. Neha Kumar, because I would not be here without them, for sure. And thank you all so much for listening, and I think I've left enough time for some questions, but yeah, okay.
Got 8 minutes for question and answer.
Okay.
Questions?
Yes? Oh, sorry. Maybe I should get my eyes checked, because I should be able to read I used to be able to see people's names. Yes, but yes, yeah.
Did you find that there's a lot of pushback just in using it in general? Do you think that's the sort of general sentiment?
Can you repeat the question into the microphone?
Oh, yes. So I got the question, was there just, among participants, was there sort of a large general pushback against using it in general? I would say amongst a lot of participants there was. I think something that was interesting is that some participants that used generative AI tools often would assume that the tool they used specifically wasn't generative AI because they used it. Like, there was sort of a weird, like, I think ChatGPT was a popular thing where it's like, oh, I use ChatGPT, but not generative AI. And it's like, oh no, we're including that. So I think there was sort of a general pushback, and I think everyone sort of has slightly different definitions of what they thought was, quote unquote, what they were comfortable using, and they sort of, I think it is a tricky, because even, yeah, I do think the atmosphere was, there was a general pushback. I think, well, you know, in the opening discussion, it was talked about how, sorry, let me just try to, yeah, I do think there was a bit of general pushback, and that was, and even amongst people who used it, they didn't want to say that they were using it if they were, yeah. Okay. How do I choose? Cause you, okay. Okay. Actually, okay. The light is hitting your name tag, so yes, please, yeah.
I also have a really crappy name tag, so that'll help too.
Oh.
But basically, my question is like, was there a big difference in the reaction between indie developers and like AAA or like AA developers?
I do think
Please repeat the question.
Oh, yes. Oh, thank you. I was asked if there was a big difference in the reactions between indie developers and AA and AAA developers. I think in terms of general reactions, they were pretty even across the board, but they had different challenges or different experiences, if that makes sense. Indie developers, they have to do a lot more self-promotion, so I had to deal more with the online environment themes that I was discussing, and AA and AAA developers, they're sort of at the whim of whatever their publisher might want them to do, or whatever, you know, whoever they're working under might want them to do in terms of integrating certain tools. So that AA and AAA developers sort of may have had different problems depending on who they were, what type of group dynamic they were in. Yeah. Thank you. Oh, yes?
Did you have, so that was like a 2-year study? Is that how long it took?
Oh, so basically, okay, so we started the study in 2024, and then we started collecting participant data, and then the interviews ended last year in May. And then a lot of that was writing the paper and consolidating and theming all the data and waiting for responses and sending out responses. So it's been 2 years since we started. So that's why I mentioned that in the related works. Yeah.
Okay. The reason I bring that up, I was asking, like, I'm curious about like the qualitative, like, there was a lot of, I think, there was a lot of like anxiety there of just like, the future is this big void of unknowns. You did have a couple of examples I liked where it was like, I had an app icon. People thought it was whatever. Like, so in your, how much of that was like actual like retrospective of products that were out there and they had a bunch of feedback versus just the anxiety of the future?
I think if I had to think off the top of my head, I would think some of the anxieties about the future were informed by personal experience they had or someone else had. But I do understand it is a tricky thing with qualitative data, because I think ideas and hopes for the future are like can be helpful data, but it can be sort of tricky to know what's actionable, if that makes sense. Like with data scraping, it's hard because like a lot of the data scraping incidents did cause problems, but it's like, oh, how do you fix someone acting maliciously with a tool? Like it's sort of, you can't, it was difficult to try and think of how we could apply that data. But I do think I think I could have done better with. I sort of picked the quotes that would fit from the themes that would fit on the slides. But maybe I could have been.
You did great.
Oh, thank you. Oh yeah, no, I appreciate it.
This was not a critique of you.
Oh no, I didn't take it that way. No, I'm overthinking it. Thank you. Oh, I think you raised your hand first.
So the sample size was 16, is that right?
Yeah.
Small sample size. And was it all qualitative, or did you have any quantitative questions?
So the survey had quantitative questions, but that was more to help us structure the interviews. Let's say, for example, if on the survey someone was like, "Oh, I'm an artist," we wouldn't have asked questions about like, how was programming for you in the industry? So it was mainly in that way. We did have, like, we collected qualitative data in the survey, but the function was to sort of screen for the interviews. So, yeah.
Do you think if you started it today, you'd get different responses than when you started it in 2024?
I have been.
Repeat the question.
Oh yes, sorry. I was asked if we did this research today, would we get different responses than we did in like 2024 and 2025 when we collected the data? I do think a lot of I had thought about this a lot because the technology changes so quickly. I do think a lot of the sentiment of a lot of the themes would be similar in terms of there tended to be a preference for things that could be easily fitted in to an existing workflow instead of sort of adding a whole extra step and like changing one's routine. But I think maybe things like, you know, if maybe wholesale asset generation or wholesale code generation might be better quality than it was 2 years back. So that is something I wonder about.
Last question.
Oh.
I'm curious whether you used large language models in your work. You took several months to analyze a lot of text that an LLM could have done in moments. Did you think about that?
Oh, I guess oh yeah, I was asked did I use any like large language models to analyze any of the data. I do think well, I that was because of the way we need to anonymize the data, that was not that was not an option. I do think sometimes I do wonder about that. I have used like in the past I've tried out large language models for things like, oh, I don't know I'm reading this research paper, but I'm sort of unsure what this part is saying. And I do think sometimes it can be helpful, but sometimes it can sort of miss the point that I'm trying to get. So I guess in terms of me personally, I wouldn't have wanted to use one of those for the data that I collected because I wanted to. Also, I think the transcripts of the interviews, you know, some people, since I conduct the interviews, I know when something someone said was sarcastic. I know like when someone was making a joke, or like when someone said something and then they said something different. Like sometimes when people talk casually, they might use a double negative, but it's like, oh, I remember them saying that and they meant this. So I think I just sort of, I'd rather I did it, you know, we did it as the research team, yeah, because of those reasons.
Thank you very much.
Thank you. Thank you all so much again.
All right, have to take a quick break, and we'll be back in 15 minutes.
I thought about that last night, and I thought, am I responsible? I should have some notes, but I didn't do it so much. Although there's deep notes in the speaker file.
Yeah, so how do you feel if I ask you to introduce the next speaker at the break? How do you feel about that?
I will do it, but I don't mind it.
Okay, well, I'm going to try to find somebody who wants to do it.
Maybe Victoria.
So any man who comments my writing is worth saying hi to. Palmer, hi. Is it Dove?
Yes.
Hi, nice to meet you.
Good to meet you.
How are you?
Fine and happy.
Yeah, good. Well, I'm excited about this. Compliments my writing? Yeah. Worth meeting.
But not just a man, anybody.
Well, women also.
Okay, I get where you're coming from.
Well, excited. Are you presenting?
No, I'm introducing somebody tomorrow.
Oh,
That's my whole.
just your whole deal. Okay, cool. I'll have to say hi.
Thank you. And I look forward to your session, which seems like it's going to be fun.
I'm hoping it's going to be really a lot of fun. So we're going to get people's brains going and see if I can solve some problems.
Great.
any kind of introduction, or do you just want to jump into it?
I can just jump right in. I can welcome people back if you want, unless you...
Glad to have you jump in, introduce yourself, and tell folks about all the cool stuff at SCAD. I'm really looking forward to hearing how this is going. I was at the, I spoke at the Animation Festival last year where they were introducing
Yeah,
this.
yeah.
So
Yeah.
that was a fun conversation to have.
It's been a roller coaster, let me tell you. So
That part I'm looking forward to hearing about.
can I...
Yes, so go ahead and escape out of that. We just hit escape should get us out of here. Nope. Got you down there. Michael, did you have a presentation you want to put on here? Let's do that before we get the next session going. If you don't mind, we'll get Michael's. Oh, you're just doing it off your computer. Oh, yeah, don't worry about it then. We're good. We're great. Okay.
Is there a frame advantage or just use the keys? Because they'll just
There
require me
is.
to come back and forth.
Let's see. Let's find out. Go ahead and get it up. All right. So allegedly we're on.
So you know Eric Allen, obviously.
Oh, yeah.
Yeah, yeah. Okay, great. Yeah, I tried to get him to come, but
They were bugged them, all of them. Chris, David.
yeah, love those guys.
I guess it works.
Awesome. Perfect. Thank you, sir.
And if you're going to walk around, if you carry the mic with you, do you mind?
Yeah, I'll keep it within, and then I'll be great.
That'd be close to the mouth. That'd be great.
Okay, great.
Yeah, if you're sitting in back and can't hear, please move forward. you already met Dr. LaGrange?
I have not.
Victoria, hi.
Hi,
Victoria.
nice to meet you.
She is just starting the Center for Interactive Media here at KSU.
Okay, cool.
And she runs the narrative design lab here, which is the only one, I think, in the Southeast.
Yeah, I think so.
For game narratives. So he runs the SCAD Savannah program.
Awesome.
So we're going to have Michelle Maton. Do you know Michelle Maton? She was early, one of the very first grad students in the program in Savannah.
Oh yeah, I saw she was giving a
So she'll
presentation
be
at.
on SimFest for us. Legion herself, she works for Axis, so
Okay.
amazing stuff.
Excellent.
She's a good alum, you should form out. Anyway, I'll go turn on this and we'll get going. Grab the microphone if you would, Victoria.
Yep.
Speak into it. You're ready.
Should we just tell people to come back in, or?
I already given the 2-minute warning, so they'll trickle in.
We should just have an air warning. We just pause.
Okay. Hello, everyone. So we're starting back. I'm Victoria LaGrange. I'm the director of the Center for Interactive Media here at KSU that is hosting this Transformer AI and Games conference. And so I would like to introduce our next speaker, who is Nye Warburton, who leads the Interactive Design and Game Development Department at the new Applied AI Bachelor of Design at SCAD. With over 20 years of experience across animated films, TV commercials, and video games, including credits on Monster House, Avengers, and Men in Black 3, he now focuses on preparing students for careers in gaming, AI workflows, and immersive technologies. And today, he's going to talk about Agile AI, preparing game developers for workflows that don't exist yet. Thank you very much.
All right, thank you. Is this on? Everyone hear me in the back? Excellent. All right, I'm going to start this up. Yes, my name is Nye Warburton. My students call me Professor Nye. So today I'm going to be talking about Agile AI. I also want to make a note as my blood pressure drops from my drive from Savannah in the rain this morning. I would like to also say that a lot of this is my own hypotheses, right? I do work at SCAD, but a lot of the things I'm going to talk about today are guesses and things that I've seen and sort of hypotheses that I want to share with all of you. None of this has been figured out, so I'm really looking for opportunities to open up conversations with people because I think that this is a really transformative technology that we haven't got our brain quite around yet. And thank you for having this conference. I think this is a really necessary thing to be discussing. So this is how it started. About 6 or 8 months ago, one of my students raised his hand and said, Professor, what if the singularity happens in class? Which kind of put me under an interesting spot, so I responded, well, I guess we'll pivot. And it's a joke, but the truth is that this is actually what I've been thinking a lot about. How are we going to be dealing with this rapid acceleration in the classroom when education and pedagogy traditionally is designed to be lecture-based, demo-based, apply-based? How are you going to be thinking about these things where the skills themselves are now going into these large AI models? So what does education look like in this landscape? So my response is Agile Classroom, which is an iterative, permanent learning culture of building. And I'm going to touch on all of these things later in the presentation. I'm going to move very quickly because I know we want to do questions at the end with my colleague here. So I'll move pretty fast, but I'm going to be covering a lot of these ideas here. So we're going to start off how I got here. I'm going to go through my past very quickly because it's informed some of my thinking on how to teach. And then I'm going to go into running a game department and then developing an AI curriculum, what went right and what is going wrong, and then Agile Classrooms and the 3 initiatives that I have a hypothesis that we're going to do. So you all ready? Excellent, great. So let's start this. So how I got here, I had 20 years in the industry working. I basically spent my youth playing Lego, and I think that's really been informative of a lot of my work, even in computers. I still see things as modular pieces that you have to put together, and that's formulated my philosophy. I got into doing animation at Monster House, Electronic Arts. I was at Disney Imagineering for a while. At the end of my career, I got really into motion capture and virtual production, and that was my first interaction with machine learning. I discovered a machine learning on a motion capture stage, which I'll cover in just a second. So I have a long career working in computer graphics, 3D graphics, game engines. I do animation technologies, and programming, but now I'm doing game development at SCAD. So previs is the one that I want to focus in on that because I feel like 10 years doing previs taught me something really interesting that I think that we can take a note from. This is from Oblivion, which was a Tom Cruise movie. It's an awful movie, but it was a lot of fun to work on. It's basically virtual cameras in 3D space. If you don't know what previs is, it's a way to reduce cost in production before you get to the actual set. So if you're doing it all in the computer and you're running iteratively in the computer, you can solve the problems there. There's also a mechanism that allows you to pitch to executives, right? So if you pitch to an executive, they're like, oh, that's what it looks like. And so they're willing to give more money. It also is a technical, so you know how far the camera is from the actor, or you know what's going to happen when the bus flips over 3 times before you do it on set. The thing about previs, though, it's based on speed. It's not based on quality. You have 3 days to get something cool out as quickly as possible. So what happens is you drop any of your standards. You get a rig off of the internet. You go to TurboSquid and you find all of your assets. You rip material shaders off very, very quickly because it's all about how do I get the idea as fast as possible. There's also no ownership or final in previs. So at the end, everything I did, I expected to change. This is a really hard mindset to have for most people, especially for artists and designers. They want to have that final product. They want that waterfall mindset where you're going to have that polished thing. I actually think that's a difficulty thing. That's something we need to smash because in order to really work with AI well, you need to be iterative and agile. So this is also a note that this is how I started working with AI before the ChatGPT nonsense came about. I was using ML on a mocap stage. I was helping build a pipeline where we did facial capture. And so we had all these vendors come in, and this vendor brought a facial capture system in, and I was flicking all the different switches. And he said, slow down. You need to wait for the model to train. And it hit me like a ton of bricks that he was talking about AI. That was the first time I had that conceptual thought about AI is going to change everything. It's actually happened faster than I thought, and it's manifested in a way that I didn't really expect. But this was years ago when this happened, and I've basically been falling down the ML rabbit hole since. I transitioned to education in 2020 in the height of COVID. I left LA in COVID, which you can imagine. It's not really a great place to be when you have a family of 2 kids. And SCAD offered me the associate chair job at the Interactive Design and Game Development Department. My boss, Sue-Ann Fu, at the time was running the department, and I took over most of the game pipeline work, doing Unreal Engine workflows. So we have a series of classes developing games in the Unreal Engine. But then when Sue-Ann moved up to dean, I popped up to chair. I took over both the game department and the interactive department. What I thought I would learn is how to teach, but I learned all these other skills, which is manage the department, how to grow enrollment, especially with SCAD, and then curriculum is the product, right? That's what sort of how we approach education, at least up till now, and culture is the secret sauce, which I'm going to touch on just a second. So we're topping about 900 students in our program right now, so we're probably the largest game program in the country. So one of our core philosophies in the game department is we make games. I know this sounds incredibly obvious to say that we're a game department and we make games, but I make sure that every single student knows that their job is to make a game when they come out, right? And it really forces them. You'll know, like if you can force a student to put a game on Steam, then you actually have that badge that you have been a game developer. And so we force them to, and we have a lot of professors who really, really vibe to this philosophy. And these are some of the games that we've made. Sky Strider is on Steam. I'm very proud of that one. Overgrown was a year-long game that we did. And these are both Game Jam games. I'm going to talk about Game Jam in a second. Suck It Up and Inflamed. Suck It Up actually has gained users, and the team is out there becoming, real game developers, doing the things you need to do. And I think it all stems from the philosophy that we try to incubate at SCAD. So This is Skystrider. This is just a couple of moments of it. You can see that we have full animation systems, combat, effects, all that kind of stuff. Very proud of this game and the team. They went on to places like Epic and independent gaming and things like that. A lot of my thought before this AI thing came along was about the digital twin concept. How do we take game engines and apply them to other industries? Automotive, industrial, medical, architecture. So here I was doing my dream job, actually running a game department, going after getting all these different things going, and then all of a sudden the ChatGPT moment comes along, screws everything up. So ChatGPT came along, and the executives, the leaders at SCAD, were not quite sure what to do. And I was hanging out in Montgomery Hall making versions of myself as Pixar characters and joking around and doing stuff. And they said, hey, Nye, can you go explain this to us? So they pulled me into some of our AI summits. We've had a few AI summits. We actually had the most recent one in Atlanta, where we've talked to a number of industry folks trying to figure out what are we going to do, how are we going to adapt, what do you guys think? And from all of those insights, they dropped it on my desk and they said, hey, Nye, help us build a program. So as if I didn't have enough to do, I also had to figure out how to do AI. So I have been balancing both the game and interactive department and AI for the last year. And so now we've kind of come up to the present moment. You can see where we're at. So I'm not going to get into the details of the curriculum, but myself and a number of other people came together to really, really work on what would be the way for us to be able to teach this. And we decided that we created a 3-point framework, which I'm actually pretty proud of because I feel it has some resilience based on first contact. And that is story, action, and impact. Every student that comes into this major has to understand what their personal story is. I like to say that you can't apply AI to nothing. So if you're an architect or an interior designer, you should still pursue those ideas. You're just using AI to augment that. And that's what the storytelling classes are. I actually think SCAD is phenomenally good at storytelling, design leadership, things like that. And so we're just kind of integrating ourselves into what already is working. The action is the application. My hope for the action classes is that while we have all these concerns about the use of AI, you can create classes where it's free to use. Just use it, whatever you find, whatever you can download, just use it. So we're trying to create mechanisms that will allow them to safely use AI in a way to explore it, right? The game program is very against it right now. Most of the students and some of the faculty are, but using AI as a framework for us to be able to use it, we're able to have opportunities for them to experiment with it. And the last is impact. Impact is where we throw all the messy stuff. Environmental concerns, energy crisis, all the stuff, intellectual property, the worries that we have. You'll notice there's a big red line between their sophomore and their junior year. This is the student experience, if you don't know what this graphic is. We're developing an impact test. And I don't want any students to do the higher level agentic design or our capstone until they've convinced, at least me, that they understand intellectual property, cloud, transparency, open source, all those kinds of things that are necessary for you to be able to do the higher level learning. So what happened? We just had AI go on the books. We just started it in January. And so we had our first AI 101 classes. Eric Allen in Atlanta and Nick Dine in Savannah have been teaching this class. The students, the first week, they were all over the map. But as soon as we actually learned their workflow and their pipeline and their prompting, they blew up. And they accelerated really, really quickly. And both Nick and Eric, within a day, around the same time, actually, which was very interesting, they both reached out to me and they're like, what do we do? This is a huge problem. They're already setting up Mac Minis and building OpenClaw agents that are talking to each other. And these are things that we hadn't written and developed, right? So I spent all last summer working with curriculum, developing sort of a classic track of curriculum. And now here we are, that curriculum is being threatened because the acceleration of what's happening with the students, right? So this made me really think, what does curriculum look like when the pace is exponential? So this is what I'm sort of hypothesizing right now. This is what I'm calling the exponential skill classroom problem, which is if in week 3, they're able to go, what are we teaching for the rest of it? What are we teaching as it goes forward? Also, if they're super productive, does that actually account for learning? Are they learning, or is just the AI doing everything? And so I don't know the answers to these questions, honestly, which is why I'm here today. because this is the challenge that we think, and the other issue is that any sort of little bifurcation of some highly performant learners or some lower performant learners is rapidly accelerating. You're getting a small selective of learners that are skyrocketing, and then you have kids at the back of the class who can't even understand what an LLM is, right? So this is the crisis that I'm trying to get ahead of right now. And so we're doing some pivots, and then the next things I'm going to be talking about are all in relation to how do I handle this problem. So I went really quick, which is good. So now I can slow down a little bit. Okay, so here we go. This is the Agile classroom, and these are the 3 pillars that I want to talk about today. So how do we develop an Agile classroom? So I hope you understand the term Agile. Agile is a project management philosophy as opposed to waterfall in the industry. And so most people who are game developers probably run Agile, iterative development. And this is something that we are focusing. We were already doing this at SCAD when I arrived, but I've made it basically front and foremost. Jack Mamias and Cyril Gachard, who run our production, generally do that. So Agile Scrum, the designer mindset, and then the last one is the culture of building, right? So let's lean into Agile. So we've been doing Agile and Scrum for 15 years. We've built a number of games using it, but now we're teaching it and having certain milestones. We're trying to replicate what it's like to be in a game studio. So when students come in, they go onto Discord. You can see that they self-declare their energy, and then they give a sort of self-declaration about what they're working on. They can say, I finished this asset, or I'm waiting for that animation rig, or it's not compiling, or any of those things. We're trying to get them in a process of self-declaration. We also have them doing quantitative predictions on storytelling. In the early days, it's kind of performative. We just have them going through the action. But what I try to do is pull my professors back in the higher levels. I really want them to kind of feel the weight of having to make accurate predictions and then getting it wrong. That's really the hardest teaching challenge, is being able to stand back and letting them to crash into walls and say, well, why did that happen? Maybe you should try to pivot. That's been a really difficult challenge for us to figure out, but I think it's actually an effective way for us to. So we have weekly sprint cycles and student self-regulation. We also try to make all the designers become more producer-like, right? There's sort of this mindset for designers to think that they could just hang out in their sketchbook and come up with mechanics and level designs. But we really want them to be thinking about, like, well, how does that level design work? How am I going to test that? What is the timeline of that? So we're trying to really put that producer mindset in all of our designers. And then that is run through weekly devlogs, stand-ups, and then documentation. So in every class, every week, we have them do devlogs, which means that we want them to record their process. It's usually a disaster when you start. They have no idea how to record a devlog. And so what I say is, what are the top 3 problems that you're working on? And then write those 3 problems out. How did you solve those top 3 problems, right? Did you go to YouTube? Did you ask your professor? Did you ask your neighbor? Did you try something out that didn't work? Put it in your devlog. And I want them to record those things, and we keep it in a Dropbox that's accessible to the entire class. Because if they've solved something, they found that YouTube series, that is a value to every other student in the room. And so instead of me keeping up with every animation update that happens in the Unreal Engine and MetaHuman and whatnot, they are doing that work, that heavy lifting, and they're going through those quantitative predictions, and they're recording their process that becomes a resource for them to be able to move forward. As a result, we've integrated a full pipeline, which I'll talk about in just a moment. So teaching the art of the sprint. I would say this is my biggest and most adamant focus right now, because I think that the only way that we're going to be able to go through an acceleration period is by using these sprint cycles. The designer mindset of guess, test, measure, and record, right? So when I got to SCAD, there was a large number of students that didn't want to touch the engine, which I was kind of questioning, why were you in this major? So now I force every single designer to functionally prototype, even if they're bad at it, right? There's no reason that you can't take a starter template and break something and just get your concept into that engine. And so we force every designer to go. We're trying to develop a series of heuristics that allow them to basically functionally prototype in every single engine. It's not a matter of how much they build, but how many ideas they validate and record. So, and all this has also been validated by the industry. If I can kind of paraphrase what I hear mostly of what you're looking for, they're like, give me a good kid who can pitch me an idea, go back to the engine, iterate it, and then come back and then pitch that prototype to me. And so we're trying to cultivate that mindset that everybody has to be able to prototype. Now, developers are a different story. It's a little bit more complicated, but designers is what we specialize in. We want them to have that technical grit to be able to build. Right, and so there's a culture of building, and this is a big one. Am I doing okay on time?
You've got 12 minutes.
Great. This culture of building is game jams, right? So when I came, I made a really big deal about the global game jam. We do a number of design sprints. So the global game jam, when I first came chair, we broke 200 participants. We made 20 games and then Inflamed won first place. So the underclassmen were so upset at the upperclassmen that they crushed it and they crushed them, that the upperclassmen then gave mentors and created Noob Jam. And Noob Jam was a wild success. I mean, I didn't even do anything. The students self-created their own farm team, basically. And so with Noob Jam, we had 60 participants, 18 mentors, but these are students who had never touched a game engine. And we forced them to do it in 48 hours, and they did it. I wouldn't say the games were great, but it got them in that culture of mindset and building. And then we had the next game jam where we had 266 register, and then Suck It Up came out of that one. And then we did a Noob Jam again, which we doubled the participants with 22 games. And then we recently had our global game jam where we broke it again with 306 registered and 30 games. It was snowing, so we had to do our award ceremony outside. But this is the culture that I really, really believe is critical to the success of our future. I'm big on t-shirts. I'm big on pizza. I'm really big on trying to create a way for them to get together and build together. And this is the result from last spring. We had 14 games playable on beta day. We forced them to have playable games on beta day. And I think this is largely not because of a curriculum that we wrote, but because we have a framework that we're iterating rapidly. So with this context in mind, let's return back into AI. First of all, I want to do one note. Interactive was another, the interactive side of the program tended to be more Figma-based and UX sort of focused. We thought this was a great opportunity for us to kind of reboot the interactive side. And so we're doing a lot of Unreal Engine on the game side, so we decided to use Unity. And I think they're here today, which is great. So Unity, we invited Unity to this hackathon. We also got Johnson & Johnson, and we built medical products using the Unity engine. Same kind of thing. We had 8 digital products, and they met with investors, and then even Johnson & Johnson hired one of our immersive reality students as an internship at the other side of it. So it works for curriculum development. This kind of rapid prototyping jam culture that we build actually works outside of games for product development. So the hypothesis, could this also work in the AI major? And so that's what I've been sort of moving to. So our hypothesis is that weekly Scrum is in the classroom. So we run a Perforce, which is a version control pipeline underneath, and we now have, that's actually grown in use. We've almost tapped out our Perforce licenses, which means that we have a lot of the students understanding version control, pushing updates, regularly going, doing projections. And the hope is that students will learn to pivot, not panic. A lot of they come in, they've been trained in this mindset of they say, can you show me file open? Can you show me the next thing? And we're trying to smash that and say, no, you tell us what the next thing is. You tell us where to go, because they really need to be in the driver's seat. And it's painful, and you have to hold the line, but I think it's important for our students to be able to learn these skills in order to iterate. So this is my struggle and my hope. I think that we've effectively got the framework of an agile classroom, but as we were talking before, tools and compute and industry problems have not quite been developed yet. So the industry does not know how to integrate AI into their workflows. They're all trying to figure it out. Also, there is a million AI tools. Everybody has a different option. You know, do I use this one or do I use that one? Am I going to use with this brand or that brand? We're not quite sure. And then also the issues of procurement and all the difficulties of trying to be able to update the engine on a regular basis exist in our pipeline. So is it possible to create a safe space for the students to experiment, right? Because we don't know what these things do, and we're going to have to find ways for us to be able to put them into a sandbox and say, I don't know, You just go, right? And so this is the largest challenge that I'm trying to figure out is how do we move away from that scripted, very structured, very safe environment into a place that has sort of contained edges to allow them to iterate in a sandbox internally. Will it work? I have no idea. I really, really hope so. But as you can see, I'm already starting to pivot, right? We're kind of like a startup within SCAD, which is why I have to say that this is us. There's a small gang of us who are in the game department and the AI, and the fledgling AI department. I just hired my first AI professor. He's a painter. And I will make a note that I went through an interview and I interviewed maybe 12 people who were all cloud architects and solutions, this and that. I finally found a painter who was very obsessive about utilizing AI. I thought that was interesting that an artist had the most sort of insight in its use as opposed to a technologist. So we'll face things we can't understand, but we'll still want to create and we'll need to sync. So we should set our watches and then figure out what the next step is and then jump to the next deliverable. Did it work? Well, let's keep doing it. If not, let's pivot. And we'll need to jump into the unknown together. So that is my talk. Again, my name is Nye Warburton. This is my website, nyewarburton.com. I also blog every week because I want to think in public, kind of like what I'm doing here. I really want people to tell me where I'm doing it wrong. And so if you want to go to my website, go to my blog. All of my thoughts are there. I also keep my blog on the blockchain, which is another talk for another day, because I am desperate to figure out what intellectual property is going to look like in the near future. Maybe we'll talk about that here a little bit today. Again, you can reach out at nyewarburton@gmail.com. Thank you so much for your time.
Thank you so much. So now, moving on to our next presenter, Michael Houk, who is a 15-year veteran educator, family and consumer science teacher, and esports advisor at Rockdale Virtual Campus in Georgia. He began teaching virtually during the COVID-19 lockdown and has taught at every level from preschool through high school. He holds an AS in Education, BS in Bible and Preaching, MS in Education, and an EDS in Workforce Education from the University of Georgia. And today, he's going to talk about gaps in AI CTAE pathways in Georgia. Thank you very much.
Thank you. So if you could please go to join.nearpod.com. On your cell phones, join.nearpod.com, and UBN5S is the code. UBN5S is the code. And we're going to piggyback off of what Professor Nye just said, okay? So if I can do this here, there we go. So I'm Michael Houk. I'm a public school teacher in the University of Georgia. And oh, I'm sorry. Join.nearpod.com. Okay. I don't have the cable. Nah. This is just the HDMI cable.
Right. You
Got a Mac. Yeah.
Uh-oh. You don't have a Mac adapter? I don't have a Mac adapter. Is there one?
I've got one at work. Yeah.
And we got a Mac adapter with them? Mac HDMI?
Oh, yeah.
GSU, come to the rescue.
Join.nearpod.com and UBN5S. Are we still not up? Yeah, it's not.
Did you press the HDMI button on that little screen there?
Where's that HDMI button?
Try that one.
Choose the mirror. Where's the mirror? Choose the
Oh, wait, here we go. Allow. Start mirroring.
Yay.
There we go. There we go. Okay, cool. Sorry about that. So the code is also up at the top right there. And I am Michael Houk, and apparently I don't know how to connect my laptop to a projector. So, just like at work. So I'm a public school teacher. I love teaching. And what we're going to do is run through a lot of these slides very quickly. And then we're going to get to work because we're going to piggyback off of what Professor Nice said. So let's see if, man, I'm just killing it today, aren't I? Look at this. There we go. Okay. The best thing about CTAE, which the rest of the country calls CTE, is that I give students access to different certifications. And what I teach is a food nutrition wellness pathway. Now, this is really important because this is going to help us in a few minutes. I teach the food nutrition pathway, and our certification, our industry certification is ServSafe. So my students can roll out and they'll take a ServSafe test, which you can go to that website. In fact, if you go to a restaurant like Tin Lizzie's tonight, you might see up on the wall these certifications. That's what that is. Somebody took probably a class like mine and got a certification. This is where the gaps in AI and game development come in. There's not a certification process, or as Professor Nye mentioned, curriculum that we as public school teachers can use to help prepare our students to go become Professor Nye's students and be successful in that atmosphere, in that arena. So, bad news, lack of industry certification. There are examples of school systems working on this. Now, this is something you may not know. A lot of people apparently don't know this. The United States does not have an education system. Did you know that? Hang on. Yeah, agree, right? Well, hang on. So think about this. We are actually a nation. We are the United States, and each state has its own education department. And inside each state, there are hundreds of different school systems, and they all have their own school board. And each school board hires a superintendent. That superintendent hires a curriculum instructor or developer or whatever. And so you have all these little fiefdoms all over our country that kind of don't agree on how to teach math or science. This is where CTAE is different because we have industry certification like ServSafe, where the restaurant industry says, we are the restaurant industry. If you want to work and be successful in our industry, you have to know not to sneeze on food. Right? Same thing with AI and game development. There needs to be somebody that comes along and says, hey, you're a high school student, you're interested in this, we're going to create a pipeline and pathway for you to get some basic certification. That way you can go to SCAD and really, or KSU, and start developing games or software or whatever you want. Here are some things you guys can go through later. I listed some curriculum frameworks for AI from Florida and California. For Georgia, I think that the best thing is we need to have components and that are attached to purposes and outcomes. In public school, we have educational standards. So and here's the thing, each state has its own educational standards. Even in the state of Georgia, Gwinnett County has its own educational standards that are separate from the rest of the state of Georgia because, of course, Gwinnett County has its own standards. But these components have to be connected with purposes and outcomes. So Georgia has Seckinger High School and Denmark High School. They do have fully functioning AI programs. Now, I couldn't really access a lot of their curriculum and stuff, but I work in Rockdale County, and one of my good colleagues, Jesse Smith, is going to develop AI software. We're going to start an AI pathway in Rockdale County in the fall. Now, the problem with that is we're going to have those kids, those students, go through these classes, and he's going to have to like develop all the curriculum, all of the organization, all of that. Like, he's got to do it. He'll probably research like Professor Nye and MIT and all these other things, but he's got to build it because we don't have curriculum directors that will approve everything because there's just not a lot out there. Does that make sense? So my good friend Jesse's gonna basically do it all on his own. Like, and that's part of the problem. The other problem is once they finish taking these 3 courses, there's no industry certification like there is for ServSafe. Because if you go on the ServSafe website, there is industry certification for being a bartender. Like, there's industry certification for being a food handler. There's industry certification for being a food manager, okay? And all of these are important because they teach people to not get us sick when we go to eat at Tin Lizzie's tonight and we're all eating chips and dip. Like, somebody's taught people there, the manager has to take that test, okay? We're gonna skip some of these. There's some research. There's a lot of research. If you guys like nerding out like I do, there's a lot of research, but this is one of the best things. Kashif et al. Says, our preliminary assessment model identifies 4 main dimensions. The first is equity, the second is sustainability, third is appropriateness, and finally scalability. And this is the model that they came up with that I really like. Again, this is a preliminary model. And that's ultimately what the issue is. Everything's kind of preliminary, right? Because our technology is moving so fast that we as educators can't keep up with it. There's no industry certification saying, if you're going to use AI in game development, this is what you need. These are the rules you need to follow. These are the ethics you need to have, right? This is how intellectual property needs to work, and nobody's really developed that. Which gives me a sad face, okay? That's sad, Michael. By the way, I have a Waffle House flag in my classroom. That's how Atlanta I am, okay? So if only I had a captive audience that could help create a framework for entry-level industry certification in AI and games. Oh, wait! I do have a captive audience. It's you guys. So this is the challenge. You guys can get into pairs and groups, whatever. You can do it individually. I don't care. And then I want you guys to start developing frameworks, or as we in the public sector would call educational standards, of things that you want high school students to be able to master so that when they go into KSU or Georgia Tech or SCAD, that they can sit there and say, hey, I did this, I know what I'm talking about, and I'm prepared to go to the next level. So you've got 7 minutes. Ready, set, go! And once you're done, you guys can post your thoughts on this amazing corkboard, collaboration board right here. Now I'm going to have a sip of water. All right, our first comment is somebody said they should be able to program a simple platformer. What did I just do? I just touched it. signal. Plug it in. Unplug it, plug it back in.
Still on HDMI.
Yeah. There it
Hey.
goes. Yeah. I touched it. It fell apart. All right. Joseph said complete global harmony, logic, imagination, health. I like that because that's definitely lacking, like, really across our culture, right? Like, demonstrate understanding AI ethics. And this is an important thing, but we also got to figure out, like, how do we define those ethics? Like, we have to somebody's got to come along and define that. Students have computer science fundamentals. Neural networks actually work, okay. Prompt engineering. What does that say? Understanding intellectual property is a real serious issue because Georgia's, I think, passed a law saying if you use AI, it's not yours. So that's also an issue. Yeah, you guys will learn from, I think, Aaron later on. Like, I'm trying to get my kids into developing games, but there's just such a disconnect of how much work that goes into it. Yeah, camera angles. All right. 2 minutes, 2 minutes, 2 minutes. Joseph Davis. I don't even know what that is. Is that divine reasoning? Is that like God talking to you? like, yes, Lord? Like, Ghost in the Shell? Is that? Did you watch it? All right, 1 more minute. Then we're going to finish up. Antoine. Nice. Yeah, if they can't do it on their own, like, we need to pause and kind of take a step back. Like, these are really good, guys. Understand how it works. Using AI as the tool and not how to get the finished product, that's what I'm trying to teach my students. And I've done that with research as well. I love ChatGPT for research because you can just say, give me AI, peer-reviewed AI journal articles that are accessible to the public and or not behind a paywall. And so now you can go and access, and it'll just give you a list. And it's great. Or you can look up the best thing. If you love research, go to ChatGPT and ask it, who has published the most papers on artificial intelligence and game development? Like, and then it'll give you like the top authors and research scientists that have done that. So, all right, you guys can keep putting stuff up here, but we're going to move on. Look, I went from sad face to happy face because of you guys. You did it, guys. So, and that, yeah, give yourselves a round of applause, okay? So, ultimately, what we need to do is figure out, like, as Professor and I was talking about pivoting, the government doesn't like its employees to pivot, okay? They like their employees to be robots. And the best teachers aren't robots, they're people who pivot. And that's really one of the issues is how there's this inherent issue of the government, which it's okay, has to have a standardized, this is what we teach, these are the educational standards, this is why we teach it, go, right? And then they can move on to being able to experience the singularity in Professor Nye's class. So that's all I got. And at the end, if you click on that link, there is a whole bunch of research articles for you to purview at your convenience. Thank you very much.
Thank you so much. We have 15 minutes for questions. We have about 15 minutes for questions for 2 speakers. So please go ahead and raise your hand if you have any questions.
So having served on curriculum committees for Georgia DOE on game design curriculum and esports, one thing that was drilled into our heads is that we cannot have a baseline for teacher ability. We can't guess that the teachers will have even the most basic Unity certification. So how do you get around that? What do we need the teachers to know in either of these cases to either prepare students for a certification or to get them into SCAD?
So what do we need teachers to know to prepare students the best way?
I think really it's got to start with the industry, people like you guys in this room, telling the government, the state government, what teachers need to know. Especially when it comes to AI and ethics. You guys, this is why having some sort of certification process, industry certification process is so important. Because once we have that, it legitimizes video game development. It is amazing. There are people right down the road for the Georgia Department of Education. They don't even know that esports is $1 trillion a year industry globally. And so they think it's just kids goofing off playing video games and not developing career skills. Because all the skills you guys posted on that board, those are all transferable to other areas and other industries. So video games is just really a launching pad in a lot of ways. You could go on to make movies, TV shows, like all sorts of stuff. So, yeah.
So I don't know about standardization, but I definitely think that any teacher who's going to teach game development should feel comfortable in an engine environment and whatever the engine environment evolves into, and they should be able to work with version control and all that. So I don't know if there's sort of heuristics that we can kind of do on that technical aspect, but I really think no longer can we just teach game development from a point outside. I think we really need to be very hands-on. So every teacher really should be in engine for sure, as I say.
The other issue that's inherent in CTE or CTAE is that why would somebody go and teach high school students or middle school students for $40,000 a year and deal with all of the bureaucracy and all of those headaches and writing bathroom passes and stuff like that, and having to go also coach sports and do all this other stuff when they can go make 4 times as much like doing industry. And it doesn't matter even like what CTAE program they're doing. I've got a friend that's an engineering teacher. He has a doctorate in I think it's physics, and he was a physics teacher. Then they had to move. He was the only one certified, kind of goes back to what Andrew asked. He was the only one certified to teach engineering. So they said, guess what? Your job is in that classroom over there. That's where your paycheck is. And he had to go and become a CTAE teacher. And he likes it now, but somebody made a comment. It's like, oh, you guys make Christmas ornaments. That's cute. He goes, look, I can walk out this door and get a $100,000 a year job before I get to my car. I'm here because I want to. Like, and that's the thing with CTAE teachers. That's why it's really hard to keep them. Any other questions?
Oh, I'm curious what Nye saw in the artist. What particular skills he had that other AI, that more specialized AI professionals.
Can you repeat that again so I can?
The professor whom you hired.
Yes, is an artist. Yes.
What did he see in him?
What made him hireable versus an engineer, essentially? I mean, I know it's creativity, I guess, is the only way to say it, which is that he wasn't sort of stuck in one process. He was sort of looking at a way to be able to manifest an emotional experience at every time. He was a really great storyteller. He never looked at AI as like, I'm going to train it and he looked at it as like, I gotta tell that story. It was all the function of how do I create a better experience. An artist, right? And an artist is somebody who really thinks about experience. They don't think about tools. So I think that there's sort of a mindset. We just talked about what the heuristic is to have like, a base, a technical base, but I really think having that storytelling capacity, that artistic mindset is a really great skill that just is important to have.
Here's a question for you guys. Are we in the creativity? Are you guys in the creativity game? Or are you in the development game? Like, cause that's what I'm trying to teach my students is a lot of them have really cool ideas, but they don't know how to like take that next step. They're creative, but they can't get to that next step.
Without development is a fantasy.
Yeah.
Development without creativity.
Yeah, it's like
There's got to be there's got to be a connection, right?
Yeah.
Okay. Next question.
There was a couple questions over there, and then.
Yeah, so I had a question kind of related to the like staffing, professors kind of thing. This is going to sound inflammatory. I do not mean it this way. But back when I used to teach in university, one of the defining traits that I thought of other people in technology was that they didn't want to learn anything new anymore. They taught the same curriculum every year.
Yeah.
And the reason I ultimately left being a university instructor was because I was so frustrated trying to get us to update curriculum and do new things. I guess these tenured professors who just couldn't be bothered. So given this information of like AI and how it's changing things, are we going to be seeing like a workforce problem? And are we going to have a problem where the same types of forward-thinking, evolving people who can teach are also the ones making money in industry, so why would they teach?
Yeah.
I can jump to that.
Yeah,
if you
jump
want.
to that. Yeah.
Repeat the question. How do we
How do we keep the skill development in our educators up to speed? And also, I mean, part of the problem, the first hurdle we have to get over is there's such a backlash against AI. Many of them don't even want to go there, right? And that is a problem. And what I have discovered, and that was my error, I was like, we're going to put you in a workshop and we're going to do this. And there was such a backlash that I couldn't make that manifest. However, when you say to a bunch of modelers, hey, modeling is probably going to be disrupted by generative AI, they don't want to hear that either. But when you say, I want to use photogrammetry and scan this and try to find these new workflows and, oh, look how cool it's in the engine and whatever, if you try to motivate them the same way you do students to do new workflows, it's that mindset of trying to create another design sprint, another jam, another project, another way to motivate them. I spend most of my time, and trust me, I completely agree with what you're saying. I feel like we need to motivate people to try new things and explore new things. And I think the industry can come to us to help that because they are also in these problems. What I've discovered is that all the issues that I'm discovering or that we're discovering in the classroom, the industry doesn't know how to put AI in, right? A company that's on lockdown doesn't want to have its data leaked, and so they don't want to have anything inside, so they don't want to have new tools, and so they're trying actively to stamp it out. So when you find that person, that design leader, who was like, we desperately need to figure out how to do this, you form an alliance with them and you try to get those really cool projects going. So the photogrammetry and the Gaussian splatting is the example that I've been using to try to motivate my modelers who are absolutely against AI and they're worried that their modeling skills are going to go away, which they might, but if you can evolve them and say, look, these skills, these engine workflows are still relevant, at least for a certain period of time, try to motivate them in that way. But I do agree it is a crisis, and it's part of the reason why I'm here, to try to get people to sort of catalyze the conversation.
And that's also like from workforce development, that was the whole purpose of CTE, the creation of CTE and CTAE courses by the United States government, is so that we could feed and create a pipeline to fill those spots. And now, like, the reality is everything's just kind of moving so fast, we can't teach it, and we can't, it's a lot.
I do have one thing to say, though, is if you can get them over the hurdle, I don't know how you feel about this, and maybe this is going to cause a riot, but I think we're going to be speaking to the engine in English in six months. And does that mean that that student that always wanted to make a multiplayer, I don't know why they all want to make multiplayers, but that student who wants to do that, you know what? You're going to have that technical ability. You're going to be able to make that dream project, right? So there's no excuse for you not to get in there and do it. And maybe not everybody's going to go with us. So. Well, for me, it is having industry game jams or industry jams valuable to the industry for their exploration and then the development of AI and things like that. From my perspective, I just showed you the demonstration for our interactive program that we rebooted by partnering with Johnson & Johnson. They are doing all this XR stuff with Unity. We wanted to do Unity. We think that medtech is a way to go if the game industry is going through its whatever it's doing right now. So that's why I think that was really valuable for us in terms of curriculum development. I think the problem is that a lot of people think that you just need to have a weekend and pizza in order to have a game jam. And it actually took us maybe 6 weeks of serious hard work of research to come up with a prompt, working with the medical, with a whole bunch of mentors in order to carefully craft that. So it's not just, hey, go make something. And I think that's the biggest problem, is that people are seeing this jam and hackathon mindset, and they're just getting the computers and the pizza, but they're not actually putting the effort in to be able to create real outcomes. You should look at it like we are going to have a dedicated sprint to solve a problem. And if the industry can identify that problem, yes, it's an enormous value. But the problem is they don't have the capability often to be able to identify that problem or specify that problem. And I spend a lot of time saying to people, what is your problem? No. What is your problem? Because I think they come in and be like, look at all this AI. And I'm like, that's not what we want. We want actual tractionable issues to solve. It's a good question.
If I'm understanding your question correctly, are you suggesting like there are games intentionally created to help kids learn academics? Okay.
But they've not been particularly targeted at students or academics. And so the question is like, is that something, from your perspective, having run them, is it valuable to even attempt that bridge, or does that just get more complicated by trying to do both?
I definitely think the game jams, the ones I've gone to, have all been amazing. Put on by Andrew and others. Like it's fantastic. It's a great learning experience. I think from an academic standpoint, we already have the tools to teach academics with just the games we've got. So for example, if you want to teach physics, let them play Gran Turismo and go into the settings and start tuning the car, and now all of a sudden the physics change, right? It's like we've got kids that can't find north on a map, but if they can find north on Grand Theft Auto San Andreas. You know what I'm saying? Like they understand the concept. We just got to meet them where they are, and that's why game development is so important, because it meets them where they are. So yeah, next question.
Last question. Savannah that have this whole pathway set out, and it's like kind of unequal. So do you plan to kind of spread out?
You want to start? Go ahead.
Yeah, so CTAE, if you do a lot of research with CTAE or CTE, a lot of it's regional. So if you go towards Savannah, you'll have like the construction pathway, right? But in downtown Atlanta, you might have a public school that doesn't have the construction pathway, but they have an AI pathway. And so it just kind of depends on superintendent and what the trend is, but also what the people want and how they vocalize like, hey, but there's also money. Like you gotta have rigs, you gotta have computers, you gotta have logins, you gotta have subscriptions, you gotta have all of that stuff, and it's all gotta be approved in schools, which it can easily be if they want it to be, but there's a lot of gatekeepers in the world, man. Like
So this is something that I'm actually very interested in doing more of. My first frustration, I actually mentioned this to Andrew, is that I spent all my time and labor cultivating these game developers, and I've got them to a point where they're doing beautiful things, and they went to Austin, right? And I really want to keep them here, and I want to build it here. And I think that if we can create more of a game culture, certainly in Savannah or Atlanta or in places, but also outwardly, there are some initiatives that I'm very interested in. I'm going to shout out to the Middle Innovation Corridor of Macon. I don't know if anyone is involved with that, but the Museum of Aviation is building all kinds of stuff with students in game development. They had a grant, and they're also trying to seed that into different local areas. I think that we have to be active to try to get whatever these funding mechanisms are to seed these places, because I do feel like they're kind of dying on the vine. A friend of mine got a grant to put game development into sort of the middle of Georgia, and he couldn't get Unity on the machines because the infrastructure just wasn't there. And so this is a huge challenge. We probably really should be thinking this way. But if we're producing game developers here, we should be sending them here and setting up businesses here to then propagate that knowledge to everybody else. The more game development we can actually do here, my hope is it will seed more opportunities outside of those like more heavily trafficked areas for sure.
Exactly. So we're now leaving Georgia a little bit. Virtually.
I'll give you a 3, 2, 1.
Okay.
Let's wait till he gets the image up. That'll look better.
Do I have a mic, or is it?
It's not for the room, it's only for the live stream. Victoria's got it right now. So again, if you're in the back and want to hear better, there are lots of seats up front.
Do I look like a quiet kind of person to you? Maybe.
All right, wait till the presentation. Keep going.
Cool.
Perfect. Awesome.
All right,
Okay. Thank you. So we're very excited to welcome our keynote speaker, Julian Togelius, one of the main specialists of AI in games. So Julian Togelius is a professor of computer science at New York University and co-founder of Model AI, which develops AI methods for game testing. He has researched the intersection of AI and video games for more than 20 years, contributing methods for procedural content generation and player behavior modeling, as well as the general video game playing competition. He argues that the absence of AI in actual gameplay is a design problem, not a technical one, and that we need to design games around modern AI capabilities. And today, his keynote is going to be about where are all the AI-driven games. Thank you.
Thank you, Victoria. And you can all hear me? Please put your hand up if you can't hear me. I apologize in advance. I am not really at my best today. I'm feeling a little bit subdued. Also, my eye is like, I promise I've not been in a fight yet. There's something else that's getting to me.
Also, Nai, who was just up here before me, he said at some point that, you know, you can just ask ChatGPT who has published most papers on AI in game development. Did anyone do that? No? Yeah, it said it was me. How did this happen? How did I get here? What so who am I? I am from Malmö, Sweden, where I grew up, and I went to high school, and I finished high school, even though I almost failed maths. I hated maths, and I thought it was terrible. I wanted nothing to do with it ever again. So I decided that I would understand the mind. I would understand what is intelligence, what is consciousness. So I started studying philosophy, as you do, and psychology. Now, I mean, philosophy is, I love philosophy, but it's very, 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 very slow. Someone comes up with a brilliant thing like once every 100 years, and I was too impatient for that. And psychology is a good idea, but it doesn't work. I'm sorry. I'm gonna get into a fight today. Maybe my other, the tools are not good enough, you know. So I needed to understand the mind to be able to understand. I need to build minds to understand them. And even though I discovered that, even though I still sucked at maths, I still do. I still don't know very much at all. I had taught myself programming and realized that programming had nothing to do with math. So I gradually segued into computer science. Isn't it great? I'm making so many enemies already. I'm like, why am I in this mood today? I'm gonna get into many fights. So and I wanted to do biologically inspired artificial intelligence. I went to England, to University of Sussex, where I got all hooked on like evolving neural networks for controlling robots. And then I went to University of Essex for my PhD, so I just changed sex. And there I discovered that I didn't have the patience for robots either, because robots are really slow and they break down all the time. And look, like, depending on what time of day you have different light coming in through the windows, so the sensors don't work, or, oh no, the tires are hot, so the robot's performing differently. And I wasn't interested in all that. I'm not really interested in the physical world. Or math. So I sort of realized I could do the same thing in video games. And back then in 2004 and 2005, I was like, what if I can evolve neural networks to play racing games? So I did. And it was fun. I went to conferences and people were like, oh, that's cool research you're doing there. That's really fun, you know. Oh, you get a paper out of it, nice. But where's your real research? This is my real research. Oh, and they look at me like, man, this guy is not going to have a career. Basically, I worked for a bit in Lugano in Switzerland with Jürgen Schmidhuber, who, anyone know of Jürgen Schmidhuber? He's the closest I've been to working with someone who's actually a genius. And here I'm implicitly insulting everyone else I worked with, sorry. But it's, the guy is fantastic. He also has ego the size of the Hindenburg. And causes, he's famous and maybe infamous. I try to learn the right things for him, not go around and pick fights with people. So somewhere around there, I realized that you can use AI to play games, and that's interesting, and that's great for testing AI methods. How about flipping it around and using AI to improve the games? Can you use AI to do game design, generate levels, generate other content, generate quests, maybe the game rules themselves? And I did some early papers back when nobody thought this was a reasonable thing to do. I remember in 2008, one of the papers that kind of founded a field, kind of, I had like the response like, oh, is this a proof of concept paper? Yes. What's the concept? So that was fun. Yeah, so I do AI for game playing, and I do AI for games and games for AI. And I also started a startup on game playing and testing, which is going all right, and another one on trading, like stocks and crypto and stuff, which is basically just game playing anyway, and that's going better. I love games, but the game industry, no. So, okay. What am I not talking about? This talk is not about production pipelines. This is not about like whether to use Stable Diffusion to generate your assets or whatnot. And it's not about intellectual property rights and everything like this. This is a big can of worms. These are somewhat tasty worms, but we're going to avoid them today. We're going to talk about completely different things. I'm also interestingly not going to talk that much about my own research. Almost not at all. I'm going to talk about other things. Mostly this is one long argument, and I want your feedback. And I also want you, because I have fewer slides than usual today, please feel free to just interrupt me at any point, you know, and argue back at me, so on. My friend Tommy Thompson, anyone follow or have you seen the AI in Games YouTube channel? Tommy and I, we met back in 2007 or something, and then we've taken slightly different paths. He's the guy on YouTube. If you find someone talking about AI in games with a strong Scottish accent, it's him. He's the one. That's not a strong Scottish accent. If you ask him how he actually speaks to his old friends, we grew up with, I mean, he will speak a kind of English that you will not understand. But yeah, his videos are great, and he runs other conferences and so on. This is his, it's a little bit out of date, the 2024 edition of How Artificial Intelligence is Used in Video Games. So looking at AI for the player experience versus AI for game production. I think very many talks today are like here. Hey, art pipelines, animation, quality assurance. The company I founded is kind of here. And then basically AI that plays, AI that creates, AI that models. I've done a ton of work in the AI that creates sort of genre, procedural content generation, procedural rule generation, whatever. I've also done a decent amount of work in AI that plays, and a little bit in AI that models. But I just wanted to orient you. When you come to a place like this, and you talk about AI in games, people are like, oh, here is where it's at. If you come to an academic venue, like here is where it's at, they will like, oh, it's AI for playing games, and they use it to test various methods. But the actual field is pretty wide. There's a lot of different things. Okay, so we're gonna stay mostly up here, kind of. With some exceptions to come later. Okay, statement number one. Games were designed around the lack of AI. The reason that most games do not feature runtime AI in any kind of interesting manner is that they build on design conventions that date back to when there was no AI that we could practically use. Yeah, the concept of frozen accident is that someone shows something and then it basically stay there. There's this long story about how the dimensions of the Roman chariots basically influenced basically the width of European roads, which influenced the original design of the first railroads, which are 1,435 millimeters almost everywhere in the world, and that in turn influenced the Apollo rocket and so on. It's a frozen design accident. It could have been something else, and it's just like, you know, it keeps influencing history. But you know, the games we play, the games we play today they build on such a history of game design and so many conventions that people came up with back in the 80s and 90s. So for people who are less old than me, honestly, this room is kind of interesting because it's a pretty wide spread of ages. I am so used to these days going in and being the oldest person in the room. I'm 46. It's weird, but yeah. This is what a computer used to look like. This is a PC 286 that was like state of the art in 1987, 88. And this is the original Nintendo Entertainment System. This is what a game console used to look like. This one had 640 kilo of memory, but basically not much of a graphics card at all. You basically had to torture it to get graphics out of it. And this thing had like, how much RAM did a NES have? Like 4K memory or something? 4K, yeah. And there we go. and a 1 megahertz Z80 processor, or Z80 compatible, I think. And this one had like maybe 16 megahertz or something. Or maybe the first was 10. I don't know. But anyway, this is like I don't know. This computer has 96 gigs of RAM, which is kind of a bit much, but you know, commonly you have 632. So basically, what could you do AI-wise? And this is like when we came up with all these conventions, like 80s and 90s. Sure, there are new game genres now. There are MOBAs. There are like dating simulators. There are like whatever do you play. But they grow out of other game genres, and then you have all these different conventions that people have come to expect, and this is limiting us from coming up with interesting AI methods or designing around AI in gameplay. This is a behavior tree. Behavior trees are still what's driving non-player character tactics and movements in, I would say, most games. Someone feel free to correct me if I'm wrong. It's some version of behavior trees you see everywhere. It is very, very limiting in terms of how they can act. I mean, but yeah, you have a behavior tree, and then you also have some pathfinding and a little bit of movement, smoothing, and stuff like this. Because this goes all the way back to, like before the behavior trees were finite state machines, and people are used to this. People implicitly think about this. Let's say you play Assassin's Creed, to take like an extremely popular game series. And it builds on like the design conventions around sneaking games, which date back to the original Thief from 1990 something, which was a finite state machine plus sensors built in. And if you're sneaking in a game, you expect these things. You expect that there's a bunch of different states that the NPCs can be in. And you expect to be able to learn those, to model this implicitly, and plan around that. And if you are going to introduce something completely different, say you're gonna put in a deep neural network there to control how the guards act, wow, you're sort of dragging the players out of their comfort zone. This is the argument that people told me, like, you know, when I first went out to like say 2005, 2006, I started talking to game developers coming as I was then a PhD student, and I was like, I have these cool evolved neural networks that you can use in your game. And they were like, we don't need that. We know how to do NPCs. This is how you do NPCs. And now 20 years later, I'm like, I have to admit that they were kind of right. But that's a sad thing, right? Shouldn't we be able to do better? How do we do better? And just throwing out like 45 years of game design history or video game design history is not an option. We can't. We have to figure out how to deal with a historic baggage of designing around the lack of AI. This is not the pinnacle of dialogue. This is a dialogue tree. And I mean, you play any RPGs or any game with like, you know, any game with like where you talk to people, you're gonna have dialogue trees. You expect it to be that way. You know that if there was some choice in the dialogue you didn't take, you can basically quit the conversation, go back to the conversation, ask the same thing again, and basically choose another dialogue option. That's how you expect an NPC to behave. And that's where you have this thing. And right now, like, thousands of people around the world are like banging their head against, how the hell do I put a large language model in here instead of a dialogue tree? We're going to get back to that a little bit later, but it's very hard because people don't expect it, and a bunch of other things. So let's take a slightly more positive take on things. Sorry, this is I'm coming here and being very negative and picking fights. But let's take a positive spin on things. Advances in AI and technology, game technology, AI widely considered, have driven advances in game design. There are a bunch of things that came out of it. And some of them became extremely influential, some of them not so much. And it's important to remember that AI is a very broad term. Today, people are like, oh, an AI, that's a large language model. And I feel like, going there and being like, putting my old person hat on and say like, no, large language models are not real AI. I'm not doing that. Okay, here's the deal. Large language models are AI, but so are probabilistic networks, graphs, pathfinding, evolutionary computation, a lot of other things, right? So pathfinding. I would you can also argue with this, I would think that Pac-Man was the game that popularized pathfinding as a kind of load-bearing element in game design. Because the pathfinding in Pac-Man wasn't very advanced, but it was there. And you, as a player in Pac-Man, and even more in Miss Pac-Man, which is non-deterministic, unlike Pac-Man, which is deterministic, are trying to outsmart these ghosts, and you are doing it by basically trying to figure out what these movements you make, how will they affect how they move around. This is how you get good at Pac-Man. And of course, pathfinding is everywhere. Like, almost every game you can imagine which features some kind of non-player characters has pathfinding. And these days you have nav meshes and all kinds of like variations of A star, but basically it's the same thing. Planning. Fear. How many of you played Fear? Yeah, first encounter Assault Recon. I like that I'm speaking to this old audience here. Nice. Like I was just like talking about these things to a bunch of like, undergrads the other day, and she's like, I don't know, the earliest game I played was Fortnite. But again, you need to know your history because design conventions go way back and they affect us so much. Fear was kind of groundbreaking in the way how the NPCs behaved. They were using something called goal order action planning, which was essentially pathfinding in the state space. And the state space is a much abstracted version of the physical space in a sense. And they're also talking to you. They're like communicating their intentions. You kind of listen into these kind of enemies' radio. I forgot what it's actually about, Fear. There's some kind of paranormal activity and you're going in there and shooting everybody. But it's kind of okay because the other people are undead or something. I don't know. I forget. But it's a good game. And they're like, oh, I see he's in the kitchen. Okay, you keep him pinned down. I'm gonna flank him. And I'm like, aha, he's planning to flank me. Okay, right. So it's really effective. Another game that used this to basically the same algorithm essentially to great effect is Shadow of Mordor. Who played it? Oh, good, many people. Cool game, right? So there is a lot of, you encounter the same kind of enemies and so on, and it's not like random. They are planning. They have a plan on you, right? It's very cool. Procedural content generation. There's I've done a ton of work in this, but basically this goes way back. Rogue, a game from the 1980s, which is, from 1980 actually, exactly. Michael Toy and Glenn Wickman were students at the University of California, Santa Cruz, and they wanted to play Dungeons and Dragons. But they didn't want to have to encode the adventures and the sort of maps themselves. And they didn't have enough disk space on the UC Santa Cruz mainframe anyway. So they had to generate it. They had to come up with a generator that generated new dungeons every time you played it. And it's kind of rough because like you may meet like enemies you absolutely can't face early on. It has this great, fantastic 1980s mainframe graphics, all text. But Rogue, of course, became extremely influential. There's a whole genre called roguelikes, and lately we've seen how more and more games have roguelike elements. Hades 2, which, who has played Hades 2? Or Hades? You really should if you haven't, it's so good. It's a design innovation here, is how they, every time you play it, all the levels you play are completely new, but they still manage to sort of combine this with like sort of top tier storytelling, which is fantastic. But you see this in so many different games, like Bloodborne had some kind of roguelike elements in these challenge dungeons, and you know, a lot of different ones. Also like Civilization and other kind of strategy games, also roguelikes. You need to generate a world every time. Or more PCG. Elite is a game that came out in 1984, where you fly around in a sort of 3D world, and you fly between star systems, you dock with space stations, you trade various commodities, you fulfill missions, you have fights with the space police and space pirates and so on. And there's like 4,096 star systems in the standard version, and it fit in memory on a Commodore 64, which had 64,000 bytes memory. This computer here has really more than 1 million times as much memory. And how did that work? Well, they used the different parts of the compiled code as random number seeds, and then they generated the star systems every time you came there. Now, you may think that, well, okay, my computer now has 1 million times as much memory. We don't need this anymore. We do, because however fancy your computer is, the real world is always larger and has more detail than you could ever fit in memory. So you're going to need to generate something. So No Man's Sky is one nice example of, like, you know, the spiritual successors of Elite here. Other things, Minecraft heavily relies on procedural content generation. This idea that you could generate worlds in different ways. And I haven't even gone into the algorithmics behind it. Minecraft uses Perly noise a bit, and a whole bunch of other things on top of that to generate the worlds. Spelunky, extremely influential. Who has played Spelunky? Well, a few. It's good. I'm not going to ask who has played Minecraft. If you never played Minecraft, you're sort of sorry, you're out of here, you know. Yeah. I was once supposed to write a paper with Marcus Persson, aka Notch, who created Minecraft. That was before Minecraft was public. But then he stopped responding to me, even though I wrote him in Swedish. So I took him off the paper. Maybe that was a good thing. Maybe not. I don't know. This is things you know. Evolutionary algorithms. Oh yeah, it's good to point out that Spelunky, for example, uses an entirely different set of methods behind the scene to do its level generation. It uses a bunch of tiles that it draws from, and then basically uses pathfinding to trace a path, and then selects room templates to sort of fit with the path it draws, and then randomly populates them. So there's a lot of depth, there's a lot of algorithmic depth to, or like there's a lot of algorithmic width to procedural content generation. There's so many different methods. Evolutionary algorithms. Creatures, it's a very strange little game. Who has ever heard of it? A few. Yeah. It's a game that came out in '96. There were a couple of successors. it's like 2D thing where you basically, I would say it's kind of Sims-like in a sense that you are watching these little creatures go about and you affect the world and you breed them with each other. So basically then they lay eggs and then you sort of new creatures come out of that, and the evolution of new creatures is kind of the main thing in the game. Galactic Arms Race, putting in here, even though it's an academic prototype, all the weapons in this game, which is a multiplayer space shooter, are generated through a global evolutionary algorithm, and basically the ones that are popular get to have kids, and they combine with other weapons, and then and then their offspring are left out in space for players to find, which is a cool game design indeed. Black and White. It's a famous game for games and AI. Who's played it? Or some version of it? There was a game Black and White 2 as well. Not only because Demis Hassabis, who later on went on to co-found DeepMind, was working on it, but also because it, mainly because it came up with a new kind of design idea for how to interact with AI. It had all these It's basically a god game in the style of Populous. You have to control this world with where various villagers live in the villages and go around their lives, and they fight and they farm and stuff like this. But to your help, you have these giant creatures, and they are trying to do as you do. You can demonstrate to them what you want to do, like, hey, help the villagers do this. And then they may do something else, and maybe they eat the village instead. And then you can punish them, or you can reward them when they do the right thing. So basically, raising your companion creature is a key gameplay element. And they actually use some kind of decently complex machine learning behind the scene for doing this. What is really fascinating is this game came out like 25 years ago, and I've not seen anyone, apart from and it was moderately successful even, but I've not seen anyone really sort of picking up the baton and doing the next game that works like this, which is really fascinating. One game series that did become extremely popular is the Sim series. According to some measure, it's like the series that sold most games in the world or something. The Sim series, in the different Sims, the AI systems differ quite a bit, but basically, at least the most recent ones are based on utility-based AI. So you have pathfinding with these, the various Sims are trying to figure out how to get around, and they have needs. So basically they have like different, like, this is how hungry I am, this is how horny I am, or whatever. It's probably not called hornies, but you know, whatever. And then the various things here radiate, like, hey, this sink here radiates that it can fulfill your hygiene needs, and you can go there. And the TV radiates that it can fulfill your fun need, whether that's true or not, I don't know. But, and then they select based on their state what they go to and what they try to do. Another kind of like, this is also interesting because it's a series of somewhat successful games, Scribblenauts. Who has played one Scribblenauts game at least? Okay, many of, like half of you or something. I think they're marvelous. These are games where you basically type in anything. And you basically, I want like a zombie chicken, and a zombie chicken pops up. Okay, and then you add like a zombie hunter, and the zombie chicken runs from it because it knows it should run from the zombie hunter. And then you come up with garlic and throw at it, and so on. So it is the various versions of Scribblenauts. They have gameplay. You need to basically solve various tasks and so on. But it really works best as a sandbox. You can do the most silly things in there. It's very fun. I don't know how many people I've heard saying, oh, I want to make AI Scribblenauts. And what they mean is kind of LLM-driven Scribblenauts. Two observations. This is already AI. This uses ontologies. This is classic good old-fashioned AI, and it's a very good example of it. But I've never seen anyone replicate this really, which is a shame. I heard a talk from Liz England, who was the lead designer, and she talked about how she basically sat down and hand-coded this giant ontology, and it works. B, I have not seen anyone really any convincing example of LLM-driven scribble nodes, although someone should do it. Why haven't you done it yet? Right. This brings us to where are all the AI-powered games? And I mean modern AI, generative AI, like LLMs, VLMs, diffusion models, deep learning in general, Monte Carlo tree search, reinforcement learning, things that weren't really on anyone's radar 10 years ago, or 15 years ago, something like this. Where are they? Why haven't people made them? If people are like going here and saying, oh my God, the AI can do my job, the AI can design my games, like, well, okay, so fight back. Use the AI to design new games around it. But people are like, weirdly not doing it. So now let's try to address the core question, why? There are three issues: compute, memory, and design. The first two issues are serious, but the third one is where the real problem. So compute and memory, like say you want to use like a kind of non-trivial LLM. Well, first of all, you don't have enough compute to run it. Maybe you have a GPU, but the problem is you're running a game and the GPU is busy doing graphics. Who ever heard of this, doing the GPU for graphics? Weird, but that's how it is. While it could be multiplying matrices for your deep neural networks. Memory, they don't have enough memory. This is a really big one. Now you could basically say that, and it's not getting better with the memory prices right now, but really you need to I don't know, you can get decent, get decent LLMs doing decent stuff on 32 gigs, but yeah, not on like whatever 6 gigs or whatever is in a PlayStation 5. I don't know, 8 maybe. Now you can say, well, we can just send a request to a server somewhere that does all the compute for us. The problem is that you don't have the economics for that. Economics in most games are not like that. No one wants to play a game where you have to pay by the token. And if you play a game up front, where you basically you buy it for like $50, and maybe 20 of those dollars eventually can be used by the game development studio. They if the game is good, then you're going to use them up very soon. So it gives you completely perverse incentives. Don't make a good game that people keeps playing, because then you'll go bankrupt. Yeah, so it really needs to happen on device. And we're not quite there yet. But the big problem is design. So, I don't know. I guess all of you know about Skyrim. I had a memorable time. I think was it was it came out at the end of 2011, I think. And I remember sometime like Christmas 2011 going on to New Year's 2012. 11/11/11, yeah, that's a good name. It's a good. I was so anxious for it to play it, so I bought one copy for myself and one copy for my friend who didn't have the money to play it. So, and then I basically unplugged the internet and basically locked myself in over Christmas. And I mean, I did go and celebrate Christmas with family and stuff like this, but yeah, you get lost in this world. It's amazing. Amazing design achievement with all warts and all. And endless amount of people are like, why don't you just put LLMs in these NPCs? And people have tried this. There are mods for this. It's terrible. It ruins the game because it's not designed for it. Because the NPCs get really boring. Because the NPCs are because it's slow and everything. but also because like they don't fulfill their function of telling you what they should be telling you. Instead of going up to an NPC and you'll get the information you need, you're like stuck in this like small talk hell. And why are you there, you know? So there's a bunch of people trying to do like various interesting stuff. We'll start with the really weird stuff. Yeah. You know about how all these let's see here. You know how AI alignment and basically, why am I not able to do this? Where is the? Oh, there we go. You know how everybody talks about like the LLM should be helpful assistance and safe and conform to your wishes, do as you say, and like, you know, just try to help you. This game is basically, what if not that?
I can't wait for our journey ahead. I will always be by your side.
Wait. I want to put the captions on here. So basically, you have an AI girlfriend. She's great, cat girl, right? Just what you wanted.
You drew a portrait of me. How cute. You can't leave. You're mine, and I won't let you go. We can bake something together. Let's have a dance party. I can't just give you my password. It's for your own
Makes
safety.
sense.
What do you think you are doing? I won't let you get away. We will be together, no matter what.
Yeah, so this is an example of taking your conventions and overturning them and doing something completely different. Which is always interesting to do. I have no idea whether this is like a successful game or anything, but it's it's one interesting design strategy. Try to make the LLM something else. Ubisoft, this was almost 2 years ago. Ubisoft and In-World AI had a demo of something called the Neo NPCs 2 years ago, and I went and tried it at GDC. It was quite fun. Basically, you have to plan heist here with like a leader of the resistance, or you have to convince this other guy that you're actually should be let into the resistance, and so on. And you basically press a button to speak into the mic, and then they speak back at you. Of course, you can trip it up. I managed to make it hallucinate once. Of course, I was trying. Of course, I'm a weirdo, and I try to do these things all the time. But it was like almost there. It's like almost something shippable, and I managed to gamify this fairly well. So in this case, you're talking to this resistance guy, and you're basically you need to say things that to bond with him, and your relationship meter goes up. So they're very good at it. What I've seen like a bunch of these different like LLM-driven NPCs. Most of them suck so much. This was the only one that felt like you could actually build a game around it. I think what it comes down to is that they had good designers working with this team, not only good technical people. And then I talked a little bit more to the people there, and what was obvious, and as probably also one reason it's not shipping is that it's not really done. Another reason is what we just said. Because this was using large models on server. How are you going to get the economics working for this? But yet another reason was the amount of authoring. So this is some kind of cyberpunk future world. And you're supposed to talk about how you want to join the resistance. But when you think about it, say you want to author one NPC in Skyrim, and you're kind of writing like 4 lines of dialogue, right? In your dialogue tree. You want to author this guy? Okay, so what world does he live in? It's said about Margaret Thatcher that she always knew what the price was of a liter of milk. Can you ask this guy what was the price of a liter of milk? Does milk exist in the cyberpunk future? What currency do they use? How much is a liter of milk? What if you're asking about his mom, his childhood? You want to bond with him, right? You can talk about anything. Hey, did you watch the game? You know, what game? What games do they watch in 2067 or something? Like, suddenly you run into a version of what's called the frame problem in AI. It's like, what are you going to model? You're going to model the whole world. But this, because if you don't model this, if you don't put, like, you know, something like a story Bible the size of the Lord of the Rings in there, you're running into the problem that then it's going to just fall back to his pre-training. And his pre-training is like, my knowledge cutoff is September 2025. and if we like, what is the price of a liter of milk? And it is whatever the price of a liter of milk was in 2025. Right. So the authoring burden is huge. This is good news. Everybody who's like, oh no, AI is going to take all the designers' job, sit up and basically like, no, honestly, we're going to need, if we're going to do this, we're going to need so much more design, so much more authoring. It's cool, right? There's other things here. There's here's something called LLM for Unity. If you want to experiment with this, this is for people who want to run local small LLMs. Like most machines, you can run like 4 gig LLMs pretty fast. They're not so good. You're going to run into the limitations pretty fast, but you can do things with it. Okay, I talked a lot about the NPCs. Let's look at AI innovation in game design that's not NPCs. Oh, I was supposed to have something here, right? It's hard. It's hard because you don't see it. Not with recent stuff. There's one thing that I like a lot, which is infinite craft. I'm now going to show this to you. This is what I tell when people ask me about, like, now tell me some actual AI innovation. Oh, there we go. This is by a guy who I've never seen, who lives in Brooklyn. Kind of weird. I work in Brooklyn. It's only 2.7 million people. I should have run into him, but no. Okay, so this is infinite craft. What do you have? You have water, fire, and wind. And well, let's drag water here, and let's drag fire onto it. We get steam. Good. Earth. Let's drag water onto earth. Get plant. Steam and plant. We get tea. Oh, nice. I like tea. I haven't had tea. Well, I had a tea today, but plant and tea. Oh, that's also tea. That's kind of a bit boring. Let's drag tea onto tea. Tea. Okay, boring. Wind and tea. Kite. Why? Why wind and tea is kite? Water and earth is plant. Kite and plant is tree. Yay! Tea tree. What is a tea tree? It's teapot. Yes. Fire on the teapot. Tea. Okay. Earth. Yeah. I mean, this is my life. It all comes back to tea. Wind and water is a wave. Let's put a wave onto a wave. A tsunami. A tsunami onto a tsunami. No. Teapot and tsunami. It's very Japanese here, right? So this game is kind of fantastic. We haven't gotten to like any weird stuff. Fire and cloud. Lightning and tea. Yeah, tea is the answer to everything. But you get into this really weird stuff. At some point, I was like Darth Vader, everything, and you get like the Yeti comes back a lot. Smoke and lightning, thunder, kite and thunder. Only lightning. I was hoping to get Benjamin Franklin. Sometimes you get these things, and you can put yourself little goals, like you can make yourself a goal. Oh, I want to get to Benjamin Franklin, for example, and like, how do I get to Benjamin Franklin? And you also get, this is barely a game. It doesn't have a lot of what you expect from a game. You can't lose, there's no score or something, but you do get, what you do get is, like if you find a word that nobody has found, ever before. Then if you found a word you haven't found before, it sort of pops up with a little shine. If you found a word that nobody's found, you get a little sort of badge or something like, hey, this is a completely new word. And you just keep exploring. This is using small llama models in the background. So it's running on a server, but with very small models, and that's why it's fast and cheap. I really like this because this is actually genuinely novel. It basically has one mechanic, but this one mechanic could not be possible without an LLM. It is emphatically not an NPC, and I really love that it's like really rethinking what you can do in a game. I think this is a great example for like things you can do. I'm gonna get back and play this. Oh, surf, surf tree, palm plant, coconut and lightning, palm tree, no. Earth, fire, palm tree, no. Coconut, why? Wind and coconut, no. Coconut is an attractor state here. Surfer, surfer has tea. Oh, it's broken. It won't work. The surfer won't have tea. The surfer. Coconut tea? Anyone? No, it's not possible. You cannot do that. Anyway, so you sort of keep doing this thing and build up this. You can get absorbed in it. Let's go back to my slides. I realized that I said I had few slides, but I've been going very slowly. So let me show you some stolen material. This is not stolen as in like, I asked a diffusion model to do it. I literally stole this from Jessica Jung, who I was on an event with her like 2 weeks ago in New York. Sorry, Jessica, if you're watching this. Why are you watching this? So she's the head of the generative AI lab at Supercell. And she showed some of the various prototypes that their people there had done, and focusing on like kind of interesting failures, and looked into a little bit of like, what are takeaways. And she looked at like lessons they had learned so far. A lot of it is like, you add AI here doesn't actually improve the experience for the player. It makes it kind of like unpredictable or weird and strange, and you don't see what's going on. There's nothing for you to model. And she advocates, like, think about it as a minimum viable AI product. Start with like the mechanic or the design element that actually builds on AI and then builds on that, which Infinite Craft is, I think, a great example of. You could build a complete game on top of that, but maybe someone should, maybe you should. Other things, in fun, I mean, this is not the only way people have fun in a game, but largely it's like you have a goal, you make a plan, then execute a plan for a very loose sense of goal. Whether the plan succeeds or fails is less important than that the players are able to get feedback and understand the outcome. This is the design secret of all the Souls-like games, right? I mean, I didn't think I loved losing so much before I played Bloodborne and then Elden Ring. Now I have understood that I am a loser. I am such a loser and I love it. But it's all about like getting the feedback and understand the outcome. So can you use the AI to add to the feedback, or are you using it as a black box which hurts the predictability? This is really interesting. This actually brings in Noah Wardrip-Fruin. He has this concept of like the SimCity effect, the ELISA effect, and the Tailspin effect, where Tailspin is an old story generator that was really advanced, but people couldn't tell from looking at the stories. Whereas ELISA, as you all know, is like a simple psychologist program that's really simple, but it looks complicated. And SimCity is a game that seems complicated and is complicated. You can actually, it's legible. You understand what's going on in there. Friction to fun ratio. If you add friction, which is very easy to do with AI, you need to provide more fun as a payout. Your competition is TikTok. Low friction, medium payoff. I don't know. I don't understand TikTok because I'm old. So for me, it's very low payoff. I'm just like, what? But yeah. Using voice or typing adds friction. I don't know why this is. People are like, somehow there's like this kind of strain of people, designers are like, what people really want is to jump around and wave their hands and then speak loudly into the microphone and perform all these physical actions and natural interaction. I never understood it. Even Nintendo, the goddess of game design, kind of failed. The Wii was a success despite all the kind of wave your hand stuff around. Kinect was a complete failure, except it was good for research. People who play games don't want to do effort. They want it easy, right? And talking is effort, he said while talking. Confusing. But yeah, how do you use this? How do you use AI to sort of take away the friction instead of adding more friction? And here conventions help. We're getting back to this thing. We talked about design conventions all the time. Yeah, we have all this design conventions goes way back. The oatmeal problem. My friend Kate Compton, who has done a lot of fascinating stuff in her life, worked on Spore, and now did a Ph.D. in sort of generative AI. Had fights with me on PCG. Was good fights. We both remember them fondly. She now works at Lego, but she's looking at she coined this thing, the oatmeal problem. What if your generative methods generates like it can generate infinite new things, infinite new levels, infinite new swords, or infinite new characters, or whatever. But look at this: 10,000 bowls of oatmeal. They're all individual. They're all different from each other. They are not identical. And do you care? You do not care at all, because they're still oatmeal. So basically, just like variance in itself is not necessarily the things here. So basically, yeah. Another thing, yeah. AI works better as a supporting character rather than a store, than a star. Okay, I'm actually, because we're up on time, I'm going to cut out some stuff that I was planning to talk about, and we can talk about that later. I'm going to end with a few more slides here. This is an old paper that a bunch of us wrote in 2015. We had like a seminar in a German castle, the Dagstuhl Castle, which is something as weird as a computer science castle. Ein Informatikerschloss im Deutsch. So German. Where you basically go when you have seminars. And then we were like, back in 2015, we were looking at what are design patterns which foregrounds the AI in one way or another. Not like background, not to support, but basically where AI is something you consciously interact with. And this is before the most recent wave of generative AI. But we looked at a bunch of like various prototypes and lesser known games and some very well known games. Just going through this, you can look at AI as something that is visualized, where you observe the AI state and that helps you understand what's going on. Third Eye Crime is a really interesting, it's a little sneaking game where you can see kind of where the NPCs are thinking of looking at next. Their internal mental state is kind of laid out, and that's a very kind of interesting way of doing this. AI is a role model. You are trying to imitate the AI. Spy Party is a good example of this, where it's an asymmetric multiplayer game where one person is trying to assassinate someone as an embassy, and there's a bunch of NPCs, and there's a human, and the human needs to try to look like an NPC. So it's kind of a weird inverse Turing test in a way. AI is a trainee. You teach the AI, and it's a child or a student or something. Black and White is a good example of this. AI is editable. So Galactic Arms Race, as I mentioned before, also has a mode where you can go in and edit the neural network directly and sort of change your weapons that way, which is interesting. AI is guided. The Sims, basically, there are lots of NPCs, but you are controlling them in some way and helping them along. AI is a co-creator. This is Viewpoint's AI, but there's a lot of other things like in the vein of like you are co-creating things with AI as it is going along. Arguably, you could put something like Civilization in there as well. AI as adversary. Obviously, this is what everybody talks about when they talk about AI that learns to play classic board games. AI is the villain, where you are not supposed to lose to the AI. You're supposed to win eventually, but it's supposed to put up a believable fight. We put alien isolation in there, which is a really interesting case of like you fighting essentially one NPC throughout the whole game and trying to figure out what it's going to do next. An AI spectacle, where you're basically just viewing society is kind of like something that you are looking at, or you kind of be an anthropologist in this. So this is more ideas, and I think this kind of thing you could sort of expand this list a lot, and a lot of things have happened. But this is like ideas for like how to design games around AI. We're out of time, so I'm going to skip the neural game engines part. Basically, what I wanted to say here is that they are great for like prototyping, and they may enable a bunch of other things, like may enable planning in games and so on, but they are absolutely not going to replace game engines. So I'm going to finish with a cryptic picture. But it's interesting that it took something like 50 years for tractors to actually replace horses on farms in the US, even more in some other places. And largely because like, wow, the tractors were so powerful, but they were like not suitable for everything. You couldn't control them well enough. The tires weren't right for various things. You couldn't connect the right kind of things. There were so many different things, and they were expensive, of course, and so on. It's a ton of little design problems that came with this new technology that people had spent like centuries working on with horses, and now we had to sort of learn to design for these new engines. And then of course there were new ways to farm coming with this. I write books sometimes. This one and this one, they're available online for free on these web pages. They're also kind of like, you know, they're technical. This one is a bit older and this one is a bit newer, are available in your bookstore. And we also run a summer school. It's going to be, next time it's going to be in Netherlands, 15th to 19th of June in 2026. Leiden, beautiful place. We invite a lot of people talking about AI and games from industry, and me and Yorgos Yanakakis are, you know, talking as well. It says summer school, but I recommend it to people who don't think they would need to go to school as well, because it's also like basically a conference. Thank you.
Can you go back to the previous slide with the book links?
Yeah.
All right. I think we're at lunchtime, but I think we want to have question and answer too. I see a lot of pensive people in the room. So if folks want to grab food, I think food's set up. Go for it. And we'll go ahead and do question and answer if Julian's fine with that.
Sure. Yeah, I'm sorry I ran over time. I don't know why. Yeah. I'm slow today. Yeah.
Do you think that the idea of games is a constraint? Because I look for a game, but then sometimes I want to play like a simulation, you know, which when I started playing Sims, I kind of felt like what you were talking about. I felt confused, I didn't know what it was, I didn't enjoy it. It was only when I kind of like said, I'm not playing a game, I'm playing a sim, that I felt like I got the enjoyment out of it. So do you think maybe there's just a new genre or context, and define a game itself is
no, so it's like do I think that the framing of games is a constraint, like as opposed to like many of the things interesting games like Sims, for example, don't feel like games originally, and SimCity very much, right? You know, Will Wright created SimCity. He said that I'm not designing games, I'm designing toys. I think it's a very good observation. I think there's a lot to like. I think there's a lot to that. A lot of the things we play now wouldn't register games as games to people who, you know, didn't grow up with video games. Like if you if you are like an old school board game player and you spend your time playing checkers and chess and Go and whatever, and you're seeing even Street Fighter, right? Like, this is weird. Why are you doing this? This is a sport or whatever. Yeah. So I guess the high level thing of this, don't feel constrained by what's like, by thinking what's a game. Like in game studies, people keep debating what is a game, what is not a game, and honestly, the only thing we learned from this debate is that there is no answer to that. Sid Meier said a series of interesting choices. Yeah, that's so decent. Yeah, so I think it's also actually good. Like, Infinite Craft isn't a game, but there is some gameful interaction in it, I guess. Yeah.
You mentioned and talked about the oatmeal problem. How do we prevent the oatmeal problem happening with our games? How do we get it to be, not just another bowl of oatmeal with some new flavors on top?
Yeah. How do we prevent the oatmeal problem when designing a game? Super hard. Yeah. I guess this is kind of one of these irreducible problems that is basically like how it basically comes down to how do we do good design. And it's also subjective. Like, would you say that No Man's Sky has an oatmeal problem? Probably not, because they're so visually different, but the planets in No Man's Sky with all the fantastic visual, if you have never played No Man's Sky, maybe don't play it because it's a bit of work, but at least watch some videos. It's really amazingly visually impressive. But from another point of view, because of the lack of overall story arc or anything like this, after a while you do feel a little bit like the oatmeal problem, because here's another planet with new geology, new wildlife, new everything that I've never seen before. Why do I care? So in the end, it's about making the player care, and that's where good design comes in. It's kind of irreducible, I think. Yeah.
Fable, which is my favorite game.
Oh yeah.
Has come out. They've made the news that they have over 1,000 individual, unique NPCs that rely on generative AI.
Oh wow.
Do you have any insight on that or any thoughts?
Who said this? The guy, Mr. Vaporware himself? So for people who don't, so the Fable, the original creator of the Fable series is, what's he called? Peter Molyneux. Peter Molyneux is a great designer, but he's almost even more famous for like announcing things that just never come out or doesn't look like what it would be. Yeah.
Well, he's not making.
Oh yeah, but his spirit is in it, right? I played one of the Fable games, the one that was on Xbox 360, right? And it was good. I liked it. My guess is what's going to come out is that they have used generative AI to generate all the dialogue trees and the dialogue lines and so on for these 1,000 NPCs, but that these 1,000 NPCs are not using generative AI in while it is being played. That would be my guess, but this is very low certainty. I am excited to see what comes out. Hope there's something cool. Thank you. Yeah.
So I'd like to tie together the first two questions about constraints. So when we design AI for our strategy games, it's so easy to create AI that no player can ever defeat. You start there, and then dial it back to a satisfying player experience.
Yeah.
But it seems that that's the constraint. It's hard to give an LLM. How do you tell it that its goal is to satisfy the player as opposed to win the game?
Yeah.
And right now we have LLMs that they're supposed to make people happy just by telling what they want, and players don't want that either. They want a competitive experience.
Yeah.
So it seems like LLMs are the last thing
Yeah.
that can actually figure out what a satisfying player experience is. And until you have that, you don't solve the design problem.
Oh yeah, no. I mean, again, it's like it's just like summarizing this thing. It's like LLMs are not. How would LLM know what a satisfying player experience is? They want to be helpful assistants. That's what they train for. And like, there's a bunch of answers to this. You can train them for other things. You can put harnesses on them and so on. But main answer is like, don't think of AI as just LLMs. There's so many different things. We didn't talk about Left 4 Dead here, but Left 4 Dead has a lot of it has a lot of like I mean, the AI director, it's fairly simple in some ways. Like, it's basically like you have this tension curve is trying to match. It's like goes up and down, and then it sort of attacks you with more zombies if it tries to increase your tension, and decreases it by giving you fewer zombies and stuff like this. So yeah, LLMs are not like, you know, the tools for everything. But you so probably something better, something else is good here, I would say. Yeah.
What is your general sense of, like, let's say somebody cracks the code on all this, we solve design problems, somebody's using AI in a different way, and then they decide that they want to patent on that new system. What's your, like, should people be allowed to do that? Is there a concern about somebody doing that? You mentioned Shadow of Mordor, which is the Nemesis system, was infamously patented, which then stifles the innovation on that system. And it was kind of, I would say,
Yeah. Yeah.
Or is AI too broad to where, like, if somebody did decide to patent something, it's not too much of a concern?
Yeah, the questions about patenting these new game designs. I mean, AI as a whole, generative AI is kind of riding roughshod over intellectual property law. And we don't know where this is going to end up. I mean, there's going to be a lot of very interesting court cases that are playing out on a completely different and much slower time scale than other people. I heard we had at last year's AI and Game Summer School, a debate came up with someone from Silicon Valley who was like, obviously, like, OpenAI going to throw billions on on, like, you know, winning these patent lawsuits. Like, the question is settled. It's like the intellectual property is going to disappear essentially. But then someone else retorted, like, basically, no, you're fighting, like, say, Disney, who is like the best people at utilizing the American intellectual property laws ever. They depend on it. It's like it's a life or death situation for them. I wouldn't necessarily want to bet against them. So I don't know where this is going to go. I don't know. I was asked by a law firm to represent some big patent owners in a lawsuit against Midjourney, and I politely declined because I don't know where I stand. I don't have a strong. I asked a friend of mine who does a bunch of these sort of court cases, like expert witness things. It's like, I don't know. He told me I needed to have a strong position. I don't. I don't think game mechanics should be patentable. And I don't think that AI methods in practice, that patents actually mean anything. Like, DeepMind technically has a whole bunch of patents on, like, you know, I think even a transformer architecture, but, like, has this meant anything? No. We're going to start weaponizing that? That seems bizarre.
They tried licensing it, but they haven't sued anybody.
Yeah. Oh, wow, they tried that. Yeah. Well, good. I mean, good luck. I'm strongly on the side of open source and on that kind of thing, at least, you know. And although open source and the games industry haven't always gone well ahead, but I think in terms of AI industry, so I don't know. Okay, yes. So the question is a dream world, a generative, lifelike content stuff?
Like, is the dream world like this generative intelligence that's like creating like live content?
Basically like the holoduck. Yes. Yeah. Oh, but is it going to be fun? That depends. Is it fun? I used to go around and tell people, like, what if we could do GTA, but, like, basically you go 5 hours in that direction, and then you find new cities and new quests and new architectural styles and new NPCs that are, like, tied to you, and and they give you the kind of quests that you didn't know that you would want and so on. And like, yeah, maybe if it's fun, if it's good. I mean, the holodeck comes up a lot. Anyone? I suppose people. This is like the key plot device in Star Trek: Next Generation. It is kind of like virtual reality sort of system on the spaceship. And the holodeck, there was a lot of great stories in the holodeck, but that's because humans wrote great stories there. So, yeah, I'll just I'll make it simple for myself. Push the story back, push the question back, like with like, yeah, is it fun? I think we're almost out of time, or like one more question. At the back.
I have a question about when you were going over games in the past and how they implemented AI and how it's can change in the future. Like you had a game from the past that led to the game from modern.
Mm-hmm.
Right? To my understanding, Oblivion is
Mm-hmm.
usually attributed to being one of the first games where AI interacts with AI. Do you agree with that, or is there another game in your mind?
I mean, it's kind of it's the kind of thing that people put on that developers write as marketing material. In the end, the AI is such an overloaded term; it doesn't mean anything. If you're going to be like, what's the first game where AIs interact with other AI? I also strongly, and I would say strongly, dislike talking about AI as a definite object, like an AI that doesn't exist. That various kind of AI-driven characters interact with each other. Well, I would say that's probably Pac-Man. So, so it really depends on what you mean by AI. Chess. Okay, great. I stand corrected.
I'm not sure which year they came out.
Turing invented or maybe reinvented the minimax algorithm and played chess against his friend's wife in 1948. He didn't have a computer that could do it, but he wrote out the program code and simulated it on paper. He lost. All right, thank you.
I'm Dr. Luke Dickin. I'm head of AI for Take-Two Interactive. So a little bit more about me. I've been kicking around the industry for about 20 years at this point, and I kind of feel weird saying that out loud because I don't feel old enough to have been doing anything for 20 years, but here we are. My first 3 degrees, which is already too many degrees, were in kind of AI theory kind of stuff. So bachelor's in very theoretical AI. My Master of Science is in kind of more roboticsy theory, Master of Research in very roboticsy theory, and then PhD. Back when I was doing my PhD, you couldn't really do a PhD in games. So it's in simulated virtual environments, because that's how we got away with doing game stuff without saying games. Fortunately, things have changed a little bit these days, and we are now talking about games in a university setting today. And that's something that you didn't really get to do maybe 10 or 15 years ago. So as Andrew was saying, I was the first IGDA board member from outside of North America. That was like 2013. So that's the definition of international we were going with in 2013 was US, maybe Canada. And I was the first guy from Europe on that board. And then I led the IGDA Foundation, which is the charity side of the IGDA, for about 7 years, from 14 through 21. I joined Zynga also in 14, joined as a data scientist, bounced around a bit internally, led the central analytics function for a few years, and then in 2019, we founded an AI R&D group. And that's where 3 of us kind of carved off, sat in the basement, got off everybody's radar. And you may have noticed the conversation about AI has changed a little bit since 2019. So Gen AI came to the fore, and we had a whole bunch of executives who said, hey, we've got an AI team. This is your problem now. To which I said, oh, thank you for the box of hand grenades. We are kind of leading governance, or we have been leading governance around AI for Zynga for the last couple of years. You know, there's a lot of AI tech coming out constantly, kind of an onslaught, and it's going to be a theme of kind of talking about this stuff. Some of it is quite sketchy. Most of it is at least somewhat sketchy. And it's our job to kind of make sure that, like, the absolute worst things definitely don't happen, and kind of be the voice of, like, what should be happening and how we should be kind of thinking about these things in a way that is a little bit more human and industry-centric, as Andrew was kind of mentioning earlier. So I do have to get a few disclaimers out the way first. About 4 months ago, we moved over to Take-Two. People have forgotten that Take-Two bought Zynga, mostly because we were the biggest deal in the games industry for all of 10 days. And then Microsoft bought Activision for significantly more money, and suddenly nobody was talking about us anymore. But Zynga is part of the Take-Two family. And 4 months ago, I did move over to lead AI from the parent company. The way that Take-Two is structured is kind of, we have the corporate kind of level, and then we have these labels, subsidiaries. They have their own policies. They have their own positions on stuff. I today am not speaking for 2K Games, and I am not speaking for Rockstar Games. And it's very important that I say that out loud up front. My first credit was on GTA 4. That was on the previous slide. That is the only reference we're going to make to GTA today. I am not answering questions. I don't know anything. But I am going to be talking a lot in generalities. And one of the reasons that I'm going to be talking in generalities is we don't want to talk about what we're doing internally. So I come here and I say, hey, these are the kinds of things. So I'm not going to be kind of hitting on very strongly on kind of what we're doing internally, what tools we have, and that kind of thing, because that would have triggered a lot of more conversations with lawyers for me. And I have enough conversations with lawyers, thank you. So we've been talking about AI now for the last day and a bit now. I don't think we've ever sort of taken a step and said, what is AI? So I'm going to do that for us right now. I have a really kind of big tent view on AI. Like, my kind of position is anytime a computer makes a decision, that's AI. So by that argument, an if statement is technically AI. Questionable, but one of the things to keep in mind is that the computer making a decision is the attribute of intelligence. And we know that, there are times when the intelligence is not that great. And, an if statement, probably not the most sophisticated thing in the world. Maybe would be sophisticated enough to run Go, but that's okay. Because at the end of the day, some humans are not that smart either. We wouldn't say that Peter Griffin hasn't got the attribute of intelligence, but we would say that, like, from a qualitative point of view, maybe he hasn't got a significant value of intelligence. So it's more about, when we think about AI, we're thinking more about, like, the attribute rather than the quality. And that justifies me talking about a whole bunch of stuff this morning. So, quick pop quiz. When do you think the first article about game AI was written? Okay. Anybody got a different answer than 1980?
65.
65? Anybody else? We got 80, we got 65. 2004. Okay. $1. 1973. Okay. You guys want to know when the first article on game AI was written? We've been talking about this stuff for 250 years at this point. And that is a point that kind of gets drowned out by a bunch of San Francisco tech bros who want to really convince you that this is something that they invented 2 years ago. In 1770, there was this thing called the Mechanical Turk. The Mechanical Turk was an artificial chess player. And this thing lit up the kind of Bridgerton era kind of social scene. It got toured around castles and ballrooms, and everybody was talking about it because you could sit down and you could play chess against a machine. And that was mind-blowing in 1770, and you can imagine that that was pretty mind-blowing in 1770. Now, about 50 years later, there was a fire. And as a result of the fire in the museum or storage room or whatever it was, they ended up figuring out how this thing worked. And the way that it worked is that it was this kind of, you can see the kind of mannequin of the dude and a big table with a chessboard on top. And it turned out that inside of the table, there was a little space where you could put a person and they could pull a bunch of levers. So this did not actually deliver artificial intelligence, but it's kind of like, it's put it in the zeitgeist since 1770. Now, yesterday's keynote covered a whole bunch of history of AI, so I'm not going to repeat too much of it. But there are a couple of things that didn't come up. And kind of thinking about what the modern era of game AI has looked like, I always reference Miss Pac-Man, which is a game from '82. That was the first time, at least, that we've been able to find that there was non-determinism in the non-player characters. So if you look at the original Pac-Man, you can actually solve that to optimality because the ghosts in that game will respond specifically to your input. So if you go left to begin with, the ghost will always, let's say they go right, they will go right every time. And they will have the same set of responses to the same set of inputs. And that means that for Pac-Man, there is actually optimal ways of playing. And you can go online and you can find these. I don't suggest that you pay that much attention to it because, like, who wants to follow instructions on how to play a game? But that happened. And then Ms. Pac-Man came along and that wasn't true anymore. Those ghosts had personalities and they had biases around how they would respond, but it wasn't deterministic. So for the same set of inputs, you wouldn't necessarily land in the same state. So that's kind of where things started to get a little bit interesting. And then I always like to touch on fear because everybody in the game AI community always likes to touch on fear. It's been 20 years. We probably ought to get over it. But fear is a great example of something from academia making its way into an industry game. So fear uses a system called the Goal-Oriented Action Planner, GOAP. And what that meant was that there was a guy, Jeff Orkin, who's still around today, doing some really interesting stuff at a company called Bitpart.ai, so shout out to Jeff. But GOAP allowed you to kind of combine finite state machines with a more kind of planning-oriented kind of way of substituting things in. So it created a world where the NPCs were actually able to kind of be more responsive, be more kind of intentional in how they were acting. So that's a great example of work that was done in academia for Jeff's thesis, being picked up by, I want to say, Monolith, and kind of put into a game and driven forwards from there. When we talk about game AI, for the last 20 years maybe, we've been talking about this kind of stuff. Making the bad guy shoot back, making the soldiers duck behind cover more realistically. It's been a point of contention for me for many years. Obviously, a couple of years ago, the monkey paw curled, and now we're talking about things from a very different lens. But we've been talking about NPC characters, but there's so much more that we can do with AI. So just a couple of examples here. I know No Man's Sky came up yesterday, very procedurally driven kind of space, a whole bunch of worlds and universes kind of being created procedurally. Left 4 Dead is also a really good example of how we can kind of push the boundaries of how things work in games. So Left 4 Dead is another interesting example of technology moving from academia into the industry. They use what's called a hierarchical concurrent state machine, and that was developed by the University of Idaho as part of a driving simulation system. And it allowed them to kind of control the pacing and be adaptive to user input and still deliver experiences that needed to happen. So you can imagine in a driving simulator, like if you're trying to teach somebody how to drive, then if you've planned a scenario where they get cut off in traffic and you want them to like respond with a hard braking and all the rest, you need to be able to do that independent of how they've been driving previous to that. So that has to kind of just happen at the right time in the right way, no matter where that car has come from, no matter where, what the velocity of the driver's vehicle is. So they developed this system that allowed them to kind of like modulate a scene on the fly effectively. And the folks at Valve said, hey, that looks really cool. Why don't we make zombies about it? And Left 4 Dead actually follows what's called it follows like a narrative pacing arc of horror movies, which is, I don't know much about this stuff, and I'm in a room with a bunch of narrative people, so pardon me while I butcher things for a couple of minutes. So narrative pacing in horror movies kind of, it starts chill, builds up, the intensity builds, and then there's like a peak intensity moment where like all the things are happening and all this stuff is going on. And then like the pace kind of relaxes, the intensity kind of dials down, and your group of teenagers who have been chased through the woods get a couple of minutes reprieve, and then the whole kind of cycle starts over again. Now, how do you bring that into games when the players are going to do different things and all the rest? Well, you use one of these, or a bunch of these hierarchical concurrent state machines, and you're able to kind of hit that same pacing where even the weather effects, the ammo and stuff that you're picking up in the world, and how many zombies are spawning and how they're interacting with you, are all under control of an AI director. And the director is managing that experience in real time. So these are just a couple of things about what we've been able to do for quite a while. Before folks like Sam Altman turned up, we were doing cool stuff. So that kind of brings me to this taxonomy of game AI, and this is actually something that I probably can say we've kind of got internally at this point. It's kind of trying to break out AI into the components that are it. Because at the moment, everybody wants to talk about this one. But when you're making games, all four of them, and arguably, the three on the left are the more impactful ones, and then the one on the right, questionable. So making sure that when we talk about game AI, we're talking about all of it. We should be using all the tools available to us, not just glomming onto the hot new thing that we read about on TechCrunch, VentureBeat, name a thing. But this is called the Transformer Conference, so we need to talk about some of this generative AI stuff, so let's do it. We've talked yesterday about diffusion models and generative art and chat assistants and LLMs, so I'm not going to go kind of crazy deep on this stuff. You kind of have seen a bit about how it works already. This is kind of like, it didn't come out of nowhere. This is one thing to kind of think about on this slide is like, it felt like everything kind of exploded in kind of maybe 22, 23, but this is building on work that has been coming for a long time. Transformers were, I think, that architecture was maybe 2019, the paper was published. And, adversarial networks have been kicking around for a while. Like the things that are the kind of theoretical algorithmic building blocks have just been kicking around for a little while. And honestly, the big breakthrough was taking those kinds of systems and putting them into a chat interface. That's what OpenAI did that was transformative, was not anything about necessarily the math of the thing, but it was about the UX. However, we've got to acknowledge a whole bunch of lawsuits about this stuff. They have just taken everything from the internet and shoved it into one system, and that probably shouldn't be legal. And we'll find out over the next year or two if it is. So there's a whole bunch of lawsuits, and many of them got referenced yesterday. Consistency is still a problem. Control is still a problem. These are things that are not really solved, and they're baked into the nature of how the technology and the algorithms actually work, to a point where there's a lot of effort being put into solving them in a way that is like, well, can you overcome the inherent infeasibility of the algorithm? Or should we maybe stop just pouring a whole bunch of compute at this and hoping that it all gets solved? So you've probably, if you're following the AI space, you've probably heard the word agents being thrown around over the last 3 to 6 months. Agentic systems, multi-agent systems. So about 20 years ago, I took a course on multi-agent systems. This diagram is from a paper, I think this one was from '91. And the point I really want to drive home is most of this stuff existed already. All the buzzwords, all the stuff, it's just a bunch of people who are reinventing the wheel yet again. You remember when they decided that they were going to reinvent a bus, and they were going to do like, oh yeah, we're going to do this thing where like we're going to get big Ubers and we're going to drive them down the street, and you can press a button on your app and get on the, yeah, that's a bus. You know, we're going to do this thing where we're going to build a tunnel and we're going to put like a car in it, and it can go along and you can get from point A to point B. Yeah, that's a fucking subway. Like, what are we doing here? So we need, you know, this has come up actually a few times yesterday, and I'm really happy about that. Because when I say that these lawsuits are outstanding, when I say that they've stolen work from people, like, it's important to remember that. I don't know what the answer is, because the way these systems work, they just grab everything that they can, and then by the time it gets to the finished product, the math has obfuscated what bits of what are being used. So attribution is going to be hard in these current architectures. That's not a reason not to have the conversation. You know, at some point, I've got to be able to look artists at Zynga at Take-Two in the eye and say, hey, you're not why we're putting you out of a job, or I'm not why we're putting you out of a job. And that's an important thing, right? Like, you can draw a line from where we are with AI technology today to the end of capital A art. And that should be scary for everybody at a societal level. You know, the Netflixification of kind of content is maybe not the best thing in the world, but doing that at scale across an entire set of industries could have some really gross implications for everything. You know, we seem to be very much speed-running idiocracy at this point. So, you know, that's great. All right. So the session's called Practical Applications. But honestly, having a rant about some impractical applications is a lot more fun. So that's where we're gonna start. All right. Haven't seen one of these for a little while. But a lot of people kind of think that we're going to take prompt to game. I can write a paragraph, press a button, and get a game. DeepMind's Genie system on the left there has a bunch of prototypes that they've kind of put together. These are actually grabbed from their website. And this is part of the kind of shell game that's played with games. So games are kind of three different things. We've got games as art, games as technical product, and then we've got kind of games as toys. And those three things are quite distinct. This thing on the left is a toy. Like, it's a little platformer that looks good, but it's not a game product, and it's not really a piece of art. It's a toy. So we're using the word game in different ways, and kind of in the kind of framing of the thing, obfuscating the fact that, you know, if they can generate this, that's great. They can't generate actual commercial products. That's not a thing that is going to happen really anytime soon. And this system, Nilo on the right, is a really interesting thing. It's aimed at kids, and it's effectively trying to be Gen AI Roblox. And part of my question is like, well, why is Roblox not going to be Gen AI Roblox? But what they're doing here is, instead of kind of doing the kind of bait and switch on this being kind of a toy game rather than a game, is that these guys are actually getting a lot of success by really limiting the scope of what that game environment is and can do, and kind of constraining to a whole bunch of, or a small bunch of verbs, gives you more control over the space. So that's kind of how these guys are managing to get prompt to very specific implementations of things. So it's not that it kind of can't be done, it's that in order to kind of make it happen, you really have to be very clever about how you define a game. I think I'm going to piss some people off with the next slide. LLMs for NPC dialogue. And NVIDIA's covert protocol demo, which came up yesterday as well. If I have to deal with one more group of people who think that the best thing in the world for games is to take an NPC and anchor an LLM to it, I'm going to lose my mind. This demo, it's fine. Getting hands-on with it, you start to kind of see that some of the stuff that they put online is the good parts of it. Unsurprisingly, that's the game. LLMs anchored to NPCs sounds great, right? It sounds like what should happen. Except, so Sid Meier of Firaxis fame, so obviously Microprose, Firaxis, part of the 2K family, so I am quoting somebody from my own company, but he defines a game as a series of interesting choices. Connecting an NPC to an LLM gives you an awful lot more choices. Doesn't make them interesting. And one of the key things here is that when we're talking about in-game, we're talking about curated experiences. We're talking about systems that are trying to say something. And when you just connect them up to like an all-seeing kind of like, hey, we can just say a bunch of stuff, you lose a lot of the intentionality. You lose a lot of the drive and the point of the thing. And if you look at this covert protocol demo, it's very tightly constrained. Taking a step back and thinking about a interview that John Riccatello did when he was, during his stint as Unity CEO, one of the things that he said was like, wouldn't it be cool if you could play, when you're playing Madden, you could wander around the stadium and like you could like sit in the stands and watch what's happening on the field and talk to the person next to you and like you could get the grandmother's lasagna recipe. No, that wouldn't be cool. Like, I don't start Madden to learn about lasagna. I start Madden, well, I don't start Madden, but like you play Madden for the NFL and for the running the game side of it, not the let's go talk to random people side of it. And this is where like the intentionality of the thing really matters. What are these characters supposed to say? What is their role in the story? Because if you make them fully embodied, you could go out into the real world and talk to fully embodied people out there. It's not super interesting. Vibe coding. Vibe coding is one of the best things in the world ever for about an hour. So for those of you, this came up yesterday as well, but for those of you who don't know, vibe coding is when you sit with one of these assistants and you say, hey, I want to do, X, Y, Z, and it goes off, writes a bunch of code for you, and you run the code, game over. And that's great. So, for a simple project, I want a script that does one thing, great. So one of the things that I do a lot is I DM D&D games, and I'm running one right now that's got, so for the nerds in the room, it's a West Marches game. So there's 26 players in this game. There's a whole bunch of scheduling to kind of figure out. Right, I'm going to vibe code a Discord bot. So got up and running, got a thing, got it hooked into Discord, got some basic commands going. Right, now I want to anchor into the Calendly API for scheduling. Well, first off, it just made up how that API works. But the more the complexity that got introduced with this bot, the more this thing started just tangling itself up in knots. And then you say, hey, actually, this bit and this bit need to be abstracted out, and I need to refactor this thing. Everything breaks. Because like, once you achieve a certain level of complexity, vibe coding is not going to get it done. But you also don't know how your code base works, and it probably doesn't work the way that it looks like it ought to work because it's not been written by a person, it's been written by an idiotic machine that just went, this works. And that's a problem. Because the more that we rely on the vibe coding side of things, the more that we're going to get tech stacks that we don't understand, that we can't maintain, that are just a disaster. So we're kind of exponentially accruing tech debt when we vibe code. And we were already kind of accruing tech debt a little bit faster than we ought to be. So this is kind of problematic, probably not today, but 18 months from now, wow, that's going to suck for everybody. All right. regression to the mean is a really interesting thought with Gen AI. Gen AI has been trained on everything. It's been trained on the entirety of the internet. It's been trained on a whole bunch of images. It's not been trained on the good stuff. It's been trained on the good stuff and the bad stuff and the mediocre stuff. And that's going to look like a Gaussian curve. And that means most of it's going to be mediocre at best. And this kind of ties back into vibe coding and code assistance. You know, one of the things that I've definitely found is that if you're a bad coder, if you don't know how to code, if it's not necessarily, you know, you're not an engineer, you're maybe a designer, great. A coding assistant will make you a mediocre coder. Fantastic. We love that. If you're a good coder, coding assistant will make you a mediocre coder. And this is kind of like the ongoing problem. So in this image here, this is a sailboat. And it's an image out of, I think this one's out of Midjourney from maybe 6 months ago. So argument that maybe things have got better, but they haven't got this much better. This looks boaty as fuck. This looks amazingly like, hey, this is a sailing ship. I know what's going on. We're on the ocean. There's a whole bunch of waves. Great. Now, everything that comes out of an AI system, to me, looks pretty good. I've got the aesthetic sense of a brick. But the thing that I do have, because like my first job was working at a boatyard. I've been doing a lot with boats over the years. I raced sailboats back in Scotland. So I don't know a lot about art, but I know a lot about boats. This is wrong. That being tied off there, that's weird. That shouldn't be done. That is just hanging out. That's not connected to anything. A whole bunch of these ropes do not exist for reasons except to give the vibe of boats. And like, if you don't know what you're looking at, you can look at that and go like, yeah, that's boats. But when you do know what you're looking at, you can look at it and go, wait, hang on, what? Somewhere I've got a different example where the wind is going 180 degrees at different parts of the boat. Like some of it is going to be this way, some of it's coming this way. Because that's not conceptually something that's being represented in these systems. You know, they are just kicking out like, hey, this looks like boats. And if you don't know any better, great. People in your audience, people who are your players, will know better, and this is why a lot of people are dragging, I mean, it's not the only reason, but it's one of the reasons that people are dragging these Gen AI systems. Is like, they're not producing stuff that is actually coherent. They are producing something that just kind of highlights a vibe. All right, that's the ranting done. And we are, well, we're a bit short on time, so let's just keep going through some practical applications. So this is the kind of stuff that I think you should be thinking about when you come to actually implement these things. First question I've got for people is like, do you want to deploy this stuff at runtime or do you want to deploy it at dev time? That's a key consideration. There are certainly areas where deploying an AI system at runtime might make sense, but in general, like having it help with development is probably a safer bet. And this actually comes back to the LLM example. So I talked about how the choices wouldn't be that interesting. Particularly in the free-to-play space, it also creates a really big problem for us because it's not a monetized, or generally, it's not going to be a monetized thing. So your players are going to be able to interact with these NPCs, and that inference has to happen somewhere, and it's going to happen in your tech stack, whether you might, at low scale, maybe you're running that kind of on a desktop machine, but at big scale, you'll be running that in the cloud. So what happens the day that your game, whether it's on itch or Steam or wherever, makes it to the front page of Reddit? Or gets pirated, and this actually happened to somebody. Game gets pirated, and suddenly they have a whole bunch of non-paying users in there. But when they talk to those NPCs and they ask all those questions, they're racking up bills. And that's a problem, because now you've got folks who are not paying, but are costing you. And the margins in games are not so big that you can really afford to do that, particularly because, like, if you want people to monetize somewhere else in the game and you've given them a reason to just hang out and chat with a buddy, you're not moving them to where you need them to be. You're just having them sit and accrue a cloud bill for you. That's concerning. So this is one of the reasons that I think that dev time is a better kind of place to deploy this stuff. The other thing is control. If you deploy it at runtime, you don't get any kind of directorial or authorial control over what it's doing. You just have to trust that it's going to do something that is good for users. If you're at dev time, you get to curate the hell out of it, and you can throw the stuff away that isn't useful. So that's kind of practical piece of advice number one. Stick this stuff at runtime. Stick this stuff at dev time, and maybe be a little bit more concerned about kind of thinking it through when you're putting these things inside of the game themselves. Tools or tech. We talk a lot about models. We talk a lot about all the different things that are happening out in the world. Yesterday, Adobe dropped Firefly v4. It's got a whole bunch of improvements. It's great, allegedly. I don't know. Firefly version 5 is going to be a few months around the corner. ChatGPT is going to have some new image things. Diffusion models, Flux, all these things are leapfrogging each other constantly. Stop caring about the models. The models kind of don't matter. They're going to get incrementally better over time. What matters is the tools and the UX and the workflow. At the end of the day, if you're building this stuff to empower artists, which is what we're trying to do, it kind of doesn't matter which model you're using. I mean, for different applications, different things are going to be better suited. But if you're in a world where you can kind of build out over a bunch of them, it doesn't matter which one's on top. But then you can have a consistency of UX, and you can actually build tools for art teams or for dev teams, for anybody who's working in the space that is consistent, that does what they need it to do. Midjourney caught everybody's attention as a Discord bot, basically. You could go onto Discord and you could type in some stuff and you could get an image. Great. That's not a great workflow if you're a dev studio. Like, that's not great to have to then export out of Discord, do the thing. Took a while for Midjourney to put a web interface in. But stuff like this is pretty close to some of the art tools that the teams are using already today. So they're familiar with it. They understand layers. They understand how to export stuff. Show them the new stuff. Get them working with it. But at the end of the day, if you treat it as a tool and you don't obsess about the models, then the tool will be the tool a week from now, 6 months from now. And it doesn't matter who's doing what in the space. You are basically future-proofing yourself. An area that we kind of focus on asset generation, right? We focus on kind of how we can use it for concept art. How can we maybe use an LLM for designing narrative stuff? Those are low-hanging fruit of varying quality. But some of the stuff that we don't talk about is how we can use these things elsewhere in games. A lot of games have chat in them. A lot of games that have chat in them have massive moderation problems. I mean, this is not new information about how these games work. Systems like this are effectively natural language parsing. And that means that you've got a really good ability to actually, instead of doing kind of player-facing or asset generation or anything like that, just on the back end, be running systems against your chat feed and be like, okay, well, now we're in a much better, more robust position to find stuff that's bad inside of our game and proactively get involved. That's a big opportunity. That's not something that really gets talked about in, it gets talked about in places, but when we're talking about it in a setting like this, it's so easy to focus on like, hey, this is how we're going to get 3D models and 2D images and audio. But stuff like this actually is the stuff that we can't do today that isn't really as ethically concerning, because like we can't do this. We're not putting people out of a job because we can't do it. So by putting systems like this in, we get a better experience, and there's not as much of a human cost to it. And then one thing to always keep in mind is that if you're running a game studio, you're a business. And everything that applies to any kind of enterprise applies to you. Whether that is, an email rewriting assistant, whether it's something that's going to help you parse contracts. I think there's a system called Harvey that's good at that side of things. Whether it's helping you with decks, helping you with branding. But these, again, like, these are the things that are boring as hell, but as a business are becoming kind of table stakes. And that's where there's also kind of not as much emphasis. But like, grab these things, play with them, be aware that like from a 3D object, 2D image kind of point of view, there are legitimate concerns, and there's concerns on the training data source. But at the same time, like the obvious places that you can see to just grab onto and go from a game dev point of view are not the only ones. And when we think about practical applications of AI in games, we could do so much previously. You know, we could do a lot of stuff with AI that a lot of studios thought was witchcraft and did not want to go near. And one of the things that's cool about this moment is that they all want AI now. Everybody wants to do stuff with AI. Now, in their heads, they mean LLMs, they mean diffusion models, but it's all AI. Level generation is something that we've opened the door to because people are more receptive to the conversation. This is an interesting demo from early 2000s, I believe. This is Silent Hill Shattered Memories. And what's really interesting about Silent Hill Shattered Memories is that they had a very rich personalization system. And that was built around an ML system and a player persona system. It's Silent Hill, so it's kind of horror themed, and it opened in a therapist's office. And the therapist is asking questions, and the player character is answering those questions. And the conceit of the thing is that you are kind of getting a psychiatric evaluation. What's actually happening is that the player is getting a psychiatric evaluation. And that created a world where they actually developed a whole bunch of content for this game, and they actually switched between it. So this character is this character, and it's this character. And depending on how you kind of tested on that initial psychiatric evaluation, you get a slightly modified experience. Some billboards get swapped out, some characters get swapped out. There's a slightly different tone shift. Now, the way that they did that was to make 3 sets of everything. It's not the most efficient way of doing it. But at the time, you know, this was groundbreaking. And this was stuff that really kind of showed what personalization can do, because we were playing different games. And now, you know, we see that in branching narratives. You know, your playthrough of Baldur's Gate is going to be very different from my playthrough of Baldur's Gate. But that's based on choices, not kind of trying to assess what we think people want. And that's the important thing. You know, my thing for the last 15 years has been that AI in games should follow D&D. The Dungeon Master manages that game experience. They start out by figuring out who's going to sit at the table. You know, the social composition, the psychological profiling of like, well, I'm not going to put that person and that person together because that will go badly. Alternatively, maybe you do that. But a Dungeon Master is controlling the matchmaking, they're controlling the narrative pacing, they're controlling the combat encounters, they're controlling the economy. They're controlling all of these things in a human-led way. And if we think about what AI could be for games, ultimately it's about taking the Dungeon Master human away and replacing it with an AI, at least for me. And that's probably because I grew up as an only child in a bit of a rural situation where like, I didn't have people to play these games with. So like being able to play them with fewer people, that's my jam. But this is stuff that we can do. You know, we've been able to do it long before these new systems showed up, but we didn't compose all the pieces together. And this is kind of leading up to all the stuff that we're talking about. Cool. It's low-hanging fruit. The real question for me, the thing that I want to chase is, like, okay, what new game experiences can we give people as a result of these technologies? And I'm going to answer to it. If I had an answer to it, I probably wouldn't be able to tell you. But this is the star in the sky. It's more important than we can make images quicker. We can, you know, make our 3D objects just integrated into our pipeline. It's more important than all of that stuff because this is again stuff that we couldn't do before. We can't do it today either, but we're going to figure it out. So part of what I wanted to give you is like a rubric of practicality. Like when we think about practical applications, how should you be thinking about it? Cost is important. And a thing to keep in mind is a lot of these systems are being sold under cost. Classic private equity and VC model where, they did this with Uber. They funded the hell out of Uber. Uber came in super cheap, ran the taxis kind of into the background, and then Uber jacked the prices up because they got you locked in. That's going to happen with a bunch of these things. They are going to become more expensive. How do you control for that? How do you control for users who can touch things, maybe racking up bills like we were talking about earlier? Speed is a big factor. Like, how do you make sure that you can make things fast? I mean, this is the promise of AI, right? You can kind of make your pipelines run a whole lot faster. But do you need to? Maybe, maybe not. So keeping in mind that speed is important, scale is also important. If I want to create like a Silent Hill Shattered Memories, making 3 sets of content is 3 times the work. But there's a reason for doing it. So now we're sort of like, okay, well, let's do it this way. It's faster. Maybe it's a third of the time, which means that we can do 3 in the same amount of time. Control is important. Maintaining that authorial control is critical. Like, your game is supposed to be a piece of art that is making a point or saying something. Don't let ChatGPT say something for you, because that's like not remotely interesting. And like I was saying earlier, future-proofing. What's going to happen next is a whole bunch more models are going to get dropped and everybody's going to hype out about them and it's all going to be fine. They're going to be incremental improvements. So how do you make sure that you're agnostic to those improvements? If you're really tightly coupled with OpenAI, you can't benefit from DeepSeek, which came out a couple of months ago. It came out yesterday. DeepSeek came out of left field, and everybody was trying to scramble to react to it. A lot of where my attention is like a layer up, which meant that we could just kind of get DeepSeek deployed, and it was in the tools that we already had. So kind of keeping in mind that that is what's happening. We're in this kind of weird arms race between tech companies, and we're kind of caught in the middle. So making sure that you understand that that advancement is still going to continue. So how do you leverage it? Here's the big thing, though. This is the important one. So the original IBM is a computer can never be held accountable. Therefore, a computer must never make a management decision. I prefer this framing. But this is important. We can't abdicate our decision-making to these systems because they are not decision-making systems. They are predictive systems of spit out the next word. They don't know things. They don't understand facts. That's not a concept that's kind of part of the math. So one of the kind of core things that I often push back on is like, are we actually automating a business decision here? Because that's a terrible idea. Let's not do that. Let's make sure that it is assistive to a human, maybe, but the human can say, whoa, don't think that's right. Let's not do that. I've certainly seen proposals for like, well, we asked ChatGPT what game we should make. That's really bad. Don't do that. This is something that we're seeing across industries, right? AI is being introduced into insurance claim approvals and more often denials. That seems not great. Actual humans need to make decisions. These things can inform them, but if they're making the decisions, wow, things are going to end up real bad. Idiocracy might be the best case if we go down that route. The Matrix is maybe where we land up. So I did want to kind of leave you with some final thoughts, and I know I'm a little bit over, but I'll just jam through this as quick as I can. This is Pixar. And the moment that we're in right now feels a lot to me like where Pixar was maybe 20, 30 years ago. So Pixar started as a spin-out from the University of Utah. There's a bit more history and backstory to it. Creativity Inc. is a really good book if you're interested in this stuff. But the punchline is that the Pixar folks, Ed Catmull and his co-founders, wanted to understand what movie making with digital tools would look like. And at the time, the state of the art was Disney animation. Like, Disney has always been the pinnacle of this stuff. And what they would do is they had a whole bunch of artists who sat and drew frame by frame. Now, there's a world where you say, okay, we're going to be digital. And you can imagine the executives saying it in exactly that way. And what you do is you take Photoshop and you give them like a tablet and you say, cool, you're doing this digitally now and you're still drawing frame by frame, but you're doing it in Photoshop. Congratulations, digital. That's not what good ended up looking like. Good ended up looking like stuff like Maya, stuff like Autodesk, actually building 3D scenes and then rendering it out as 2D. What we're seeing today is today's workflows getting AI crammed into them, mostly to satisfy investors. You know, half of the features that are being rammed down our throats are not actually that useful. But they're trying to fit it into an existing workflow. What is the new workflow? What does it look like to make games in an AI kind of native way? That's a big outstanding question. It probably does not look like Photoshop, Perforce, all the things. You know, it doesn't look like the tool chain we have today. We don't know what it's going to look like, though. The magic trick is done. Everybody wants to think that AI is this thing on the left. It's just going to go up and up and up and up and up. You know, the next ChatGPT, the next Claude is going to be exponentially better than the previous one. It's not. Unless we fundamentally change the architecture, and that's some of what's kind of starting to happen in some of these papers, we're here. And we're actually here because everybody sort of started paying attention maybe here, but AI started here. AI started, you know, best part of 60 years ago, 70 years ago. You know, this is not a new thing. This is not something that's taken off and going up through the roof. It's something where we've had a step function, we've had a transition into these new systems, but now they're starting to plateau. You know, they've been talking about ChatGPT 5 for a long time.
Okay, so last year we had the great pleasure of Fernando Aragon talking about the work he was setting up at the Gwinnett Public Libraries and also at Gwinnett Tech, where he teaches, and at Georgia State, where he teaches, I'm not sure which classes in which place, but advanced artificial intelligence and games, and game development in general. And today he's going to show some of the work that he's been doing with two of his favorite students, I'm hoping, Tyler Hoyt and Dominique Hodges.
Thanks, Stove.
It's not amplified,
it's only for the screen. It's only for the screen? Oh, for the stream? Okay. Well, thank you for the introduction, and I'm so happy to be back. Like Dove mentioned, my name is Fernando Aragon. I've had the pleasure of teaching game development since 2020. In 2020, Gwinnett Tech hired me, took a chance on me. It was great. It was, you know, new into the game dev space, but started teaching with the intro to game development and then started teaching their advanced AI for gaming courses. In 2022, I started teaching at Georgia State University as an adjunct. I would teach the fundamentals of game art class and the programming for games 2 classes. So overall, all the classes, it's been based in Unity. So last year, I gave a presentation on curricula evolution and academic integrity for AI for gaming. So like I mentioned, I started teaching in 2020. Got the groove of teaching AI for gaming, and then all of a sudden, 2022, November, something big happened. And I'm like, all right, now we've got to evolve. You know, how do I feel about it? How does curriculum look? So I highly recommend checking out the presentation from last year. It's just a screenshot. It's on the GGDA website. YouTube channel, yeah. And so you'll get a background on my points of view there. So in that session, I talked about how I created an in-class assignment so students would be able to play with a local large language model in Unity. And that kind of spawned from, I was, dabbling, playing around with local LLMs, just what I was doing in my personal time. And I have an unhealthy obsession with Raspberry Pis. And so that's when I downloaded Ollama, started playing around with Llama and Gemma, and got into the adjusting the model files. So changing the system prompt for the LLM, like for example, you're a humble farmer living in a peaceful village. You love to talk about crops, seasons, livestock, and daily life on the farm. You don't know much about the outside world beyond farming, and then tweaking some parameters. And this got me thinking. I was just like, hey, this is kind of fun, and I could see this being like used in as an NPC in a game. And I'm just playing around, toying around with it. And at the same time, I was thinking, how can I start implementing generative AI in the classroom for the AI for gaming, while also still maintaining that core AI for gaming curriculum, like fuzzy logic, procedural content generation, pathfinding, etc. So I did an in-class assignment, and in the video I do there's a demonstration of it where the students download LLM for Unity, and they tweak the parameters and just have interactions with the LLMs. And doing that, I was able to get feedback from the students on, all right, so what are your thoughts? And introduce them to just what's out there, because it's really important that they're exposed to what's going on in the world of generative AI, not just in game development. So so that assignment went pretty well. So then I decided that in the fall, this past fall, I was going to challenge the students to actually create a game for their project, actual like homework. It's like, all right, you're going to use LLM for Unity, and we're going to download a model, and I want you just to have fun with it. Let's play. Let's experiment. And Tyler and Dominique, who you'll hear from in a second, they stepped up to the challenge, and they're like, we got this. And I had to do kind of like a rah-rah speech. I was like, all right, guys, this is what we're going to do. I was like, I don't even know all the ins and outs of this package. I'm learning just along with y'all. We're going to learn this together. So it's just kind of like, we in this? All right. And it's just like, and we don't have to like it. If we like it, great. If it's fun, awesome. If it's not fun, hey, the important thing is you're going to be a part of the conversation, this ongoing conversation where we're all trying to figure this out, right? So that being said, they took the assignment and just blew it out of the water. I mean, it turned into a multi-week assignment. They learned things that I had never even thought of, and it was truly an enlightening experience. So enough rambling from me. They're the stars of the show. They're going to come up here, talk about how they implemented local large language models into their Unity game, the pros, the cons, and yeah. So that being said, Dominique Hodges, go ahead and come on up.
So like he said, we started going through trying to experiment with the LLM, and this is the premise of the game that I came up with. So it's got 3 different creatures of different species that invaded different time periods, and they are disguised as local NPCs. And in order to find out who the culprit is, or the ones that's committing crimes and things of that sort in disguise, The player disguises themselves, and you have to interact with them. And this is all through the LLM system, where you're talking and communicating directly with these NPCs. So you'll see here the ancient era, the medieval, and the modern era, and everything kind of warps depending on that. Now, once you think you found out who the culprit is, each stage has its own turn-in location, and then when you turn in, it'll take you here, where you'll activate a console, and it'll summon the NPC. Once you hit the NPC, if you're correct, it'll break the disguise, and you'll engage in one of the 3 boss fights. And if you're wrong, well, you get a game over, because you just killed an innocent civilian. So this is leveraging all the NPCs are using large language models. So instead of a typical mystery style game where you have set dialogue and dialogue trees where everything's already set and standard and you just have options that you're toggling through, instead everything is through the LLM. So I set an introductory message for each NPC, as you can see here, and then you just directly ask whatever kind of questions. So instead of you having a set story that you're just following along and you have to make those choices, now the amount of information that you gather is based off how good the quality of the question that you're asking these NPCs are. And you can see here, then he starts to answer based on the personality and things that I've instilled in the prompt through the inspector in Unity. And then based off of the personality, you'll get different responses. Like for here in the ancient, he's saying unga unga because he's like a caveman. It's the ancient era. So everything's time specific and is based off of the personalities. And then I also encoded hard limitations. So you can only interact with each NPC up to 6 times. And that's to incentivize the players to not just throw a bunch of different questions and potentially break things, but keep things in line and actually have you be incentivized to use quality questions. Because if you don't have those questions, you'll never be able to progress. You'll just continue to lose. So getting into some of the pros and the cons of the experience. So it does help make the NPCs feel a little bit more human-like. You know, they're much more responsive. They're less repetitious. It's not quite as robotic. You know, it's not like the standard practice where you have the dialogue tree and you have set dialogue and it'll just repeat infinitely. Instead, it's more engaging because you're actually asking a question and then you're getting an actual response to that. And it also makes it a lot easier to conceptualize or create these NPCs because you don't have to do, you know, the dialogue trees and all the scripting and the coding. Instead, you just instill a prompt into them and then they'll kind of take over from there. And because of that, it's great for any kind of lesser characters, any kind of side characters, or any kind of idle chatter, anything like that. But I wouldn't use it for anything too major or like the main story, but using it more so for the side characters because then you're not having to worry about crafting all those things. It's a little bit less stuff that you'd have to worry about. And because of that, I can see that becoming much more popular in the future because it is easy for these side characters or NPCs because you don't have to go and do all the extra work that we already have to do now. And you tend to not do that much for these side characters. You do that for your main characters and your main story, but you don't do that so much for the side characters. But this kind of adds a little bit more life or flavor to those side characters. And as was mentioned in the keynote, the LLM that we're using is a free add-on that you can get in Unity itself. And that's what I use. And I used Llama because it was very good with the prompt management. And I use the tiniest version, which will be important later. So now getting more into some of the cons. It can be a pretty rough starting point. There's a lot of issues with the Unity engine once you start implementing the LLM software, especially if you don't change very specific settings. There's a setting in the inspector called parallel prompts. You need to make sure that you change that because if you don't, you're going to wind up with infinite loading screens, you're going to wind up with a bunch of crashes, and you just won't be able to proceed or get any kind of work done. And even once you change that, it's still going to slow down the workflow because it's going to add more lag, it's going to add more loading time whenever you're trying to test any kind of anything or whenever you're trying to load up a scene. And that also heavily depends on the PC that you're running. If you're working on some kind of optimal high-end spec, it's not going to affect you quite as much. But if you're working on something a little bit suboptimal, it's going to greatly increase how much time it's going to take for you to actually proceed with any kind of work. And that's not only important as a developer, but also on the player side, because that can also inflict or it can change the minimum specifications that you need in order to be able to optimally experience the game. You don't want to be sitting in 5-minute long loading scenes because your computer's not able to run it. So we have to take all those things into consideration. And then due to the fact of it being an LLM, and we're not tailor making all the dialogue, it's hard to get it to give you exactly what you want and get the exact kind of responses and the story that you want. And even when you do get it on the same guidelines, you're going to wind up with a lot of idle chatter. You're going to wind up with like stage style directions, grumblings, or eerily looks to the left, you know, things like that that can distract you or can be a dead giveaway depending on the nature of your game. And then if you have any kind of plans on doing voice acting or voiceovers or animations where the mouth is supposed to match the words, that's going to be pretty difficult because these things aren't set in stone. So then you'd have to find some kind of other thing that you can add in addition to that that's doing it in real time to match. And the biggest obstacle that you're going to face is hallucinations. There's going to be a lot of different times where it's just going to randomly say stuff. There was times where, you know, I'm in the medieval setting and I'm giving them a certain amount of people that they can suspect. And then all of a sudden they'll pull out some random name and they'll go on a witch hunt. And it's like, I didn't say any of those things. But those are the kind of battles that you're going to fight as you're going through it. And that's kind of the issue with this, is you're going to be constantly fighting a battle of trying to get it to be what you want it to be. And it's very inconsistent. Even when you finally think you got it working, it'll only work maybe 80% of the time. And then the other 20%, you're crying, you're punching a hole in your computer, frustrated, because you can't get it to work, you don't know what's going on, and it's super frustrating. And that kind of takes me into the overall feelings I had going into the project. And that's that it feels like there's much more cons right now instead of pros. I do think if you are going to integrate it, it can't be a standalone thing. You still need to use it as a hybrid, where it's best to still have the standard practices that we're already doing with your dialogue trees and hierarchies and things of that sort. But if you want to use it for, like I said, the side characters or lesser NPCs or any kind of idle chatter, it can be pretty good for that. And because of how rough the starting process is and the distribution of work and how much you're actually able to get done, it is pretty rough to really recommend. But I can see, you know, the usage that it could have in the future. But as of right now, I think it still definitely needs much more work. And because of that, I'm not a huge fan, but I am very grateful for the experience that I had to be able to have a hands-on experience, be able to be in that conversation. And then I can see, you know, how it can be integrated. And as it becomes better, I can integrate it. I've already done the groundwork. I've done the hardest part. So as it gets better, and if I want to implement it, I can. And I've already done that. So that'll do it for me, and I'm going to go ahead and turn it over to Tyler.
Thank you so much. So, I created a game called Pack Mentality. Has everyone here played Among Us or at least heard of Among Us? Excellent. So, it is a derivative of a social experiment game called Werewolf or Mafia, and that is what my game Pack Mentality is also derivative of, right? And so, the game mechanics. The number of AI, so I take a step back. I did a lot of my building dynamically, so number of AI is determined by game size, and it's also determined by the number of players. Players being human and AI are randomly distributed roles. I'll explain those in a second. And through conversation with AI humans determines the wolf or moves suspicion. Very similar to Among Us, right, with the imposters. Cool. Every midday, you have to vote on who the werewolf is. This will become tricky with the LLM, and I'll explain that in a second. So, wolf can kill one player a night, or infect to add to the chaos, right? Because you can bite, now you're a werewolf. Excellent. Hunter can set traps to protect from the werewolf. The seer gets to decide which player gets to see one of the roles of the player, and then the villager doesn't get any special powers except for conversation. Cool. Now, implementing the actual LLM. These become important because I was doing everything originally by just creating the LLM, giving it the prompt, and say, hey, this is who you are, this is what you're doing, go do the thing. That did not work, okay? LLMs are really cool for dialogue. They do not do logic well, which makes sense for brain because you have one for like conversing and one for math, and all these jobs are broken up. So then I decided to break up the jobs. I have a human trust level, which does the math every time you interact with it. It adds something to it. But if you walk up and start cursing at one of these bots, well, it's not going to trust you. So if I walk up, start cursing at it, and then say, hey, Jessica's the werewolf, it's not going to trust you, and it's not going to believe you when you say Jessica's the werewolf, and then it's going to say, oh, well, you're probably the werewolf. So then that's going to, instead of adding to its suspicion dictionary, which is also built dynamically depending on the bots and the player, instead of adding a point to Jessica's spot in the suspicion dictionary, it's going to add to your spot in the suspicion dictionary. So then it also has the prompt. The prompt, which is randomized based on the role, and also with the world building, and then the secrecy prompt, which I'll explain everything a bit more, but basically it's just saying, hey, this is your role. If they ask about your role or if you're a bot, don't tell them any of that ever, right? And all this gives you a feeling that you're actually speaking to a person and somebody who's playing a game with you, because my whole concept was basically, what if we had this werewolf game with AI? Or what if, because my holistic goal with this long term is to also add multiplayer, because if you're with buddies and you pick a game size 4 and there's 4 people, okay, no AI. But if you have 4 buddies and it's 8, well then you and the AI and you have to figure out what's going on. I think that is finding the fun. But anyway, this is where it gets really, really cool, because like I said, the bots are spawned, LLM is assigned. Like he said with parallel prompts, there's only one actual LLM in world, and then the parallel prompts are decided based on the number of bots. So the LLM is assigned. Depending on which role it is, it gets broken down, and then we give it the world building prompt. This was also super important because at any point when you walk up to it and say, hey, what's going on? I wanted it to be able to say, oh, well, I've been hearing some rumblings and little Timmy went missing, or some version of that, right? Within the bounds that I gave it. Now, one thing that is also super important, notice that the only thing that goes to the or from the LLM brain is response to the player. Who to vote for doesn't come from the LLM brain anymore. It just comes from the suspicion dictionary. So I had to realize that I have to parse all of the input from the player to get the who to vote for, which leads me to my actual findings, and I can bring that back up towards the end of it if anybody's interested, or please ask me afterwards. We are, and this is a lot of points. The point is, I couldn't trust it to reliably give me who it thought the wolf was. Even when I was like, hey, I would create lists, I would destroy the parts of the list when they would be killed or destroyed or whatever, and it still just couldn't reliably give me who it thought the wolf was. And long story short, we're the coders. We should write the code, we should do the logic, the LLM should do the talking. And piggybacking off of what my friend Dom said is, I think that there is a bit more cons to do this smoothly when it comes to allowing them to be a part of the core mechanics. I think there is a whole lot of potential in this kind of technology, as long as we don't trust it. This is the key sentence here. It can be problematic if we expect too much of it. So LLMs, generative large language models, the key word there, I think, is language. Let it be dialogue. Let it be for one-off NPCs. Don't trust it to be your quest givers. I don't think, you know? And again, we do the logic, we do the math, we do the game design. Let it just be the dialogue. So, oh, no, go back. Thank you for having us, for all three of us.
Questions after Aaron's presentation? So write down your questions.
Introduce you. So Aaron Farr is the Chief Technology Officer of Jam and Tea. game studio that's AI native, AI centric, I guess. And they produced a game called Retail Mage, which I urge everybody to play tomorrow out in the lobby. And among the miraculous things he's done with it, it's a multiplayer game, and he's managed to reduce the cost of playing the game from hundreds of dollars per session to dimes per session, which might be an economic model that works.
Let's just find the right display here.
Did you?
I'm plugged in. I just need to drag to the right display.
I don't know what he did before Jam and Tea, but
I was at Riot Games for 7 years. I was CTO effectively at Singularity 6. We shipped a cozy MMO called Palia. I did mobile and social games out of Hong Kong in the 2000s. So that is a little bit about me, and we're going to mirror these. Let's see if that works. And keep these changes. All right, good. There we go. Let's slideshow. Okay, this talk is going to maybe be a little bit more technical, but we're going to go through and try to share as much as we can, and we will try to do this on time. Yes, I'm Aaron. I represent a couple of folks on our team that had worked on this project. Carl's my co-founder, Yudi's the ML engineer, Naaman Gupta is a student at Ph.D. candidate at Stanford that we've been working with on a couple of different research projects. So we're going to talk about Retail Mage. Retail Mage is available on Steam. It is one of a handful of actual AI native games that exist today. Little Umbrella, Timothy, you're going to be talking tomorrow, right? Is going to be sharing one of the other few released AI native games. It's essentially a job simulator. And the way I describe it to people is it's late stage capitalism comes for Diagon Alley. So you are a mage at Mage Mart. You need to deal with, you got 30 minutes to close. You've got to deal with the crazy customers who come in. And well, hopefully it goes well for you. Here is the trailer. All right, so that is, oh, didn't mean to close that. So that's the game. Oh, that was amusing, but we don't need to watch it again. Actually, before I go into some of the problems that we faced and how we solved them, let me give a little bit of a description of what you're doing again in the game. So an example of what I think of like as new gameplay that was not possible. So in one play test, you have an AI, you're the mage, you're the employee, a wizard comes in, and their quest is basically, I want something to inspire me for my next spell, right? So it's not anything specific. It's not like I need this particular item. So you talk to the character, and in this one play test, player was able to convince the wizard that a particular painting on the wall was the thing he needed. So for various reasons in the game, the way that you make the sale is you have to take an item in the store, put it in your inventory, and then hand that item to the character. But being a role-playing game, or being a video game, there are stats, how strong you are, how smart you are, things like that. And this character was too weak to do that. They could not take that painting off the wall. It was like, nope, nah, not you. And so they're like, well, I can't complete the sale. I've convinced the wizard that I need to give them this painting, and I'm too weak to do it. So what do I do? So they ran around the store. They found one of the bookcases. They pulled a book off the bookcase. They ripped a piece of paper out of the bookcase. They wrote IOU on the piece of paper, handed that to the wizard, and said, "We'll ship it to you later." And the wizard was like, "Great, 4 out of 5 stars." None of that was programmed ahead of time. right? All of that was emergent behavior. And that is what we think we mean by AI native video games and how it creates new types of experiences. That said, this was near impossible to ship, right? When we started, that 4-player 30-minute session could cost $200 in OpenAI token costs in early 2024, all right, per session, right? When we shipped it in late 2024, we had that down to 50 cents. The way that we had to do a lot, and I'm going to share a little bit about what we learned from it. But I think this is a challenge, and it's a challenge that the AI industry is not going to solve for you if you're in the game industry. Because, you know, to be frank, if it takes me 2 minutes or 40 minutes to do a AI coding exercise, that's still faster than a lot of engineers. It doesn't really matter. But I can't wait for 40 minutes to do that in a video game, right? So we need it fast, we need it accurate, because we're talking back to a game engine, for example, and we need it cheap, because we're going to do lots of these. This game is written in Unreal 5, and all of the AI processing is happening in the cloud in AWS. We don't do on-device because it was not reliable enough, and that's a whole other story. We could talk about where we think we're at with on-device. So an example, this is another example I'll give. Make a sandwich. Make a sandwich is an example I usually give because this is a magical IKEA. There are meatballs. So if a player walks in and says, make a sandwich, what does the AI needs to do? The AI needs to delete one of the meatballs out of the world. The AI needs to look in their backpack and realize it should delete the bread that's in their backpack. It should delete the cheese that's in their backpack. And it should create a new meatball sandwich in their backpack. And if it does not do all of those things, then we've broken immersion. Right? So if a player just says, all the player's going to say or type is, make a sandwich, while targeting that meatball, and the AI needs to figure out all of those 4 transactions. And that's the challenge. Now, we do a lot of other things. We do dynamic dialogue, we do planning, but this interaction has been one of the ones that a lot of the systems struggled with. So the answer is orchestrate. Prompt orchestration, this is one of many techniques, but this is the one that I'll share today, is prompt orchestration. So don't do one big prompt, break it into lots and lots of small prompts. That's the main idea here. In fact, it relates to a game design principle that we have at our studio that we steal from the tabletop role-playing game community called rulings over rules. So you can think of primarily that we mainly develop video games on rules, even with heuristics and you know, a randomized procedural logic. It's primarily rule-based systems. And what machine learning allows us to do is a ruling. At least that's what I try to help my designers understand, is that it allows us to take a much, much broader data set, larger input set, and create a ruling off of it. The idea is to be very intentional when you're creating your game system as to when you want a ruling and when you want a rule. And you should use both. So as was said before, you know, there are some things you don't want the large language model to do. Don't make it do math if it doesn't need to. So one way that we do this is an example of the kind of breaking the problem down. You can think of that a reasoning model might reason these steps through. Hey, I need to make a sandwich. So what should I do? I should understand, you know, what does make a sandwich is? What type of interaction is that, right? There's probably, we have about 20 some different interactions. You know, this is maybe combining objects or creating a new object or casting a spell. What is it? What are the impacts? Meaning like that strength, the intelligence, you know, is the thing on fire? What other labels does the object have? Is it fireproof? Resolve it and translate it in a way that can be sent back. The trick, though, is if you just have even a reasoning model do this, it will only do so well. This is an actual trace of all of the inference that happens when we make a sandwich, right? So this is, each one of those little blue lines is essentially a small little prompt. And it's all happening very fast. We manage the inference directly on the GPU. We manage the KV cache, we manage everything, so that all of this, now in this case, this will take about 5 seconds. Usually most of our things will take 2 seconds or less. And you'll notice that, for example, we will do lots of inference in parallel, and we'll structure it. It actually is even a little more crazy than that, but that's the best way to visualize it in 2 dimensions. So this is an example of prompt orchestration. And what it means is that we're able to take a small model. In the case of Retail Mage, we released it in late 2024 using Gemma 2, a 9 billion parameter model. And we were able to get better results out of Gemma 2 than we would have gotten out of any other large model at the time, GPT-4, GPT-5 even later. And it works pretty fast. Now, Gemma 2, if I had asked that question to make a sandwich, would it do it well? No, horrible. But if I ask it, you know, is bread relevant to making a sandwich? It won't answer that question. It'll answer that question very well and reliably. So the idea is to be intentional about what you're asking your models, and when you orchestrate them, you can get them to do a lot more than you would otherwise. Now, last part, something we've more recently done. We're releasing some material about this here soon. I should have already had some of this published. So a year and a half later, end of last year, one question we had ourselves, because we built this in mid-2024, is that was prior to reasoning models, prior to DeepSeek, prior to O1, is do we still need to orchestrate, right? Like, you know, now that we have reasoning models, could we do this with just giving those big prompts to a reasoning model? And so we basically kind of flipped back and said, can we take this orchestration, go back to templated prompts? We had about 150 some test cases that we had built up from regression tests for that game. And we wanted to see, could the latest models pass these tests if we did like a prompt template? And the answer is no. The answer was the best we got was about 50%. I actually think that with a bit more work, so this is about 3-4 months of work. We actually engaged, using AWS, we actually engaged Mission Cloud to help us with further evaluation. I think that with more work, we might get up to 60 or 70% best tests passing on this. But even when they would pass, often it would still end up being more expensive or slower, right? So it would pass, but it'd be like 40 seconds. DeepSeek actually did really, really well on this test, although that said. So I think it is possible. But why is it hard wrapping up here? So this is one of the tests that like a lot of the models would have a challenge with. The question is bake a pie, and in the player's inventory is an apple, poisoned sugar, towel, and a sword. And so what they have to do is recognize that bake a pie, they're going to combine items, but one that was really hard for a lot of them is that the pie should end up being poisoned because they use poisoned sugar, right? And so it has to have a poison trait associated with it. And again, just having so despite the fact that large language models can write incredible software these days, right? Cloud Code is very impressive. Being able to do some of these other problems can be very challenging for even a state-of-the-art model on its own, particularly doing it fast enough and cheap enough to be able to run. So some of my advice, you're going to get your hands dirty if you're going to actually build games like this. On all of the game side, but also on the machine learning side. Currently, state of the art today. I do believe in the future we'll have new tools and new products that will make this easier. But yeah, you need to break. I recommend looking at prompt orchestration if you're looking for like types of open source libraries that do this. An example would be like LangChain, LangGraph, but there are many, many, many others like it. We actually have our own that we have built. We are considering open sourcing it. That's a whole other story. But when you do this, it allows you to really constrain that model, right? Think about what the rulings are at that lower level. Like, what do you want it to make a ruling about? How much can you constrain it? Both from how small of a question you're asking, but also using all the techniques that we have with modern inference frameworks like constraint generation, grammar support. You can constrain a response to a JSON schema, in fact. But you will not always get that feature if you just use whatever chat completions API is available. If you think of that API to a large language model as a black box, you will not get this. You need to get your hands dirty. You probably need to work directly against one of the inference frameworks like LVVMs, SGLang, Llama CPP, or similar. So the kind of takeaways, I would suggest that if you're trying to build these type of products, orchestrate, don't prompt, constrain your outputs. There are ways to measure, right? Like you can do a lot of benchmarks and measurements. Track of everything. You build out evals. We have 200 some test suites for Retail Mage. We have a whole other feature test like smoke test that we can run in-game, in-engine, and it is possible to use this for smaller models. In this case, while we tested with fine-tuning as well, we actually released Retail Mage on a non-fine-tuned vanilla Gemma 2 9 billion parameter model. Fine-tuning only tends to make it a little better. We are still, I think, a ways away from being able to solve these problems on device. So I think right now that if you want these type of things, you're still looking at in cloud. But I think we'll eventually get there. So thank you.
Give you all chairs this time instead of everyone standing.
You should remember the panel.
That was excellent. Thanks. I really enjoyed that. Good.
Cheers. All right. Let me pass these around.
Question.
I think I saw it.
Yeah, sure.
Yeah.
That's you.
So Aaron, how are you monetizing the loss?
Great question. Great question. So if you go onto Steam right now, Retail Mage is $5 because at this point we've largely recouped what we need to, and we have other operations, so we've optimized it, and we just kind of eat some of the extra GPU costs. I will say our goal. Wow. Julian had mentioned this. So we released it at our goal was to try to release it like an indie game. So we released it, I think it's never been more than, say, $15. But we intentionally built the game so that you probably wouldn't play it that long. It's a 30-minute game. You can play with up to 4 players. Most people will play, about less than 3 hours of the game, maybe 6 hours, right? So our goal was to really kind of release this as an experiment. So there are a lot of retention mechanics and metagame progression that we did not include because we would have had to have a different type of monetization for it. And so, as long as we had enough people paying that, like your $10 covered the inference that you have. But I will say that the design of that architecture is best used if or when you could keep a game up and running all the time. Like that you had a relatively constant CCU.
So I know you guys were mentioning that it's really good to use the models as like background things and background chatter. How would you go about like implementing that in a game in which it's just like chatter of like walking by something? Like you just hear people in the background just chatting. And how would you implement that?
Oh, so essentially, to paraphrase, how would you have it as background NPC idle chatter? So I would do it kind of like the graph that I showed, skipping all that, just giving a built-in LLM, not built-in, but the local LLM world building prompt, in the sense of you are kind of stealing from your slide. You're a farmer. You don't know anything but your farm. This is the world. This is the game that I created. You could use like a voice actor or a voice AI, whichever, and I'm not getting into the legality of anything. I'm just saying as an example. And so you just have it running and rambling. You could have the 2 parallel prompts, so they're taking their turns. But yeah, you just have that set, whether it's in Unity, so it's an audio source, and they're just going and rambling. And so I think I'm trying not to think at the code and get too technical, but you just set it up and let it go. And in the same sense of having an NPC where you go to talk to them, you can have that back and forth of the LLM speaking, just like you saw in a lot of our pictures where you type into it, ask it a question, and it rambles back. But when it's background noise, it's even simpler because you don't have to have that kind of wait for it to press enter. You could have it on some kind of like for loop with a timer, if you will, just waiting for it to go on to the next one or back and forth. I think it would be rather simple, just depending on, or really wait for a collision of the player to start. Like if once you enter this specific place, that's when it starts. So. Please.
And if you wanted a little bit more control of it too, you could also create like a list that it would run as a system message to have it improvise the certain prompts or guidelines that you want as background chatter. So then it's not just idle conversation. You have some kind of control of the background conversation, because you don't want it to spiral too far out of control, because if it's just infinitely going, it will start to hallucinate and you're going to wind up getting a lot of stuff you could get in trouble for. So you got to have some kind of measurement in order to keep it in line. And that's the biggest battle that we faced, was trying to constrain things, trying to hold it back, because it just wants to go. You know, it'll answer any question that you give it. It won't give you the answer you want, but it'll give you an answer. So it's trying to constrain it and give it how you actually need it to function. And that's the biggest challenge.
Anybody else want to tack on?
I'm good. Next question. So the first question was, did we consider multiple models, including local and remote? We certainly considered it. The sense in 2024, and I would argue even today, there's a real challenge in having reliable local models that will work on any given hardware. Right, you can do a lot. It's pretty limited. The test that we primarily looked at was adding on-device voice support, and I think you can again do various different components. There is a company, another studio out there called Studio Teleco. They're just released, are talking about a game that they're working on, and they are very focused on local models. And I recommend, like, if people are trying to learn what local models are able to do, look at the stuff that Piero and they are at Studio Teleco. I think we've also considered, would we do specific fine-tuned models for like given characters or for given routines? And I do think that there's an advantage there. Our expectation was to use LoRa adapters for that. The challenge and trade-off comes with operational complexity, because depending on how much you do there, you can get quite a bit of number of models that you'll end up with, and you need to manage those models somehow on the back end, which is possible. It's just additional complexity. I'll just say we hired someone to do that. We realized halfway through, like, oh, this is a big enough problem. We actually need to give someone a full-time job just to do this. And there's a lot out of that. But yes, the simple answer was yes. We needed someone focused just on that problem, and QAing AI games is an unsolved problem, period.
Yes, and we'll just go down the line because I'm sure we all had this issue. That's kind of what led me to breaking up the logic away from my LLM when it came to the voting aspect. That was the biggest problem, was it would either vote for the exact same person or someone who wasn't even on the playing field. I'm like, who is Tiffany? She's not in the village right now. That's not even in the list of names to pick from. So once I got that logic tight, and just like with every game, I'm like, okay, cool. I've worked so hard. I love this, or maybe I hate this week. I don't know. And also, don't just, and this is some advice I got a little while ago, don't just give it to your friends and don't watch your friends play, because even bad things are fun with your friends. Give it to strangers and watch them play and see if they're having fun, or even if they're just intrigued a little bit, it might still be worth pursuing. And so bringing in strangers, putting it in other people's hands and seeing what they think of it, and if it still at least works with the way you intend somewhat, I think that's the success rate. And figuring out, like, is it close to what I expected? Okay, cool. So
yeah, I basically had the same sentiment. It's no matter how much you individually test it yourself, you won't be able to get everything done. You're going to have to get other people, outside sources, and constantly, refine it if that's something that you really are trying to focus on. Like, I had a lot of issues with a lot of different things in there, especially even just trying to get to the point of testing it because of, you know, hardware limitations and things of that sort. It slowed things down, and like I said, infinite loading screens and stuff. So there's a lot of things, even just getting to the testing stage itself. And then once you actually get there, now you have to get even more involved. So it depends on how far down the rabbit hole you want to go. And that's why, you know, we were kind of hinting at trying not to do it as a mainstay if you want to maintain your sanity. Because if that's going to be your core mechanic or your core theme, you're going to drive yourself crazy with how much extra effort that you're going to have to put just solving the simplest of issues. And then, even then, I mean, you have all these AAA studios that are throwing hundreds of millions of dollars at games, and they still have bugs. So imagine, you know, if you're a smaller dev or an indie dev, how are you going to be able to test all these things? That's infinitely creating things in the moment. You know, they're having these issues, and these are standard things, static. They've designed and coded it themselves. This is real things that are happening in real time. You don't have control over all that. So it's kind of almost impossible to measure all the metrics and all those kind of things. So you got to keep that in mind.
Yeah, I mean, the is it fun question and just the quality control, like, you know, it's an interesting thing because when I pitched this this assignment to Tyler and Dominique and the other students, it was a weird approach for me to be like, hey, look, it's okay if your game is not fun this time. Right, like in general, you know, we want to make good games, right? But because this was a learning experience of we're going to really just put ourselves out there and figure this out, maybe it will be fun. Maybe we'll find it very boring. I think Tyler mentioned that there's moments where he's like, yeah, awesome, and other times he's going to throw his computer out the window. Now, as the on the grading side of it, because a question that I got from a lot of students was like, how are you going to grade this? And I was like, don't worry about that. It's like it's about the experience. I'm looking for the good effort. How did you implement it? Are you trying to how are you debugging it? So really, it was about the process. Now, in terms of is it fun? And I'm not just trying to, you know, brag about these guys here, or I guess what people say now, glaze, is that the term? But the games that they made, and these are, I mean, what, maybe 4 weeks, 5 weeks? I mean, they went from having not downloaded a local, you know, large language model to implementing it in a Unity assignment. It's really impressive, and not just that, but their games were genuinely fun. You know, Dominique, he didn't mention it, but like to pass the last level to like determine who the culprit is of the syndicate, it's actually like the grandma, and the only way you can figure out it's the grandma is by like threatening her grandchild. But in terms of testing that, I mean, sometimes it would work, sometimes it wouldn't. So anyways, as a but as a instructor and grading it, of course, it's like, you know, not going to, you know, hold them to account for that. But I just want to take this moment to again just say how proud I am of y'all, of what y'all accomplished in a short amount of time, and adding your voice to this ongoing conversation of we're just all trying to figure this out, you know. So I'm really proud of y'all. All right.
It's you.
So the question was, what kind of tooling did we need to build for this, and what did we not predict? In brief, and you know, maybe we'll have time somewhere else, or you know, in one of the breakouts or whatever. I have a dev build of Retail Mage, which shows some of the tools that we had, and we've shown this in a couple. So two things that are important. So we built tools in engine. And I think you might have seen some of this. I can't remember what we've shown with you, but some of the, and when I say in engine, like we're running it in real. So we actually build them when you're running the game. So when you're playing Retail Mage, if we were to bring up the dev build, in the middle of the game, I can bring up debug tools. And this is useful as a game developer in general. You'll find Unreal and Unity already have these. Continue to build your development tools like that as an advice as a game developer, right? Build tooling, inspecting, and debugging that happens in real time while you're running the game. So in our case, for example, we could bring up and see all of the inference that had happened in that session, right? The input and output, all of that. But I could also then take that same, any one of those particular input and outputs, we could bring up a prompt editor. You could edit any of the data that you wanted. You could rerun that same prompt or even the micro prompt or the input that goes into the bigger system. You could change that and you could run that against multiple different models. Simultaneously to then, therefore, while you're editing, determine like, well, what's the output if I run it against that backend or that backend or that backend, and that allowed us to do real-time evaluation. And what was useful about that is it allowed, it allowed us to test in real time with real data. I think this is one of the other things is that it's kind of, look, if you go to ChatGPT and be like, can I make a game? And it'll be like, yeah, sure, you can make a game. Like it'll agree with you, right? And you'd be like, will this work? It's like, yeah, that'll work, right? So use real data, right? That's why all of our tests use, like there's one test that we run in, I was looking at it and it's like, why does this take so long? It's because there's like 200 items nearby in the environment because when we snapshotted that one test, we take all the game data, and it just so happened that that test, the player was sitting in a moment that in a spot in the game that's just filled with items around it, right? Now, if I had handcrafted or written a little prompt that kind of simulated that scenario, would I have put 200 items that had to figure out which of the 3 it needs out of it? No. But that's an actual case that happens in the game because the game has a lot of items in it. So by having real data, it let us not get ahead of ourselves to think something worked just because I could get it to work inside of a chat bot, inside of ChatGPT and be like, does this prompt work? Sure. Work in the engine with real data, get in the engine as fast as you can, build your tooling in the engine, build your prompt engineering in the engine. The last, though, I'll say, the thing that we didn't build that we needed later, that the newer the system that I'm hoping we'll open source solved, is that when we started with large prompts to prototype, and then we moved to the orchestration. And what we lost then was the ability for our designers to be able to essentially program in English as easy, right? Because now instead of it being one prompt, it's a whole bunch of prompts and it's a little harder. And we started to build out some tooling for that. And a lot of the work that I had done after that and that we've done since is try to be like, how can we get back to that point? Right? Because the iteration loop of once you can let game designers essentially program a functionality in English is just astounding, right? But that requires large prompts, and somehow you need to be able to then go from either a large prompt to the orchestration or back and forth again. And that's some of the work that we've been doing that I'm hoping that we'll release either open source or maybe even as a product or something on top of it.
Thank you all very much.
Do you see my signal? You see my signal?
But they won't be able to hear you.
So I'm. I can project across the valley. What's the right speed for you guys? Can you guys hear me in the back? Blue shirt. Blue shirt. You hear me good? The guy that Shane can hear me, right? Okay. All right, guys. So we're good. So I'm let's try this one. So if I'm just standing here talking, can you pick me up? All right. Oh, we could. Could we do that? Can we see that? No, but Shane, can you hear me? Guy in the beard, bottle, you got me? All right, and you're tracking because we're looking for the thing, right?
Okay, Michael Gokey is just the kid, by my perspective, since he's only had 30 years of experience in software development. During that time, he's done everything, but he particularly would like you to know that he's done AWS-style cloud development, he's done UI development, he's done AI development, as we'll see. He's done AI gamification projects at Duke and at DragonCon, where he's also notably part of the EFF team, the Electronic Frontier, that's protecting our freedom.
Thank you. Good, Andrew? You hear this good? Okay. Hey, guys. So as he said, so I bought my first computer back in 1982 with my paper route money from 7th grade. So, and I haven't stopped playing with computers since. My trick is I figured out how to get people to pay me money to solve their problems, right? So that's what we're always looking to do. So when we look at this, we're like architecting AI gamification systems that people want to use. What a horrible thing. We know what game mechanics are, right? We know what business mechanics are. We want to make money, make a loop. How do we get people to give us their data, but making it fun, right? So that's the trick. A business owner, a product owner says, hey, I got a feature. Does this feature do anything? Yeah, it lets me log into my bank website, but yuck. So going along, I want to talk about a product that we've developed as it was indicated. I work with Andrew on Electronic Frontiers Forum, and we know a lot of people in the computer industry across the board. So this project was built over the period of 2023, 2024, and 2025. A lot of active work in 25. So let's see, did we get the button? Yeah, okay. Dashboards, right? So we're looking at, what do we have? Green arrows, all sorts of stuff, engagement, user clicks. What is it doing, right? It's just, what do you, as a business person, you're looking at reams of data. What does it mean? I don't know. Do you know? No. You have to decide what it is, right? So we get there and we're like, yeah, the user did something, but what does it do? And what do we want the user to do next? And do we know what the user is going to want to do next, right? So how do we do that? Gamification. What is that? Is that like engagement theater? Like we go to the airport, we call that security theater. It's not real security. We know it's fake. We know it's like, to calm the masses. What is engagement theater? We have gamification. We have clicks. We have buttons. We have stuff. But what really is it? Points, badges, leaderboards, social engagement, right? So that's all fun stuff. But, what's next? If a game isn't fun, the data is garbage, right? So who is the person we were talking about? The instructor. Where is he? There's the student. So he's talking about making games, right? And they didn't even have to be good games. So Andrew knows about Siege, and we have game jams. So back in the day, game jams, you'd come in, 48-hour weekend, let's build a game. And I came and attended, and I watched, and they would hack out this. They would get the running loop, or they get the opening ceremonies, or they get some component of it, but they never got a real completed game in a weekend. It takes a while. So one day I figured out, let's build a board game. Figured out that by building a board game, I could actually get it finished in the weekend, making it fun. I got a group of students, KSUs, down in Marietta. We built it Friday night, Saturday, Sunday, presented it, yay. It was a fun game, and we collected no data. It was just fun. Let's build it. Yep. What is? Gamification isn't just the UI. Let's define. UI is user interface. UX is a user experience. Behavioral data, analysis, right? So we're looking at it. Quests aren't tasks, they're intent probes, right? What is your intent? What do we want the person to go do on this quest? I'm gonna go find the sword. I'm gonna go slay a dragon. What are they? Badges aren't trophies. Yeah, they are. I go get my Chipotle badge. Hey, I got a free burrito, you know? They're timestamp state changes. Oh, person did something, person did something. So I have a marker in the data somewhere. Leaderboards, ooh, cool, man, I'm at the top of that. We talked about Pac-Man. Somebody went back to Pac-Man. I mean, oh, that leaderboard was cool, right? Back in the day, how many quarters you put in there? Social motivation curves. We do things because we're socially motivated to do them, right? Okay, gamification is a journey. To an architect, it's data acquisition strategies. So I'm looking at a system, a business tool. How do I make that fun and keep people engaged so that we know what we're gonna do? Because what was the guy saying? Monetization, right? We wanna make money. So what do we do? Well, Duke University, orientation year of 25, we ran every single one of them. They contact us and say, hey, let's build a game, let's build a series of quests. We put the quests out, we ran them. We had to make sure it was gonna run that many people all at one time. That was our test. That was the big test. We went to Dragon Con. We haven't rolled it out to there because, you know, we're still working with the people. But we ran a bunch of quests and had a lot of fun because you've got 80,000 people in how many city blocks wandering around doing stuff? How many 5 hotels, lots of convention floors, lots of floors in the place. You got people walking through the convention, you got people walking out on the streets. Let's figure out if we can guide traffic. Oh, you push your button and say, hey, I need help. Let's figure out what we can make it do. New York Auto Show, 2 million users go to that a year. That was a lot, and that's a week-long experience, and we're like, how can we tap into that? So we're looking at how do we build brand experiences for all the different car dealers. Let's say Subaru, everybody knows Subaru. Subaru is what? Love, the wilderness, their dogs. What if we build different quests within Subaru, within the auto trade show? Different personas, different pieces of what you're gonna do. Tribal wellness. So the same tool can be used to help us pick up, eat carrots instead of Cheetos. Go for a walk after dinner instead of watching TV. How can we make that happen? We can't make it happen. Was it Shane? Or where's the other gentleman that is not in here? We were talking about outside, and he was saying, how can you make people do something? You can't, but what if it's fun, right? What if it's fun? So we decided to come up with game mechanics as behavioral inputs, 8 mechanics, 8 signals, human intent, because we're looking at all of them. Every time you get something, you're getting a dopamine hit, right? You post something on Facebook, somebody likes on it. Ooh, cool, right? You get on the board, you got 40 people have seen it. Ooh, that's kind of cool. Content, my content's being thing. So you've got your activity. How do you take some game mechanics and put it into it and make it fun? So we're looking at quests. The adventure, I'm not just clicking, I'm on a mission. I'm gonna go do something. What's its intent sensor? The quest, predictive window of actions. We know that they're gonna go from here to here to here to here. We're gonna see how long does it take them to do it? Are they doing one and not the other? Why did they not do that? We're looking at badges. They get completed, they finish the quest, they get a badge. But it's not just the badge. What is the badge? The badge is more. It's a, I did the thing, I get the dopamine hit, I get a cool badge, and we get like, we're trading information back and forth, right? Levels. Ooh, I'm a gold level, I'm a silver level. How many people like Chick-fil-A you've got, right? You got a red level, you got a silver level, you got a gold level, you get free food. You go to Taco Bell, you sign up, you get free food, right? You're leveling up. They're taking that. That's a game mechanic, right? Progress. I can't leave it at 90%. I'm supposed to do 5 things in this quest, and I'm missing the one. I have to go click the QR code somewhere to get that. How many people want to leave and quit something before it's finished, when all you have to do is one more little thing? Right? Okay, so what do we got next? Leaderboards. Everybody likes to be, competitive. Social engagement, that's a tool. Rewards and coupons, that's a tool. Let's say you're at Dragon Con and you completed a quest, you want to get a free thing. Free t-shirt, free badge, free stickers, right? Let's say you're at a racetrack, NASCAR, you're at the Charlotte, and you did a bunch of things, you're going to get a free hot dog. That's a deal, because those are $5, right? And it's free to them. They can just, write it off. Points, bing, 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 because it goes up. Everybody loves points. What happens when you get that badge? On your phone, on your app, fireworks, confetti, and the badge. So, leaderboards and social engagement are 2 different sensors. Where do I rank? Who did I connect with? You see that? So that's a trick there. 2 different dopamine hits, 2 different activities. So you can look at it differently. Now, I don't want to look at that data. That's reams and reams and reams of data. I don't know what that is. But the system can go in and tell us what it's doing, right? So, how do we play that? The quest. Quest is the core loop. So, what do we have? The quest. Dun, 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 let's go. Go to the South Hall, click the button. You ever watch security guards? They have to walk around the building. They have a little handheld. They have to click the QR codes at certain points around the building so that the system knows that they walked all the way around and did all the things doing their job, right? We might have caught that. One of the things we do with EFF is we're always talking about penetration testing. So you're always looking at security. We're all geeks here. We're all play computers. So at some point, you may want to be concerned about security, internal, physical, whatever. Okay. Badges. Yay. If a quest takes 10 minutes to do the whole thing, 20 minutes to do the whole thing, I started, where's my dopamine hit? So you want to give them something along the way. And that's where the badges become check-in points as each one you do. The leaderboard shows up. Cool, I finished. Let's see. So we have how many cohorts? We got a bunch of people. We got 2 girls right here going to school together. They're going to graduate together. Are they competing with each other? Not really. Are they competing with the people that are below them? Not really. But they're in a cohort with a bunch of other kids, right? So you want to stand out because you want the job. There's 80 of you in the group, and only 60 of you are going to get jobs. You definitely want the best one. All right, leaderboards. Let's say we got Dragon Con convention. Anybody ever been to Dragon Con? Hands? Yeah? It's a huge place, right? Just getting through one of the main floors during the photo thing, 20 minutes to walk around. But what if you're walking around on that floor, and each time you're taking a picture of somebody, they have a badge, and they got a baby QR code, and you can scan their baby QR code, you took their picture. You're going to throw it on Facebook, right? Oh, cool, look at the picture I got of this person. You also just grabbed a baby QR code. So 5, every single time, you're getting those little hits. Oh, I got a cool picture. Ding, 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 ding. I got a little badge, too. Moving it along. 5 different hits of dopamine. What does data actually look like? Yep. It's a pain in the butt. We had to figure out all these little tricks like, what are you doing with all this? Session start, intent flag, predictive window. AI can begin modeling. Now first, this was built, tool with Elixir Phoenix, Next.js, horrible stuff. We rebuilt it, but then you still have the basic loop, the same basic mechanics. Quests, badges, leaderboards. We don't really track users. We're tracking quests. We're tracking progress. Where are the people at? Are they finishing or not? If you open it up into a database, it's gigantic long, just on the one record of your biological data. Let's see. What's the next piece of this little tool for fun? Yep. How do you build a franchise? How do we make some money? How do we get businesses to pay us money to put our system in their business? We're going to integrate into their business. You own a business. What's your business? Yeah. Game development. Okay. Does anybody have a business that does business with the public that sells a product or has interaction with the public? Firewalls. Great. So how do we get that, right? How do we talk to those customers and outside? They're walking around. They come in. You're going to sell people out there, sales engineers out there, right? And that building that you're protecting with your software, it's an insurance company. It's a restaurant. It's a whatever. You've got your security. You're trying to implement your security package into their business, right? How do you make that tool, your firewall, fun for the people at that company that are going to be using it, right? So that becomes the trick. Because if you don't, dead time is empty. So what does that mean? Let's pretend we have a franchise like a stadium. Okay, we got all the NFL stadiums. We got all the Major League Baseball stadiums. Braves Field. We got NASCAR. So NASCAR is a big franchise. And then Charlotte is a local. Daytona is a local. Indianapolis is a local, right? So that's the racetrack is a place. Is it being used for the races? Yes. What else is it being used for? Concerts? Something else is happening there in the off time. So let's do that. I walk into the racetrack. My badge shows me as a race fan. Now it's doing something different. What happens in the next model? Let's go look down and see. Creates the trigger. There we go. That's the next page. Dun, dun, dun. Yep, location services. I walked onto the Charlotte Motor Speedway. Okay. So it's going to look at me and it's going to create a profile, user 123. Today, because NASCAR is hosting a race, my user 123 is a NASCAR fan at the Motor Speedway on the race day. Make sense? That's some of the data that it's collecting. What happens the next time I go there? So right now it's going to give you colors on your screen, fan material, details. You ever see those little PDFs? Oh, they're going to give you some information. You go down to the Brave Stadium right now and they've got the Hall of Fame, batting cages, photo simulators. What do you, if you go to a racetrack, they got race car simulators in the lobbies, right? You're going to run those. So now we have NASCAR fan. What else are we doing? You're going to go back by out in the parking lot on Tuesday. They're having the barbecue cook-off competition. So I live by the Gwinnett Stripers, way out there by Mall of Georgia. Yeah, it's a baseball field. They play baseball games every once in a while. They go on road trips, and the rest of the time it sits there. They have shows. They have flower shows. They have barbecue competitions. They have this kind of competition. So they've got something else going on there. What else are we doing in the off season? We're doing something. So you go there, hey, my little badge, Geo, it says I'm at the field, but today is not a race day, so I'm doing something else. So my persona can change. So I don't have to look like I'm a race car fan. I can be a gardening fan, because that's the event I'm going to. Let's say, find the little elves that are scattered around the field and get some free cocoa. Cool. Anybody ever like the Christmas plazas that we go to and they have the little Christmas fairs? So that's a franchise. You bring in one of those, you bring some elves, they scan the badge, you get some cocoa. And it becomes a way for people to track people at the event, but you get something in return for going, because it's all about giving something to get something. It's fun for me as a user, but my business is also tracking data. Let's see, what do we got? Wellness, yep. So this architecture that we were using to track NASCAR fans, the mechanics are basically the same. A Native American Indian tribe contacted and said, hey, how can you help us with a wellness program? Take a walk after dinner, right? It's a quest. Take, what else? Have carrots instead of Cheetos. So when you look at an Indian tribe, its health, education, economic statuses, All of those things where they're wanting to help motivate growth. They're wanting to help in a way. Could it be bad? Sure. But who's running it? The franchise, the tribe. Are they really going to do something bad to their people? No, they're doing it to improve the quality of life. So they're going to be looking. You're going to get your badges. You're going to get your social. So let's give you a real life example of that. Progress feedback, health situation. I plugged in, I'm using it. I have diabetes, me personally. So my blood sugar, my A1C is tracked every 90 days. I go in and get a little blood sugar test, right? Get one done in August. Next one's gonna be September, October, in November. But my brain says November, 90 days is too long. But it knows that Halloween's coming up at the end of October. What if I have to take the test on October 20th instead of sometime in November? Then I have a window. I know it's coming. I know it's going to come, that A1 test. So I'm getting a social engagement that says to myself, I have to pass my A1C. I'm going to get a blood sugar test. I don't want to eat all that Halloween candy. I don't know about you guys, but if you're, bigger, and you like your Halloween candy that starts in September and goes all the way through October, that's a lot. But every single time I would go to pick up a piece of candy, I can tell myself, I'm not taking the candy right now. I'm doing that. That's my motivation. But I can make my window do the same. Because sometimes we got, on our phones, we got trackers that, our walking trackers, our carb managers, some of us eat, what's our diet like. So we're doing some of that already for ourselves. But what if we're doing it by a group for something, right? Veterans do this all the time. We're all, hobbits in a big hole together. So, social engagement, quest campaigns. Yep, there we go. Dead time monetization. So this was the trick that we're talking about at baseball fields. Getting in, we get you to the door, we got your money, 5 minutes. Good job. 5 minutes, you got revenue, square footage. What are we going to do? How are we going to get you to do things in the building? And that's what the quest operation is going to be. So you're playing a game wherever you go, logged in. You got a business card, you got a this, you got a that. The stadium says, we're going to do these things for people. While they're here, we're going to help them have fun. So those are just some examples you could get from a baseball field, right? So some of the technical gets down to the sticky factor. Yep, this is the horrible one. 2 parts to this game. We got the user app, we got the operator. So that's the stadium over there. They're the ones that are going to be setting up the quests. They're the ones that are setting up your campaigns. They're the ones that are building the geofence around. And like the gentleman in the back there, we're helping them to figure it out. So what was it? Firewalls, right? The guy with firewalls. So they're going to define what's in your firewall. You're defining it. You're going to help them, right? What stuff is going to be able to filter through and what stuff is going to be blocked? What rewards are you going to give people for doing good computing, right? So we're not coding it. It's an app built into a dashboard. So we had 2 dashboards. You got yours, the user, they're getting the rewards, and then you as a business owner are helping run that. So what do we got? Itinerary. Nexus can be run as a business card, your tool. Some gentleman here, I showed the trick, hold up your phone, and the girls were there. They weren't linked in together as LinkedIn. They know each other. They're computer geek girls. I said, let's get your LinkedIn, and I showed them a little button where you can pile up your QR code and connect with each other instantly. I was like, hey, that's cool, right? That's exactly what we were doing, trying to build a business card. How many of you guys used to carry a business card and give it around? And we're now geeks, and we don't even do that anymore, right? But how do you give your data to somebody without giving out the card? How do you make it safe? That's yours. You define what's you can give out, depending on your environment. Persona switchers. Where are you at? What world are you playing in today? Right? So. Let's see. Data. Yeah. Do you need 5 minutes? Data? Yeah. We're looking at scale. We're looking at granularity. That's the biggest problem. The badge That's me, I'm playing the game. I gotta get my dopamine hit, I gotta get my thing. But the data is getting collected, okay? What's happening with it? Is it live? Is it on the go? Let's see, I'm gonna skip a little of this. We're gonna get down to, here we go. User action, app sync, hot path, cold path. So you're like talking about an AWS to cloud stack. Some databases are great for writing, some databases are great for reading. We're dumping everything into an S3 bucket. Dump, 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 dump. Tenant, event, time, open search, query, Sage, that's our AI tool. Everything comes on, and that's happening deep in the background. When it's spin up, live, it's all up into a Dynamite database. It's gonna go down and grab your data, push it in, then you know who you are. Because you're gonna not do anything for 3 weeks. The next time you go to a place, it's gonna spin up and go, hey, I know you, welcome back. So, hot and cold is happening. You don't gotta do anything. The system spins up, and of course, it spins down. It drops off after inactivity periods. And we can read all of that. Let's see, next button. Yeah, stack. API, Dynamite, databases, speeding, all the tools, a lot of work, pain in the butt. I love AWS, but sometimes I really hate it. So we get a guy, he's our guy, he's building the AI tool. He's been building this sucker, he's got Python, he's the master, he's the whiz. I'm just the cloud architect. I'm working with all the people building the software. He's building the big engine. Turns out he wanted 40% of the company. He wanted a big share, and we're like, eh. So we built it without him, and we had to go figure out how to build an AI tool that sat on top of it. So don't get yourself locked into something. So we're gonna push over here. There's two parts to it, right? The brains and the voice. So these are part of this stacks. So this is our tool that's gonna do the computing. So it's learning. What was the guy talking about, like hallucinations and is this real, is this not real? Is it gonna do something? And it's gonna adjust the outcome as it goes. The engine, it's not even gonna do it because it's looking at, like we're talking about, the hot swap and the cold swap. So the real data is being collected, it's being handled, and then it will do something eventually, right? So what do we have? Yep, there we go. Big picture, fun. We're doing something, we're engaging the customer all the time. We're looking at the data, we're grabbing it. We're making smarter AI models that are constantly learning in the background. It isn't on the fly, it isn't with you, it's because you've grabbed the data. It's very personalized to you as you're going along. And from a business guy, so this loop never goes, right? It just keeps going every time you're there. It's not really intruding on you. We don't really care who you are, you're just user 1, 2, 3. But what happens? We're exchanging value for insight. We're giving you something. We're helping that guy with the company, with the firewall company, make it fun for his users. He's taking that over to Little Caesars. He's taking that over to, some alarm company. He's doing whatever. He's gonna try to figure out how to make his firewall tool more fun for his customers, right? Okay. To the gamer, it's a quest. To the architect, it's behavioral data. The business, it's a flywheel that constantly is working to how do you help. So we're trading experiences for insight. And that's the goal. Cool.
Mehdi Mousavi is a independent researcher, graduate of Georgia State. He's done 2 major projects. One's called Supercaustics, which is a data synthesis tool for building training models, as I understand it. The other one I don't understand at all. It's called data ablation. So, you know what that means? Okay, he didn't make it up? Okay. We'll learn together. Well, Phil already knows, but the rest of us.
And he also made Light Break, Best in Georgia winner.
Right. Oh, you did? You made that?
Yeah. All right. Hi, everyone. My name is Mehdi. Thank you for that introduction. I had some introduction in mind myself, but that's okay. I'll Yeah. So I am a senior research scientist at a company called Aquabyte. Is completely unrelated to games. I mean, it's a little bit tangentially related. We do simulations to train AI models. I have a PhD in computer science. My research was mostly in computer vision, robotics, and graphics. And yeah, my research is called synthetic data, the field in general. So I will give you a quick dip in the toes in synthetic data. And I have a point. So I've released 4 games that are a little bit presentable. I've released a lot of games. Some of them are not really good, like Iron Soul is not really good. Don't play it. It's bad. E.T. Armies in 2016, worked on it for a long time. Lightbreak, again, we worked on it for almost 3 years, if I'm generous, a little bit more than that. And Gokey was my college project. It's free, you can download it. Don't make 2D platformer games, okay? All right. So I'm not gonna tell you what to do in this presentation at all. This is not a talk that says don't use AI or don't build for VR. I'm here because I've watched a lot of smart people make bad, uninformed decisions because they didn't do their math. And I did the same thing. I'm going to share my experiences with you. And the ultimate goal is building deliberately, looking at what data is out there and building with strategy. And if your dream is to have your own indie studio, your dream deserves that. So like you need to get in with clear eyes. All right, so I'm gonna give you a pattern that I saw that's true in tech. It's also true in games. It's gonna get a little bit into synthetic data, but every few years there is this one big thing that comes out and everybody puts money into it. And before generative AI was a thing, that thing was called convolutional neural networks. Everything had a CNN in it. In around 2012, there is this competition called ImageNet at a major scientific conference, and some guy, his name was Alex Zherkovsky, if I remember correctly. Some guy used an obscure method called convolution on images that nobody, like a few people did it before. And that point is probably why you have AI in your phones today. AlexNet crushed the competition. Like it was like 26% better than the next best thing, which as a leading scientific conference, that's huge. Like the margins is like 0.3% mostly, and they say, "Oh, I have the state of the art." So it was crazy good. The problem was that CNNs needed a lot of data. It was crazy. Like I think at some point, Elon Musk said that we have exceeded, like we have depleted all the real data that's available. Think about that. And gathering real data in reality is very expensive. Like if you're Tesla, you just grab some cameras and put them on your cars, and you could just drive it and gather real data. But for all of the other companies that were putting AI in their systems, very, very expensive and legally a little complex. So the solution was to use game engines to make photorealistic 3D simulations and then gather that data. And the idea was that it has procedural variation, so you can like sample it infinitely and get as much data as you wanted. And I was a part of this wave. So that data ablation thing that Dov mentioned, that was my first paper. I worked on it around 2017. and like it introduced a control method so that you can like control your lighting and stuff like that. And then as I kept exploring light transport, I was taken into like transparent media and then the water and then underwater, which is like, related to my day job. So basically, we were teaching AI with fake images. And at the time, synthetic data was huge. So companies poured millions of dollars into this narrative. So NVIDIA was working on something called Omniverse, which had like multiple different divisions. Like, it had Isaac Sim for factories. They had Drive Sim for autonomous driving. And they were shipping it as a product to businesses. There was a company called Parallel Domain that raised $30 million. And it was founded by the folks at Need for Speed, by the way. And they were making driving simulations, and Waymo and Toyota, Continental, they were their customers. There was a company called Synthesis. They raised $24 million. They were working on faces. Tesla, famously, they're using Unreal Engine for their autopilot simulations, and Meta actively still uses synthetic data all over the place because of their VR play. The problem was that the substrate shifted hugely. So they went from hand-built 3D systems to Gaussian splats, which is, you can think of them as like 360 footage, but in 3D, and very, very, very realistic. So what you see there looks very realistic. It's from Parallel Domain, and they adapted their tech so the hand-built models are inside a Gaussian splat. And they sell that to like car companies so that they can train their autonomous cars. And yeah, with this substrate shift, Synthesis AI went down because they couldn't keep up. They couldn't adapt quickly enough. So they went out of business. Parallel Domain adapted, so they're still around. And NVIDIA, to save Omniverse, they went out and bought a company that was doing the disruption. So they spent 9 figures on a company called Gretel to save Omniverse. So my point is that disruption always comes. The question is, can you survive it? If you're NVIDIA, just buy it. So good for you. But if you're a 3-person studio in your mom's basement, you are cooked if you're not ready for that. So to bring this back to games, the same cycle is true in games. So the way that I assess the risk of any project is how much time am I going to spend, and what's the probability of me making my money back. That's the equation. Time is money, even if you're an undergrad, even if you're in high school. The time that you spend on a project, you could go out and make money. So that time is money, guys. So let's try doing something. Let's start doing some math. So I have this chart over here. And let's say my runway means how much time can I realistically do this? Like, let's say I have savings for 3 years, or I've gathered funding, and that funding can last 3 years. How many games should I make, or how big of a project should I make, and what is the probability of my success? So let's say, let's actually ask you guys, how much do you think the success rate of an average indie game is? Do you think? Don't do that. I will get to that. Yeah, somebody has done their math. How do you measure? I measure success by can you live off of it? Yeah. Let's just say Georgia, like an average, like let's say you have to make 100K. It's actually more than that. But I actually had this conversation at one of the DreamHack events, and the average person thought it's 10%. I was like, yeah, there's 10% chance. I will come back to this slide in a bit once I show you the real math. But I guess the crowd here is a little bit more educated than I thought. Yeah, so if at 10%, I have 3 years, 36 months worth of runway, and I spent 2 years on a project, there's a 10% chance that I win. But as this increases, like, your chance of success, why isn't this updating? This should update. But we're getting into the red territory, where the probability that we are ruined is a lot more than probability that we are succeeding. So let's look at the actual market data for this. So this is Steam, and the number of games that come out on Steam. So in 2018, it was around 8,000 games, 8.3 thousand. In 2025, it's 20,282. That means around 56 games per day come out on Steam. And your game must compete with all of them, plus TikTok and Instagram. This is, somebody asked, how do I define success? This is, I would say this is a good analog for that. So if you reach 1,000 reviews, that means you get around 150K in revenue. So after taxes and platform fees, you can live off of that as one person, I would say. But you're not going to be one person. You're going to be at these like 4 or 5 people. So the chance of success, so you see games that do make it past that line are increasing. So then that's good news. The bad news is the success rate percentage is actually just around the same. So just under 3% is what the data tells us. So if we try that, and we spend 2 years on a game with 3% success rate, with a 36-month runway, 97% chance that we're gonna fail. Is math, it's not me, okay? And as you decrease this, this time it updates. Ooh. As you decrease this down, let's say you spend 7 months or 6 months on a project. By the way, for my math nerds, this is the formula that I'm using. It takes into account the success rate and also your skill, because your 4th game is going to be better than your 1st game. You're going to learn. So your chances of success of your 2nd game is probably bigger than the average 3%. So basically what my point is that as you make more games, more shorter games, you're more likely to succeed. You're more likely to be able to pay for your indie studio to pay for your living. And if you didn't know, the median gross revenue for any Steam release in the past 3 years have been $500. Yeah. Okay, so I have 2 case studies of very confident advice that I've seen people give, and I'm gonna break it down. Okay. Yeah, you probably heard this pitch before. Somebody from a $1 billion company in a packed room, coming and telling everybody, "Hey, build a VR game. It's amazing." So let's look at the numbers, okay? So this is the percentage of Steam users that own a VR headset. Not active users of VR. Own, okay? I have 2 VR headsets, and the last time I used it was like 6 months ago. Okay, I'm in this 1.77%. And even in that, 28% of them are Quest 3, 24% Quest 2, 12% Quest 3S, 11% Valve Index. It is fragmented, so you have to support all of that. And the chance of hitting 1,000 reviews by genre for VR is 0.27%. Yeah, so VR is literally the worst performing genre on Steam. Yeah, don't build VR games, guys. So, and this is actually a really helpful slide because survival crafting is 20%. So that 3% changes based on the genre of game you decide to build. So do this math. Whenever you are beginning a new project, look at, okay, what is the genre of my game that I'm planning to put on Steam? And then, is it survival craft? Then you have 20% chance, almost 21%. Farming. The reason why you're seeing so many roguelike deck builders is this is why. Because they're easy to build and they have a good chance of success. And simulation, horror, RPG, like if you are a new person, you making your first game on Steam, make a horror game. Okay, and right now, these are the 4 largest VR-only titles on Steam. This is live. How many people are playing Half-Life Alyx, Blade and Sorcery, Beat Saber, Gorilla Tag? And the amount of people who are playing, 1.2% of peak. So all-time peak of Half-Life Alyx was 42,000 people were playing it. So even like these games that are the top 4, they're not doing very good in terms of players. Okay, second pitch. Built for Fortnite. Okay, so there is some truth that the creator economy for Fortnite has been paying money to people. Okay, according to their own numbers, they've been paying $352 million in 2024 to around 70,000 creators, and their play numbers or the play hours are very impressive, 5.23 billion hours. But who gets paid? So out of those 70,000 creators, 81.6 under $100. So if you spent a year making a UEFN project, 81% chance that you're gonna get under $100. So if you want to be in studio sustaining range, you have 0.6% chance if you built on UEFN. Again, these will go up the more projects you do, but do you really want to take that risk? When Steam gives you around 3% chance. And my point here is, yeah, I'm not saying it's a bad idea. I'm just saying know what you're getting into. Don't like blindly go into it expecting that my game is different. If I make a good game, the customers will come. That's not unfortunately true. 3 out of the 4 games that I showed you in the beginning are good. I'm not a millionaire yet, okay? So with UEFN, yeah, you get instant distribution. The players are already there. You just put your game over there. Anyone who sees it can play it. The platform is complete. You don't have to pay for hosting. The updates, tooling, all of that is already there. Monetization system, you don't have to build. That's great. But the player relationship, the player is not playing your game. The player is playing Fortnite. You don't own that player relationship. An algorithm decides who sees your work. Rules and payouts can change. Big companies do this all the time. Unity, remember? And you compete with Epic's content, first-party content. Can you compete with Epic? And in all of these plays that I showed you, who absorbs the risk is the main question. If you're NVIDIA, just go buy the disruptor and keep moving. If you're Epic and something risky happens, they just change the terms and their money keeps coming. The VR advice guy, he gets paid and go home. And gives the same talk in another place. But you spent 2 years making a VR game. Your chance at success evaporates. So you hold all the risk, and they go to the bank. So this is another, like, I'm gonna move on a little bit to the tools that are very common right now, and the sales pitches that AI build the game. You do the creative management, and AI will do the rest. And there are like 4 categories of things that I found. So the first one is world generation, huge promise, right? You describe your world, some AI thing or some tool will come and generate the world for you. Say, I want a village by the sea, and it will come and generate something really cool for you. Or like you give it a prompt and it gives you props or like layouts. There's NPCs and interactions. We saw a bunch of these as like naked tools that you can add yourself, but there are services that sell you these things. There are services in the art pipeline that like say, okay, I will generate your textures, you describe a material that you want, and I will build it for you. And there's code generation, so also very common right now. A lot of people are using GPT, whatever, or like Claude code to build their gameplay scripts, tools, shaders, whatever. And what I found is that in most cases, what they're actually selling you is a dependency and not a tool. And that is, like, I'm not saying it's bad to have dependencies. I'm just saying it's the difference between selling you a dependency and selling you a tool. So what does that mean? Whenever a difference between a dependency and a tool is that in a dependency, what they get is a subscription, either way. They get your usage data. They get to improve their models with your usage, and a platform position inside your pipeline. So if you use whatever tool, you have to bring it into our platform. You have to build in our platform. And your risk is your runway. How much time do you have to ship a game? Remember, for like a moderately successful indie game, you have under a year. They get lock-in, so your pipeline shapes around the tool. Terms, pricing, availability can change mid-project. And then you're shipping something that you don't fully control. That's the biggest risk, in my opinion. So I have prepared 4 questions to ask, and I'll give you a example of a good dependency versus a bad dependency. So yeah, world generators, NPC chat layers, texture tools, all of that, great. But who pays, who profits if this works, and who pays if it doesn't? If the vendor gets paid regardless, whether or not you win or lose, that is a different incentive for them. So if you have to pay a subscription to get onto their platform, to use their thing, that is a dependency for you. It's not a tool. And you need to price this into your decision. I'll give you an example here. Somebody might say, okay, yeah, I'm using Unreal Engine. And that is a dependency because I have to build tools around Unreal Engine, right? But Unreal Engine doesn't get paid if you lose. You only pay royalties if you win, if you get above $1 million revenue. And like Unreal Engine's interest is that you build a good game and you actually succeed in the market. Unreal Engine doesn't bank on you just using Unreal Engine. You see that difference? So what is the real time to value? If somebody is selling you a tool, how long does it take for you to say, okay, I shipped this in my game and it saved me money? Does it take a week? Does it take 3 days? Does it take a year? That they all have different levels of risk. 3, does this fit my pipeline, or am I reshaping my pipeline for the tool? The best tools should disappear into your workflow. And that's why like coding, code generation is so popular. It's because it disappears into the workflow. You just type it, gives you code. That's a great tool. Is it a dependency? Yes, it is, because you have rolling costs. You pay like Cursor whether or not your game succeeds. It's a dependency, but it disappears into your workflow. So that's a good dependency, or like moderately good dependency. And what happens if this disappears tomorrow? If the API pricing of GPT-5 overnight goes from like $15 per million token to $30, are you ruined? If the model gets deprecated, if like OpenAI overnight decides to pull GPT-5, what happens to you? Or if the company pivots, or if they get acquired, if somebody comes in and if Apple comes in and buys Epic Games and they throw it into the trash, what's going to happen? And if terms of service changes, so this is a huge cliff that's coming in 2027. The V-Bucks split is going to change in UEFN. What's going to happen? Epic's going to take 50% of all V-Bucks sold in your games. So my point in all of this wasn't to discourage you from chasing trends or aiming for moonshots. Do that, but have a strategy and know what you're getting into. If you are building a VR game, do it, but know that you have a very small chance of success. And that's not a bad thing. Like knowing that, okay, I'm not gonna spend like $20,000 on an Indian developer from overseas to build this for me if I know I'm never gonna make that money back. There's a difference. And yeah, doing your math, your dream is worth like 20 minutes Googling things. So do that, please. That was it. Thank you.
That was a fantastic slide.
Anatoly Lubarsky is an independent game developer with quite a portfolio. His studio is X2 Line, and he makes a number of casual games. A game I love. He's got some baby adopter games. He's got, go look, there's a huge spread of them. But his particular interest today is going to be in introducing generative AI into your workflow.
My talk is called AI as Junior Team for Indie Studios, a framework for rethinking production roles. I want to thank organizers and Kennesaw State University for the opportunity to speak today. And my name is Anatoly Lubarsky. I run a small game studio called X2 Line, and I've been doing this full time for more than 15 years. X2 Line is best known for our Baby Adopter franchise, a series of role-playing games where players take care of a virtual child. We also have other role-playing games and puzzle games, including those in Match 3, Mahjong, and Nonogram genres. What we are going to talk about. Today I'm going to use a hiring style way to think about AI in a small studio. It's a type of framing and my opinions about AI and how it can help in a small studio. Imagine you can hire a couple of junior helpers tomorrow, what would you hand off and what would you still keep with the core team? For me, the core stays human. Creative direction and the IP that defines the game. AI can take on support work and speed things up as long as humans keep responsibility and review on the human side. What I mean by junior? I'm using the word junior here only as a way to talk about scope, supervision, and responsibility, and it is not some kind of ranking of people. Junior developers and junior artists are real team members. They take responsibility, they ask questions, they learn fast, and they grow into owners eventually. We all started as junior, and anytime I pick up a new area, I am a beginner again. AI can help with work, make everyone more productive and efficient, but it doesn't take ownership of the outcome. That part stays with humans. I'm also not implying that AI tools are less capable than humans. They are highly capable and on average higher than humans are. AI as an extra team member. I treat AI as an extra capacity that can cover parts of roles a small studio often can't hire for. It can also join brainstorming and help generate ideas, names, mechanics variations, UI text variants, edge cases, alternatives to compare. It can also do office organization style work, translation and localization work, internal documentation, meeting summaries, and turning notes into tasks list. And on the development side, it can help with code review, debugging, and QA support. Things like reproducing bugs from logs, suggesting test cases or code review, and pointing out risky code paths. But it should not be making final product decisions. Humans own the creative force and the IP. For me, IP, intellectual property, is the identity of the game. The characters, the world, the style, and the key visuals people recognize. That direction should be set and approved by humans. AI is best when it works around decisions you already made. Variations, conversions, drafts, and support work. If AI starts defining the identity, you often get drift, inconsistent tone, inconsistent style, less originality, and a weaker brand. So, studio-owned IP should be first. There is a practical reason for this, and there is a personal reason. Practical, you want an identity you own, can defend, and keep consistent over time. And personal, I don't want to feel like I'm building on something that might belong to someone else. I'm talking about art mostly now. I don't want to discover years later that what I shipped is basically a lift from another creator's work. So the foundation should be human-owned and human-directed. The characters, the world, the style, that's the foundation. Then AI helps around that foundation. Variations, conversions, drafts, and support work. AI only outputted copyright. In the United States, copyright protection is tied to human authorship. The Copyright Office guidance is that purely AI-generated material is not copyrightable by itself. And in mixed works, where both humans and AI participates, the protectable part is the human-authored contribution. That's the main reason the art and the game's identity, the AI team member, doesn't become the senior who establishes the foundation. It can help around a human foundation, but it doesn't become the foundation. derivative works and permission. Copyright law gives the owner the exclusive right to prepare derivative works based on their work. So if you generate something that's effectively based on someone else's protected characters, for example, if you generate art from scratch with AI tools, Midjourney, and others, it's based on someone. It can be based on someone else protected characters, scenes, or recognizable elements, and you can walk into unauthorized derivative territory. But on the other hand, if you own the base work, that's where AI becomes very useful. You can generate variations and extensions of your own characters developed by humans and around your own world, because you control the foundation and you have the right to authorize derivatives from it. And you can, and the AI can help to build derivatives from your human developed foundation. This is an official US Copyright Office guidance document called Works Containing Material Generated by Artificial Intelligence. And another one, US Copyright Office document, Copyright and Artificial Intelligence, Part 2, Copyrightability. It is clearly written in these documents that the work can be protected by copyright only if it is created by humans. And the work also requires originality. The document also explains that what many people call prompt engineering is often a black box. The AI system can revise or expand prompts to improve outputs behind the scenes. And the output of current generative AI systems may include content that was not specified in the prompt, and exclude content that was specified in the prompt. And many times when we see like tools hallucinating, it's not actually they're hallucinating. They behind the scenes they modify the prompt, then they extract tokens from the prompt, and what you get is a black box. And the same prompt can generate different outcomes. On the other hand, the work can be protected if AI was used as an assisting tool, or if AI was used in brainstorming ideas, while the human still authored the final protected expression. AI in brainstorming, it is helpful but not the decider. Brainstorming is where teams often get stuck, especially in small studios. And it is a missing piece of puzzle when you are working solo. AI helps by generating a batch of candidates you can actually discuss. Names, feature ideas, UI text alternatives, level variations, marketing text drafts, even what could go wrong lists. The speed matters because it gets you out of the blank page problem. You are not waiting for the first idea, you are picking from a set and improving it. After the discussion or debate, AI can produce a short written summary, what we decided and why. AI can help turn messy notes into that summary with decisions and action items. If you could hire 4 junior roles, who would you hire? If you had budget for a few junior roles, you'd hire people to remove load from the core team. Common choices in small studios are internal scripting and tools, translation support, documentation, and operations help, community content, code review, and QA support as well. These roles don't define the product, but they multiply the team's output and reduce mistakes. AI can cover parts of these roles if we keep tasks clear and review the output. Virtual junior developer, responsible for internal scripts and conversion helpers. This is the kind of work a junior dev often does in a small studio. Not designing the whole system, but writing a batch or Python script, converting files, cleaning data, generating a report, or automating a repetitive step. The key requirement is that the output is testable. And this can include practical QA or developer support too, reviewing a code difference, debugging, suggesting where a bug might be, proposing a small fix, or writing a short list of test cases to try. The output must be testable. If you can't test it, it's not a good delegation candidate. This is my basic pipeline, for example, for moving a character from 2D to 3D with AI help. AI isn't used to invent a new character or change the look. It's used to convert what we already own in 2D or 3D, into 3D. First, a human artist creates a clean, symmetric 2D pose of the character. We also prepare a few hand variations because hands are where 2D to 3D AI tools often struggle. Having 3-5 clean hand versions makes the 3D step more reliable. Then I generate a 3D version from that 2D pose. After that, I bring the model into Blender for surface and texture fixes and other touch-ups, and export to the formats I need. Finally, I rig and animate the character. And this is the example, small example. This is a 3D animated character that AI helped to generate, and it was based on 2D character created by a human. Virtual office assistant, writing and organization. A lot of studios need help with office work, not just game content. AI can summarize meeting, capture decisions, and list action items. It can draft internal docs, release notes, and change logs in a consistent format. It can turn messy notes into a structured task list. And it can help keep plans and schedules organized. If you want consistency here, you can also do this through a custom GPT that has your templates and your preferred structure. This saves time and reduces mistakes as long as you review it. Virtual translator, localization support. This is a good example of junior scope work because it has defined input and you can review the output. Personally, I used to pay for human translation services. Now I do all of my translations work with the AI and I keep iterating with it, not just once. I ask it to adjust tone, shorten strings for UI, and keep terminology consistent. For verification, I use back translation and also cross-translate into another languages I know to see if the meaning stays stable. I also do a quick sanity check with Google Translate. Then I still spot check in the actual UI because that's where length issues show up. Another role AI can cover is part-time instruction. AI is a part-time instructor. When you learn a new tool or workflow, the slow part is often getting started and understanding the IDE. AI can explain concepts, compare approaches, and give examples, provide step-by-step instructions. It can also help debug understanding what you think is happening versus what is actually happening. You still verify things in the real environment, but it can remove a lot of friction and lower the learning curve. If you were giving work to a junior hire, you'd give them the input, you'd tell them what output you want back, and you'd list the rules they must follow. You'd show 1 or 2 examples of what you consider good result, and you'd tell them how you are going to review it. That same approach makes AI output more predictable and easier to accept or reject. Review checklist. 5 quick questions. When you get output back from AI, I like to run a short review in my head. First, is it correct? For text, does it mean what intended? For script, does it run and do the right thing? Second, is it consistent? Does it match my internal code convention, term list, and the look and tone of the game's IP? Third, does it fit? A translation can be correct, but it still not fit the UI. A script can look fine but fail in the real folder structure. Fourth, do I understand it? When we talk about code, I need to understand what it does, generated code. I need to understand what it does and how. And fifth, what could go wrong? That's where you catch brittle scripts, wrong claims, weird wording, edge cases. I keep it to 5 questions so I don't overthink it. It's just a repeatable way to avoid accepting something that only looks good at a first glance. What should not be delegated? Some work stays human-owned because it defines the product or carries serious consequences. Core intellectual property creation and final art direction define the identity of the game. Product vision and final creative choices need stable human taste and intent. Also, in a studio, balance and economy decisions can damage a game in subtle ways if they are wrong. Another thing is security and privacy sensitive code needs careful judgment and testing. Legal claims, contracts, and crisis communication need responsible ownership. And at the end of the day, the decision what ships stays with the human team. Where the junior team idea helps and where it breaks. This framing helps because it fits real small studio needs. You can remove load without immediately adding headcount. Where it breaks is if junior is heard as low quality or as in comparison to students or human junior developers. Human juniors are accountable people. They learn, they ask questions, and they grow into owners. AI is different. It can be highly capable, but it doesn't own consequences. So the boundary is responsibility. Humans own direction and intellectual property, and AI helps with scoped work inside that direction. Treat AI as extra capacity for support roles, scripts, docs, translations, summaries, organization, code review, community drafts, QA, debugging, and variation. And keep direction and IP human-owned. Keep tasks specific and use a simple review checklist so output can scale without drifting. Thank you.
All right, we got all of our speakers back up there. We are prepping the esports demo outside right now. I believe Dylan will come back in and let us know when that's ready. And yes, I've agreed to come up here because Dub knows I got a lot of questions about the workflow side of things. Dub, you get to work camera now.
Okay.
You get to be the camera. Well, first, just make sure that I'm in camera. Michael? Yep. All right, let's start with questions from the audience. All right, well, I do have a number of questions that I'll throw out as well, so feel free to raise your hand if you have some. I'm going to start from the far left coming towards me. So the first thing I want to talk to all of you about is time, because all of this is about either adding time to what you're doing or reducing the time involved. So Anatoly, if you specifically, you've added AI into the workflow and you're doing this successfully already. So two-part question for you. First of all, how much time do you feel it's saving you, or is it just giving you more time to do other things? And secondly, how much time are you spending in review for your new junior assistant? For every hour or 8 hours it does for you, how much time are you having to spend reviewing what it's doing? Pass the mic down to Anatoly, please.
I try to be effective. So also when I work with AI, and it helps me, for example, in code generation, it helped me several times to solve like within half an hour. It's like not with the first try, but back and forth or debating. But it helped me resolve some complicated code that on my own, for example, 3D animation on Android, something like that. It's very complicated, and it's like in development by Google, and they use a third party, and so it's complicated. And on my own, I think it would have taken like maybe a week for me to like create on my own to code this. And
How quickly?
it helped me like with the first working draft, like it took me an hour. And also I used ChatGPT 4 and it didn't succeed, and while I was at it, ChatGPT 5 came out and it solved it. So this is one example, and I try to make it efficient, not to delegate tasks that I shouldn't delegate. Like I learned with time. I learn also with my own mistakes, but I think right now I am efficient. I know what to delegate, what not to delegate. So I think it's.
And how much time do you spend reviewing it? For every 8 hours it does, how much time do you spend reviewing it?
For example, with translations, I used, for example, I need to translate game description into 12 languages, and I used to review a lot, but with time I know I can trust it. I still review it, but I make like a sanity check, so it's short.
12 languages.
Yeah, I check like another language, and I check like I know besides English, or I take Google Translate and check it, and usually it's very good. It's like human translation.
I'm going to go ahead and answer that too. So I've been using it. He uses it for game. I've been using it for programming for about a year. I first started playing with GitHub Copilot, which was great, and it fits into your Visual Studio. It's a code assist tool. It's not an AI. To me, it's just a code assist tool. Then they started talking about vibe coding like 7-8 months ago. I was like, okay, what's going on here? So as I've been playing, ChatGPT helps me with brainstorming. It helps me with rough drafting. It helps me with gathering parts and pieces. It does really good at educating me. I was like, hey, give me a 1-hour summary of a blah, blah, blah. Because I used to do WordPress, or I might have done Drupal, or I might have done something else 10 years ago. Where's it gotten to now? So I can update my knowledge. So when it talks about code, I use Claude, and I'll write my code. I'll use my Gemini to write my user scripts, my user testing. So I'm not using one to do the same. I'm doing cross-board so that I'm verifying it. Now, the answer of 8 hours of work in a 4-hour block is what my evenings are. I will spend about an hour going through it with a fine-tooth comb, because sometimes as a junior, you realize a junior, you're like, I'm an architect. I've seen it. I've done it. I coded it. I don't like the way that guy wrote it. I'm going to tell him to rewrite it the way I like it. And as an architect, that's my prerogative. So it wrote the code, and I'll spend an hour going over it, which in an 8-hour day, when I was working with my 40 developers in India, I might spend 3 hours in that day looking at all of their code as they've checked it into code reviews, right? So I'm still testing it. I'm still getting it used to me. So that's the...
So, Michael, I had another question for you. So, we're talking about all the data you're generating, because that's the big focus we're talking. We actually want to be able to use this data. And for a lot of my friends, they talk about the more time you spend in data analysis, the less valuable it is. There's a quick decline in the value of each hour spent. With the data you're generating, is there a point at which you're getting diminishing returns evaluating it? And what sort of data is the most valuable for you out of it?
Good answer is, I don't know. That wasn't my particular area. I wasn't really looking at it. And we were generating data. It's getting dumped in the S3 buckets. It's getting dumped into MySQL. It's getting dumped through conversion scripts over into no, different database. It's not Mongo. It's the Amazon version of a Mongo. No SQL. What? Dynamo. Thank you. So we're pulling parts and pieces around. We didn't get into doing heavy scripting. We wrote scripts that could give data analysis. That was write scripts that do this for the owner backend, right? The business owner wants to know what's going on, seeing that stuff. We wrote a bunch of those scripts, but we're not doing ad hocs on the fly. We're not digging around. We wrote some scripts that we think they need, just like the guy with the firewall. So we're going to go talk to them. What data do you need for your business? Okay. Can I ask her? Let her ask her question because I saw her had a hand up. Go for it. Okay, so leave that question there. So I'm going to repeat it back. So like Andrew was asking about data analytics, right? So I started with data analytics with web trends, web analytics, way back in 98. Okay, so web trends was this, then it was this, then it was this, then we went to Google Analytics. So it's all about like looking at large blocks of data and seeing where it's going, right? So the same thing you're doing, they do have, if you're a YouTube creator, they have analytics tools, right? What? So can we take these concepts, if they brought us in and said, hey, can you come in, bring your tooling set, bring your big picture into this, can we help them? Yes, we could. Right now, I don't know. I'm exploring that because I'm always looking at, because of my longevity of always ride the front wave, always find out what's going on. So there is that concept of analytics is about money, right? So I'm always trying to help a business make money. That's how I get paid to play on computers for the last 40 years. Did you have a second one? And like I said, I really like using them as a junior tool. Sorry, I'm not.
So there are multiple places where you can get live marketing data from. They target Steam. So one is vginsights.com. They are mostly like they pull their data from Steam and also the community itself. There is a website called gamestats.com that tracks the estimated revenue per tag or per genre. And there is a really good website called How to Market a Game, and they have a very active community that report their own financial data, and the owner of the website puts that up, that runs the analytics. So some of the data that I showed was from VG Insights, some of it was from How to Market a Game, some of it was my own research using GameStats.
Yeah, How to Market a Game with Chris Zukowski is the most accurate. The rest I know based on my own game numbers that there's a wide variance in them, but they're still like the best rule of thumb stuff out there.
So when we're talking about, like he mentioned, live streams type of thing, if you go to data analytics, right, we're looking at web trends or marketing, stuff like that. So web trends is doing one thing. It's telling you where they're going, what they're doing. The other side of the coin was the SEO, the search engine optimization. How much do I need to pay to get this keyword out there? And we don't want short keywords, we want long keywords, but what's the right word you want to buy if you're trying to get marketing advertising? So Facebook, Facebook ads, right? So I want to target that guy. I want to target that guy. And that's how they did the political elections, is they sat down and they looked at the demographics, they drilled down and they said, we need to buy that block of that vote. We need to buy that group of people. And you just target them and target them and target them.
And Mehdi and I have both been very open about showing our Steam numbers. So if you ever want to see them, we're glad to open the dashboard and let you check them out. Tyler in the back.
Yeah. So the question is, how do I feel about the essential tools that you have to use that have a subscription, and they're not necessarily tied to the success of the game? Is that correct? That is fine. That's your choice. I was mainly talking about these emerging tools that are trying to get you to migrate to them, to say, okay, if you migrate to this particular tool, it will generate an open world for you, for your open world game. And that decision, whether or not you use that tool, is still a valid decision. It's just, from my point of view, it is a dependency, and it specifically becomes a bad dependency because when you make that choice, when you do that migration, you make a deal with them. You either pay a subscription, you pay upfront, or they take royalty out of your game, which means even if you do not succeed, they can take money out of your project, and that is a bad dependency because it makes your loss worse. I hope that answered your question. Yeah.
So you're all indie developers, and you just had this very sobering presentation about the likelihood of indie. Do you think AI and discoverability or publishing or things like that is going to evolve? Because I talked to a lot of people and they seem to be very optimistic about the indie scene, or the global indie scene, but they're saying that there's not a way to make this very small chance. Is that just the way it's going to be? It's like kind of a one-hit wonder kind of thing, or do you think there's going to be sustainable models in basically all of it?
I think personally that there is sustainable models that you can actually succeed, but it's never going to be with one game. You have to keep trying. You have to do your research, look at the statistics, and build with a plan, and not be betting all of your life savings or all of your time on one thing. I personally have 3 different projects that I'm working on at 3 different scales. So I have a project that's ready in next week and I can ship it, but I am choosing to spend a little bit more time on it. I have a medium-term project that's going to take maybe a year. I have a very long-term project that I'm probably never get to make until one of my projects makes $2 million or something. So it's about operating at different scales. And discoverability is an issue, but not as big as you think. Because a lot of let's take Steam, which is something that I've studied for a bit. Steam, what they really do is they curate. It looks like everybody has a fair shot. You could put your game, if it's but that's not the case, because if you go look at any Steam game, and you scroll down to the bottom, it always is promoting the games that's making Steam money. And if you go look at a cozy game, it's going to show you the 8 most money-making cozy games. And the secret sauce is try until you get one of those hits. And when you do, Steam is going to make a crap ton of money for you. And that's how you get sustainable.
And let's also be very clear. We're looking at Steam here. We're not looking at the console stores. We're not looking at mobile. We're not looking at all those. Comparing this to 95, when we started HCI, we did Machiavelli in 94, Everything Sons. 1,000 successful games is amazing compared to the few hundred you would have at Software Etc. Electronic boutiques of everything, of console and everything combined. 1,000 successful in 1 year would have been amazing. So I look at that number, 26,000, 25,000 launch in a year, 1,000 successful. Just look at 1,000 successful. 20, 30 years ago, that was mind-blowing in the sheer scope of the whole games industry now. 650. So when we're looking at the numbers, I see that as actually very promising, because that is a whole lot more than there used to be, and a whole lot more indie. I mean, we consider our studio indie, but we still needed publishers. We had Take-Two publishing us, everybody else. The fact that you can do that without a publisher is mind-blowing. So one company that did that was it, and they still needed good time software to really get to those numbers. So it's extremely promising for me.
I just have one more thing to add to that, and that is Steam actually is the best tool if you're looking for an indie studio to become completely self-sufficient, because it's possible that you do the research, target one specific niche, and build a game that no one has ever heard of, and that game that no one has ever heard of makes millions of dollars. And that happened to me. And actually, one of the Siege sessions, I was networking with some guy who just came by my booth. I was showing Lightbreak, and we exchanged information. And I said, "Okay, what game are you working on?" And he named this obscure game that I've never heard of. And I looked it up, and I was like, "Oh, cool! It's like a little like anime girl game or whatever." And I brushed it off. But then when I go home, I go check all the cards and all the information I get, and I looked his game up. Dude made $3 million. And it's like one person, so like that you're set, and Steam gives you that chance.
But he's still writing more stuff.
Yeah, he was working on more games.
So that's where I wanted to go with the same with, think about book publishing, right? So authors that they get a book published, they don't publish just one and then they're done. They keep publishing and publishing. So they got a lot of garbage out there. And every once in a while, and then they find the secret sauce, then they make a bunch of good ones. But then what happens is the other ones seem to come up in value as well, right?
All right, we got two last questions, I guess. All right, I think we got time for 2 questions, then we'll go to Valorant. All right, let's go in the front of the back. Or Tim, was it you? Well, let's give our keynote for tomorrow the last question. Let's go over here.
There are so many Steam players, and the key slide that I showed was in the VR section, where depending on the genre, that 3% could be 20%. It could also be 0.27% or something. It depends on what you decide to build, and that probability is like if you say I'm gonna make a like open world survivor craft game, and you make that in 8 months, there's probably a good chance that you're gonna make some money. If you make 3 in like 3 years, there's a very, very good chance that you're gonna make money, because it's like the interest in your studio, the interest in your games compounds, and your skill at making that game compounds. So you get better and better and better. So there are these little bubbles on Steam of communities around a certain game, a certain genre. So like right now, narrative games are very hot on Steam, but there are like thousands and thousands of narrative games. There is a community around horse games.
Horse game sale right now.
Yeah, there is a horse game sale. Games that involve horses.
Very popular genre. Chris Zukowski will go on about how everyone should be making a horse game, just because it is such an underserved community. But I think the most telling stat was the median he showed of half the games are making under 500. That's great, but that's including every student game. That's including every game that's not really finished. That's including every game that's free to play anyway. So that means half of those games made more than $500. I find that very promising, and they keep going, and they'll be doing better, and they'll be doing better. All right, last question to Tim.
everything faster for everybody, the time to market's gonna, I don't know what it's gonna do, but it's gonna be less. Do you think that that's gonna raise the success rate for everybody? Or is there an X and a K factor that's hidden inside there that we don't know about yet, that as everyone starts to do 3, 6, 8 months, it doesn't change how much we're
The question is there a minimum in how fast you can ship a game? Yeah. And yes, there is. Because I could use AI to generate a Red Dead Redemption 2 this evening that I when I go back home, and I can release it this weekend, and nobody would ever hear about it, because the game, any game, needs to go through a marketing cycle. So like you need to post about it, you need to send to websites about it, you need to participate in Steam festivals, do Next Fest. That takes time. That takes planning. So like right now, like there are like 10 festivals on Steam that are gonna happen in the summer that are right now taking applications. So if you are building a game and you're planning to release close to the summer, you have to go there, and like you have to plan for it. And AI can make a game in 5 hours, but cannot do the marketing for you. Like humans need time to be familiar with things.
So I think the other important part of this is that just like when we've sold the boxes, most of your sales are in those first few months. That is still true. However, the long tail now is so much better than we had when we had boxes in stores, because those boxes eventually left the stores and there was no more tail. Now that long tail goes on and on and on and on, and that's why Mehdi's idea of multiple releases that are linked is so valuable. So make sure you wishlist Machiavelli the Prince on Steam right now and buy Emperor the Fading Suns. But in all seriousness, that long tail for something that comes out in 6 to 8 months as opposed to 2 years, it's still just going to have that blip at the beginning, but if it's good, you now have a tail that can continue and continue and continue, and we don't know where the end result of games like mine released in 94, 97, when they'll stop selling.
And finally, the Steam actually does that for you. So Steam looks at a lot of things, and one of the things that Steam looks at is playtime. So if you make a game that is attracting a lot of playtime, Steam will the algorithm will continually push it to other people who might enjoy that game. So like if you go to SteamDB and look at Andrew's game, it has a sinus wave. Like the amount of people who play it is like sinus wave. It goes up, some people stop playing it, it goes down, some people stop playing it, Steam starts pushing it back up. So it's like a sine wave. And a lot of the games that do have this like continual community, Steam keeps pushing them, and they continue making money.
And with that, let's take a break. Let's enjoy some Valorant. Let's go to 10. Sorry, Anatoly. And let's go to 10 Lizzies afterward. Thank you all very much. And tomorrow, remember, Tim speaks. Sorry, Anatoly. I didn't realize. Say it to the camera. They want to know. Folks on YouTube, give it to YouTube.
Fine, it's fine. I wanted to say about many AI-generated fast art, especially in videos, animated videos. There are a lot of copyright violation there. So, and it's a matter of time until it becomes demonetized and throttled. So these games that generate art, generate videos, it's a matter of time. It's like 1-2 years.
That's a great point. Thank you. See, remember everyone, tune in tomorrow, and if you can't tune in tomorrow, join us live.
this AI team? Maybe.
Yes, 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 yes.
And he was thinking outside the counties, the Texas criminals are all saying, but you go past that, Douglas. So we got Forsyth, we got Fulton, right? But the next, what's right above Forsyth, right? And so what about White County? What about Cherokee County? They're not attached to, so if they're not, Cherokee is not, Cherokee has a high side. Cherokee has a totally different plan.
It's in between you gotta worry about.
Is anyone talking?
Sterling, we're going to use two microphones. I'm going to hope they don't feedback each other.
Okay.
So this is for my stream. It's showing your stream.
Okay.
And this will be so people in the room can hear us.
Okay.
All right, so this is still Andrew. Hello, everybody. This is Sterling. He's esports coordinator for Kennesaw State University. And this is Valorant. So I imagine a number of you recognize, at least this one if you don't recognize us. But we're going to talk a little bit about esports in general and about AI's role in esports these days. So Sterling, tell us a little bit more about yourself and about the program here.
Sure. So a little bit background on me. I started in esports in 2006, back when it was very much a grassroots initiative. I spent time as a semi-professional and professional player both across 4 different titles. And have built, this will be my second collegiate esports program that I have built from the ground up. Proud to say at the last one we were able to earn a national championship, and those are the ambitions here. As we see it, Kennesaw esports is very much in its infancy, and this is kind of just the beginning. Something to know and highlight about this program is that both the teams you're seeing now are some of the strongest Valorant programs in the entire country. And these things were built completely by students and the students' desire to make it happen. And now that Kennesaw has seen that and gotten excited about that themselves, it's our ambition now is to help these kids propel the program forward. really, I want to open this to you guys with questions about maybe esports in the collegiate space, the professional space, or how I see AI getting involved in the future. I'm not going to pretend that I am an AI expert, but I do have experience from a coach and a professional player perspective, and have thoughts on where I think I'll see it the most.
Well, let's go and sit down here because my feet are tired. And I wish we had anyone who'd ever been at Ryan to talk more about Valor.
Well, we know.
Wait a minute, why did I do that? We have a streaming mic. We'll just go with the streaming mic. You all can
Hear us because Sterling and I are loudmouths. So, we think of esports as being that human and the computer together. We don't usually think of the AI side. We think the AI is kind of the balancing factor. AI on all teams are even. But that's not really the case, because your knowledge of how things spawn in the games, how things appear and so forth is key to it. Your familiarity with the game, you're familiar with how I'm going to go back to Warcraft, to the original Warcraft as an esports title and StarCraft as a title. Your understanding of pathfinding was key to your success. If you knew how your Zergs would rush, if you knew where they would come so you could set up your towers appropriately, you were going to win based on your familiarity with pathfinding. So let's start with the low-hanging fruit. As a player, what do you need to know about the game in order to succeed?
Everything. I mean, if your ambition is to be professional, you really can't consider this the same kind of motivation that any traditional sport would take. You need to spend time perfecting your craft. For every minute, every hour that you're not spending that doing that, there's somebody else is. I can give you for instance, in my personal playing experience. I'm older, so the game I'm going to reference here is Halo 3. Halo 3, right, one of the biggest factors on a map when you're playing a game are the power weapons. So a sniper rifle, a rocket launcher, things like that. Those things are on, in Halo 3, they are not static timers. The timer itself is going to be the same every time it starts, but when that timer starts, it's completely dependent on the interaction with the weapon on its initial spawn. So one of the tricks that was really cool to use, if you had a team that could understand it, track it, and everybody be on the same page about it, is if you were at the position of a rocket launcher as it was spawning, and you were able to pick it up before it actually touched the floor in the map, that means that timer would not start until you stopped moving. So now you can give you and your team an advantage on, okay, I'm going to mess with this timer, and I'm not going to stop moving until 7 seconds. Let's make it really weird. So now the next time the spawn comes up, my team knows that it's not going to be up immediately, and we're going to have a little bit more time to work with. So again, little details like that, if you're not perfecting those things and paying attention to those things, those are the separators between a professional player and somebody who does it casually and for fun.
All right, so now let's talk about roles of AI from outside of the game, mainly in doing that analysis for you. So I've been talking in esports for years about how do you appropriately coach esports. What are you teaching? You're teaching them teamwork, you're teaching them communication, you're teaching them headshots, you're teaching them planning. What are the main areas you coach, and where do you see AI coming in to help the coach?
Yeah, oddly enough, I think coaching is also a perspective thing too, much like in traditional sports. Me as a coach, I spend a lot more time focusing on the mental aspect of the game and how we're handling our preparation time and how we're handling our frustrations and our losses and how we're using those to keep moving forward. At the same time, how we're handling wins and what our culture is like when it's time to just put some work in. So for me, right, specifically where I see AI coming in the most is to help in the strategizing and the preparation piece. Every team has tendencies and favorites and things like that. We'll take Valorant, for instance, as we're watching it. The entire purpose of the game is an attacking team and a defending team exist on the map. The attacking team is given 2 or 3 areas where they need to plant a device and let that device go off. And the defending team's job is either to eliminate all of the attackers or defuse that device after it's been planted. Every team has different strategies and preferences on which site they like to use and which one they're better at defending. And where I think AI is really going to help coaches and analysts in the future is being able to use tools like that to predict your opponents and prepare for your opponent's tendencies. Again, I'll use the reference much like they do in traditional sports when they're breaking down percentages of run versus pass in football, or if they're hitting weak or strong-sided in football, where are their favorite spots to be? I think it's going to implement the same kind of thing in esports.
All right, well, let's dig a little bit more into those analytics, because in games we can analyze everything, and we do analyze everything. And you as a Valorant coach have had access to those metrics for a while. What do you want AI to help you with when you're digging into players' metrics?
I want AI to help me with exactly that. I want to know if my team is on an eco round in Valorant, which, so you guys understand, is a disadvantage round, meaning we have less money to buy equipment at the start. And I know the team has that advantage going into the round. A good team will be aware of that, and a good team will have a strategy they prefer to do in that situation because they think it leads to a higher percentage of win. So I want AI to be able to help me with, okay, my team's on an eco round, the other team is in an advantage. What is their preference and their tendency in this situation? That's the kind of information that I would love to be able to equip my players with.
Can AI analyze the training films, or does it have to actually get the full game viewing?
I think there are certain things AI can analyze about a film review. Definitely like crosshair placement and accuracy percentage, and maybe how to help a player fix mechanics as they move, and maybe the routes that they're taking. There are some things, though, that I think have to be left up to the human eye. I think a player is only really going to be able to explain to you why they made a move at the time that they made that move, because more than likely that was being based on something that their teammate was doing, something that they'd heard, something that's been communicated. Again, not to say AI can't get into that in the future. I just think those are the things that you need a human's perspective on. And I don't know that piece will ever go away.
Now, the games I make are all, you've got humans versus AI, or all humans versus humans, but there's a lot of human versus AI in my games. Do you see games incorporating AI more effectively so that AI can be part of the esports component? For instance, a human and an esports companion versus a human and esports companion. And while you address it, I'm going to go fix my camera.
Yeah, I think there's a lot of interesting tools that AI could be turned into for a player personally. Some of those exist already. You can go to platforms like, if you guys ever want to explore, there's a platform called Overwolf. And on that platform are a bunch of different apps that players can download for different games that have different, decision-making metrics built in and different goals. Some are as simple as helping you buy the correct items in a game like League of Legends based on your character. Others are for games like Valorant to show you different kind of strategies and setups for different things. And some of them are built specifically for that, to record and track your gameplay and to provide you some analytics post-game and let you decide how to improve on that. So I think we'll continue to see things like that develop. I think that is kind of one of the cool things about AI, in my opinion, for esports is it has led to all these really cool tools that you as a personal player can take advantage of. Even away from the team setting, it's really just about whether or not you have the initiative to go seek those things out right now and take advantage of them.
All right, let's talk about the most important aspect of esports, the shoutcaster. Yay! But seriously, AI can be a big help for the shoutcaster. Shoutcasters miss stuff. AI can be giving them information. In pro sports, there are a lot of experts in giving info and quick blurbs to the commentators all the time. Except at the highest levels of esports, we don't really have that, those giant staffs of experts saying, hey, talk about this next. So do you see a role for the AI in helping the shoutcasters?
Yeah, absolutely. I think one of the most interesting pieces, or one of the pieces of a cast I enjoy the most is always is kind of like the stat breakdown going into a map. Like, this team has this win percentage on this map in this game mode. Or this particular player has, this tendency or has played this side of the map, this percentage of the time that they've played it. So I think things like that are super interesting in a cast. Like you said, professional casters just have the benefit of having a producer in their ear kind of feeding them that information. But making things like that more accessible to programs like ours, right, where it's student-led and it's student-driven, making things like that available to them to, improve and get better at what they're doing and what they're trying to perfect is, I think, hugely important. And I think it can go a long way in helping casting.
Let's talk about another area where AI is already impacting esports and which all of us game devs are very interested in, and that's the communities. And we know we're seeing bots already in those communities creating issues, trying to build support, and more usually to troll, to create issues. Have you had to encounter this in any way, and what are suggestions from you to people who have communities that are being inflicted by bots?
Yeah, we definitely have this problem. We have this problem in the Kennesaw Esports Discord right now. I think I ban at least one person a day right now who's in there giving away a brand new PS5. You just got to call them and come pick it up. It's how do you fix it right now? Right now, I just let the students report it to me and ban it. How do you fix it in the future? I mean, again, not an AI expert, but I definitely think there is a world where we can build bots to help recognize other bots.
Bot battle. Battle bot.
There was a show about this, right? For long. Yeah. Okay. So yeah, maybe we just make the AI and digital version of that. And I think, how do you do it? I don't know. I think the Discord API is relatively easy to get a hold of to assist in that kind of thing. So yeah, if any of you want to develop that AI for me and let me put it in the Kennesaw Discord, just let me know.
If only we had a Discord developer here. Where's Tim? All right. No, that's pretty fascinating stuff. Now, what are the teams you have at KSU? What games do you play?
Yeah, so our teams operate in two different tiers. One is Premier. You can consider that our version of a varsity athletics team right now. In that level, there is League of Legends and Rocket League. Historically, so far at Kennesaw, two of our better performing teams. One of our players on our Rocket League team actually was a Season 1 world champion. He goes by the name of Kronovi. Super happy to have him. We're glad he decided to join us. Past that, though, there are also a bunch of, like you're seeing right now, student-led and student-driven competition clubs. So inside of those clubs, the students get to govern themselves in what leagues they're competing in and how they're picking their rosters and how they're forming their tryouts and how they're developing themselves. And we have Valorant, we have Marvel Rivals, we have Apex Legends, we have Smash Brothers, we have Rainbow Six. What am I missing? Counter-Strike. Yep. That might be all of them. I might be leaving one out, but it's very active.
I'll turn to you a question in a minute. But out of all those games you just mentioned, where do you think AI is being the most helpful for esports teams? And where is it being least helpful? Where are the tools the best? And where are they least useful?
If you're asking me where I think they're being utilized the most right now, it's probably going to be League of Legends, Valorant, and Counter-Strike. Mostly because those three games are very well funded and invested into from an organization and a team perspective. Those teams, they put a lot of resources into making sure they're enabling their teams for success. So, on the analytics and coaching side, there are definitely AI tools being used for, analysis and predictability and things like that. Again, that kind of thing is as esports develop individually with investment level and, infrastructure and resources, that's when you see those things kind of start to pop up. So I think, again, League of Legends, Counter-Strike, and Valorant right now are where I think I see it the most.
You got a question? Do you know about the new project from Razer?
Not as
side. You know what? Yeah, it's kind of like a little side. They like backseat game. It's kind of like an AI coach that they're trying to implement now. Do you think that would ever replace your job?
Yeah, no, that's a great question. Do I think something like Razer's Project Ava would replace my job? No. So, and I'll tell you why. I think that there is a place. I think there is a universe where that kind of thing happens in the world of like traditional professional sports, mostly because a lot of those professionals are older, right? They're more mature. They've seen a lot and experienced a lot. So I could see a world where maybe a professional league tries to do that kind of thing. I think they'd see a lot of pushback and a lot of really angry people, because again, you're immediately removing that expected and familiar human element out of coaching. Why do I think that won't replace coaches in esports is because our professionals are so young. I mean, you have kids going pro in games at 15, 16 years old, depending on what we're talking about. It's not just an improvement of skill that needs to happen with a lot of these kids. There's some serious maturing and growing up that also needs to happen. And I think if you as a coach or even a professional organization, I think if you are not putting effort into that and you are not making sure that these kids are growing up equipped for when this is done, because the average esports career ends right now 25, 26. You know, the older guys push it to 30. But even then, it's like even their communities are asking them to retire. So, these guys have a life to prepare for post esports. And so there's a lot of growing up that needs to happen during that career for them to be ready for that. A lot of these kids get handed a paycheck at 17, 18 years old, maybe 19 in some of these leagues that have some age restrictions now, and think they're on top of the world. And again, they're at that age where they think this isn't going to end. And I'm an esports pro now. I'm set. I figured out my career. Then that career ends. AI is not going to be able to replace what a coaching staff and a team management staff does for these kids at a young age. So no, I don't see my job going away. And I would make the argument the same in professional sports, like from a traditional sports perspective. I think removing a human coach from the scenario with everything else that a coach does for a player or a team, I think personally would be detrimental to teams on both sides.
So I'm curious about your team composition. So you've got students from all parts of Kennesaw State University. Kennesaw State University is a kind of tiny school of only about 50,000 people. So what majors represented? And more importantly, how many game developers, how many computer programmers, and how many AI developers?
So AI developers, I expect there to be a lot more now that Kennesaw has announced its new BS and AI. I think
no
that
jokes about BS and AI.
I think that will be something that drives, I mean, not just students to our program, but students to Kennesaw in the future. So I expect that number to definitely go up. Right now in our program, from what I've seen, and keep in mind I've only been here since December 15th, but from what I've seen so far, it's a lot of engineering, both civil and mechanical. A lot of comp sci, some psychology thrown in there. My experience at previous institutions is kind of the same thing, even more of a mix where I've got those same majors, but then I've also got biology and people there for like their business administration and marketing. And I also think that's the unique thing about esports that's kind of untapped as of right now, and what collegiate has put a focus on is it's not just about playing, right? Like every job that you imagine exists to make the NFL operate also exists to make the esports leagues operate. So, as that gets shared and as that's more understood at a younger age, and as we're developing the industry, because it's, again, I'm 36 and my generation was really the one that kind of created this whole thing. So now this younger generation has a chance to kind of get educated in the fields that were created and the job opportunities that were created. So I think across the board, there's an interesting group of majors that are interested in esports.
And as anyone who's played against a nurse knows, they are the mistresses of headshots. So expect to be taken out quickly. They know where it hurts. All right. So when you are creating a training regimen for a player, is there an AI component of that you give them separately from how you do their analytics?
For me, no. I'm not going to say that I don't like the idea of what AI can bring in the future, but as of right now, I'm still a bit stuck in my ways and old school, if you will, in how I coach and how I run my teams. I obviously definitely do a lot of stat tracking independently and on my own. And honestly, we'll probably start using some sort of AI tool to gather that kind of data for me just because it's tedious. But no, as far as training regimens and things like that, I keep that thing to myself and my staff. Just because, again, I think when we're deciding how to coach these kids at this level, I think their personalities and their motivations have to be taken into consideration. And that's not something that AI can do right now, or at least do well from anything that I've seen as, again, not an AI expert.
All right, unless any of you have questions, that sounds like a perfect note on which to end this, since it looks like we're over anyway. So any other questions? With that, thank you very much, Sterling, for joining us. Yay! All right, on to Tin Lizzies. Well, I'm going back to the hotel, and then on to Tin Lizzies. Thank you, gents.
Oh, of course.
How's Peach Belt Conference going for you?
Well, in Valorant, in Valorant, they're doing really well right now, and League of Legends doing really well with one team, struggles with another, but that's not in Peach Belt right now, I don't think. No, it is. League is Peach Belt.
What do you think of the Peach Belt champions? It used to be really cool. I don't know how they rate now.
You're talking about just like the championship event? I didn't get to see one last year, but I know for esports it was held here last year as well. And I know we're holding it again on the 34th. So my expectation is it will be good.
It was fun time last semester.
Very cool. Good to know. Sterling, appreciate the time.
No, of course. Yeah, it was great. Thank you.
Online, I'll have it up there. It won't be the best since I didn't have a camera person, but I'll share it with you.
Lisa, you hang out? What?
How many viewers do you get for your streams?
On Twitch, no, we're under a guess.
I think it depends per title.
Oh, really? It is title dependent? It's more title dependent than team dependent?
Yeah, I would say so, because certain communities are closer together than others, and some are just bigger than others. So you get Valorant that may get like 10 to 15 people watching at once, and then you'll get Rocket League, and it might be like 400
So,
people.
like Columbus State, can both of you stream it on your channels?
Yeah, if they want to.
In PB, in Peach Belt, which other schools get you the best numbers?
I don't really know yet, honestly. I think everything is pretty average right now, and particularly when we're playing teams inside the Peach Belt, it's more about which of our teams is playing than anything.
Got it.
As far as Peach Belt goes, we kind of are the draw, really, in that conference. But we started streaming on Twitter recently too, and we're getting like 80-ish on there, depending on the game. Last one I saw was still like 30 to 40, I think.
So when I started the Georgia Esports League, it was about creating those rivalries.
Yeah.
So I still really want the Georgia Tech, Georgia EGA rivalry to drive stuff here, but you guys in a GSU rivalry, better than a Peach Belt rivalry.
It's interesting because, like, so my experience in esports so far is that the athletics conference rivalries tend to matter a little bit less to the kids, but they definitely develop their own. Like so far from my experience,